We'll start with the udevadm command. The udevadm command is indeed used to work with the udev interface of the kernel and the device manager subsystem. Udev, this is the device manager for the Linux kernel. Let me type it for you. Udev, part of this command. It manages device nodes in the /dev dynamically. And if we add ADM part or administration or admin, this is a utility that allows us to interact with udev, query the udev database, monitor udev events, and more. Now let's dive deeper into the udev ADM command with some hands-on example. We'll explore its usage and see how it interacts with our system. First, let's start with a simple command to list all the attributes of a specific device. For example, we'll use a USB device or SDA. So we'll type udevadm space info and then --attribute -block space. And now we'll need to specify the device and its name. --name equals /dev SDA. I'll hit enter, but I'll get an error because I don't have such a device. But that's a very commonly used device. In case you have, you'll get an information on this device. So let me list devices I have on this system with ls bulk command, and as you can see, I've got VDA device. Let's try to rerun the previous command, but I'll change SDA to VDA. Hit enter, and as you can see, we get tons of information on this device. Let's break this down. So first we've used udevadm command. This is our main command. Then info. This is sub command. Actually, let me bring down the previous command for you to better understand it. So this it's a sub command. It tells udevadm we want to query the udev database. Next up is attribute walk. This option tells udevadm command to show us all attributes of the device and all its parent device. And finally, name dev VDA. This specifies the device we are interested in. In this case, it's dev VDA. It's on my system. You could use SDA or any other device you want to query. Now let's run this command again, and let's look at the output. We can see various attributes of our VDA device. For example, kernel, BDA. This is the kernel name for the device. Then subsystem block, here it is. This tells us it's a block device. Then attribute size. We can search for this attribute. Here it is. This is the size of the device. And all this information can be incredibly useful when you're writing udev rules or trying to understand how your system sees a particular device. Now let's try another useful udevadm command. I'll exit from here by typing Q and clear the screen by typing Ctrl-L, and we'll run udevadm monitor. Hit enter. So this command will start monitoring udev events in real time. It's very useful if you're waiting for some events like plugging in a USB drive to see what happens. So you could experiment with this command, run this command, and plug in a USB drive and see what happens. Now let's break down what we are seeing. The kernel lines show the events as they are happening at the kernel level, and the udev lines show the events after udev has processed. We can see the device being added at various levels of the USB hierarchy. If we plug in a device, And again, this real-time monitoring can be incredibly helpful when you're troubleshooting device issues or trying to understand how your system interacts with new hardware. Okay, now let's switch to another command. Actually, not command, but the configuration file, which could be useful for monitoring or troubleshooting your system. So, interrupts file. I'll type cat proc followed by interrupts file. So this cat proc interrupts command displays the contents of the /proc/interrupts file. This gives us a snapshot of the current IRQ assignments in our system. It's like picking at a list of which interrupts are being used by which devices. Pretty cool, right? Now let's dive a bit deeper into IRQ and the cat/proc/interrupts command with some hands-on example. First, let's run the command and take a closer look at the output. Your output could be similar to mine, but could be different, of course. When we run this command, we see something as on my screen. The first column shows the IRQ number. The next column, CPU 0, CPU 1, and so on, shows how many times each interrupt has been handled by each CPU core. So if I scroll up a bit, we'll find these columns, CPU 0 and CPU 1. The next column shows the type of interrupt controller, like the interrupts you see on my screen, IO LPIC, PCI MSIX, and so on. And the last column shows the device or driver associated with the interrupt, like RTC0, as you can see on my screen, PCI Express, and so on. Now let's try something interactive. We can watch how these numbers change in real time. And for this, we'll use watch command. So let me clear the screen and type watch-n1, so number of lines we want to watch, and then specify the file with cat proc interrupts and pipe it to grab command. And let's grab, for example, CPU \vertical line. That's how you ask grab to find some information in this file. And for instance, xhci_hcd, and we'll close double quotes. Let's take a look if we have such a line. And of course, I forgot to place closing single quote for this cat command. Hit enter again, and now we are observing the behavior of this file in real time. This command will update every second, showing us only the CPU header and the line for xhci_hcd. So in this command, first we use watch-n1. This tells the system to run the following command every 1 second. Then cat proc interrupts. This is our main command to show IRQ information. And grab part. This filters the output to show only lines containing CPU or xhci information. Now, if you want to go further, try to plug in a USB device while this is running. You should see the numbers for xhci_hcd increase. So this kind of real-time monitoring can be super helpful when you're troubleshooting hardware issues or just trying to understand your system better. And please remember that the /proc file system is dynamic. It's constantly updating to reflect the current state of your system. That's what makes it such a powerful tool for system administrators to know about. And of course, feel free to experiment with different grab patterns to focus on other devices you're interested in. We'll start with the udevadm command. The udevadm command is indeed used to work with the UDEV interface of the kernel and the device manager subsystem. UDEV, this is the device manager for the Linux kernel. Let me type it for you. UDEV, part of this command. It manages device nodes in the /dev dynamically. And if we add ADM part or administration or admin, this is a utility that allows us to interact with UDEV, query the UDEV database, monitor UDEV events, and more. Now let's dive deeper into the UDEV ADM command with some hands-on example. We'll explore its usage and see how it interacts with our system. First, let's start with a simple command to list all the attributes of a specific device. For example, we'll use a USB device or SDA. So we'll type UDEV ADM space info and then -- attribute -walk space, and now we'll need to specify the device and its name. -- equals /dev SDA. I'll hit enter, but I'll get an error because I don't have such a device. But that's a very commonly used device. In case you have, you'll get an information on this device. So let me list devices I have on this system with ls bulk command. And as you can see, I've got VDA device. Let's try to rerun the previous command, but I'll change SDA to VDA. Hit enter, and as you can see, we get tons of information on this device. Let's break this down. So first we've used UDEV ADM command. This is our main command. Then info. This is sub command. Actually, let me bring down the previous command for you to better understand it. So this info, it's a sub command. It tells UDEV ADM we want to query the UDEV database. Next up is attribute walk. This option tells UDEV ADM command to show us all attributes of the device and all its parent device. And finally, name dev VDA. This specifies the device we are interested in. In this case, it's dev VDA. It's on my system. You could use SDA or any other device you want to query. Now let's run this command again, and let's look at the output. We can see various attributes of our VDA device. For example, kernel, BDA. This is the kernel name for the device. Then subsystem block. Here it is. This tells us it's a block device. Then attribute size. We can search for this attribute. Here it is. This is the size of the device. And all this information can be incredibly useful when you're writing UDEV rules or trying to understand how your system sees a particular device. Now let's try another useful UDEV ADM command. I'll exit from here by typing Q and clear the screen by typing Ctrl-L, and we'll run UDEV ADM monitor. Hit enter. So this command will start monitoring UDEV events in real time. It's very useful if you're waiting for some events like plugging in a USB drive to see what happens. So you could experiment with this command, run this command, and plug in a USB drive and see what happens. Now let's break down what we are seeing. The kernel lines show the events as they are happening at the kernel level, and the UDEV lines show the events after UDEV has processed. We can see the device being added at various levels of the USB hierarchy if we plug in a device. And again, this real-time monitoring can be incredibly helpful when you're troubleshooting device issues or trying to understand how your system interacts with new hardware. Okay, now let's switch to another command. Actually not command, but the configuration file, which could be useful for monitoring or troubleshooting your system. Understanding kernel module loading. So we use modprobe command. Let me type it for you. Modprobe. And by the way, we don't need this P here. Modprobe. And this command is not only loads the specified module, but also its dependency. It's like a smarter system that knows what your module needs to work. And it also checks for conflicts and prevents loading incompatible modules. Now, let's dive a bit deeper into kernel module management with some hands-on examples. So first we could check what modules are currently loaded on your system. For this we'll use ls-mod command. Hit enter and we'll get all the modules listed and available in our system. This shows us the module name, its size in memory, and how many other modules or processes are using it. Like this, dm_mod, the memory it uses, and how many other modules using it. Now let's try to load a module with modprobe. We'll use the loop module as an example. I'll clear the screen and we'll type modprobe loop. And of course we'll need sudo privileges to run this command. Hit enter, and now this module is loaded. As you can see, there is no output, but it means it loaded successfully. And we can verify it with the following command: ls-mod pipe grep loop. Hit enter, and now, as you can see, this module is loaded. Now we can try to remove a module with sudo rm-mod command. So I'll type sudo rm-mod loop command. So now we'll get module loop is in use, error message. That's how you remove a module with rm-mod command. In case you want to troubleshoot a bit the loop module, you should first check which loop devices are in use. You do this with sudo allow setup -a. And as you can see, it's used by snapd, and you'll need to detach the devices before you can unload the module. For this, we'll use sudo allow setup -d command, and we'll need to provide the path to the device. Example this one. Sorry, I'll need to copy the device itself, not the directory. So I'll paste device name here, loop 1, and you do this for loop 2 and loop 0. Now you could try to sudo rm-mod loop. Again, it's in use. Let's list it, and seems like snapd automatically attaches the following devices. But that's how you use rm-mod command and you detach loop devices. We could try to remove the module and their dependencies. Let me clear the screen and type sudo modprobe -r and followed by the module we want to remove. It's loop in our case. Again, we get this error, module loop is in use. But this command will remove the module that was loaded and its dependencies if it's not being used, as in my case. In this lesson, we'll walk through the process of installing the BTRFS file system module and its utilities on Red Hat Enterprise Linux system. This module is taken as an example. It could be any package you want to install and troubleshoot on your system. This task will introduce us to various package management concepts and troubleshooting techniques commonly encountered in Linux administration. But before we dive into the technical details, let's outline what we aim to achieve in this lesson. By the end of this session, you'll be equipped with several crucial skills. First, we'll attempt to install kernel module and system utilities. Then we'll troubleshoot package availability issues. Then we'll manage repositories in RHEL system. And we'll add alternative package sources. And finally, we'll install and configure Snap Package Manager. These objectives will not only guide our learning process, but also provide you with practical hands-on experience that's valuable in real-world Linux administration scenarios. Now, some words about key concepts used in this lesson. To achieve our objectives, we'll be working with several fundamental concepts in Linux system administration. Understanding this will be crucial as we progress through the lesson. We'll be covering basics of kernel module management, DNF package manager, RHEL repository and subscription management, alternative repositories such as Code Ready Builder and Appel, and Snap package management. As we encounter each of these concepts, we'll explore its role in our task and how it fits into the broader landscape of Linux system administration. This approach will help you build your comprehensive understanding of package management and system configuration in RHEL environment. Now, what challenges and solutions will be covered? Throughout this lesson, we'll face several challenges that are common in Linux administration. Here is what we'll be up against. First, we'll encounter BTRFS module unavailability. We'll start by trying to load the BTRFS module only to find it's not installed and compiled for our kernel. Then we'll encounter package unavailability in default repositories. When we attempt to install BTRFS utilities using DNF, we'll discover they are not in the default repository. Repository management. To solve the package availability issue, we'll need to ensure additional repositories and update our system. Finally, alternative package manager setup. We'll explore using Snap as an alternative method to install BTRFS utility. For each of these challenges, we'll implement step-by-step solutions given your practical experience in troubleshooting common Linux administration issues. So let's get started. For example, if we load the BTRFS file system module, let's do this with the previous command, sudo mod prop BTRFS, hit enter. And as you can see, the BTRFS module is not installed on my system, or the module might not be compiled for this particular kernel version. To address this, we can try the following troubleshooting steps. First, check if the BTRFS utilities are installed. We'll type rpm-q btrfs-prox, and now as you can see, package BTRFS prox is not installed. So if it's not installed, we can install it with sudo dnf install BTRFS prox. That'll check subscription management repositories and search for this package. And as you can see, we get no match for BTRFS prox. Now, as it appears that the package BTRFS prox is not available in the default repositories for my RHEL 9 system, we could also troubleshoot the situation with the following steps. First, let's make sure the repositories are up to date. So I'll clear the screen and type sudo dnf clean all. Then I'll type sudo dnf repo list. Not list, but list. And we've got only 2 repositories on this system. Let's double check it. I'll run sudo dnf search again for BTRFS. And as you can see, we've got no matches found here. So let's try to add Code Ready Linux Builder repository. BTRFS utilities might be in this repository. And we can enable it with the following command: sudo subscription manager wrappers -- enable, and I'll paste the repository link here. I'll click allow to paste. So it's code ready builder for L9. Hit enter and we'll try to add this repository. It's fetching some content, updating statuses, and now a repository code ready builder for L9 system is enabled for this system. And let's try to install BTRFS procs again with sudo dnf install command. Now that will try to search in this code ready builder repository. And again we get no match for argument BTRFS procs. One more step we could do is to use EPEL or extra package for enterprise Linux repository. So I'll type sudo install, and I'll paste the link for EPEL repository, which I found in the internet right now. As you can see, it started to add EPEL, and now we'll need to hit yes to add it. And when it's completed, let's try the third try with sudo dnf install BTRFS procs. Again, it will start searching for this package in all repositories. And by the way, what I forgot to do after adding the EPEL repository with this command, I forgot to run sudo dnf upgrade. I don't think that it will help to install BTRFS procs, but that's what you should do after you add EPEL repository. And it found 9 packages to install and upgrade to 61 packages. Okay, I'll hit yes. That'll take some time to do. Now we can also use BTRFS snap. After we upgrade the system, I can install snapd. Snaps are applications packaged with all their dependencies to run on all popular Linux distributions from a single build. They update automatically and roll back gracefully. And snaps are discoverable and installable from Snap Store, an app store with an audience of millions. And we'll do this after this upgrading process when it is finished. As you can see right now, we are upgrading package 39, so it'll take some time, and when it's done I'll get back to you and we'll install Snap. Now, the system finished to upgrade. I've shut down after the upgrade process and made a snapshot of this system. So if you go to virtual machines, as you can see, I've added one more snapshot. The description added repos code ready and EPEL and performed upgrade of this system. So let's continue with installing snapd. I'll clear the screen here and run the following command: sudo dnf install snapd. It takes 65 megabytes in size, so I'll press yes to download the packages and install them. Hit yes again, and now we get the result: installed Snap 4 packages. Once installed, the systemd unit that manages the main Snap communication socket needs to be enabled. To do this, we'll run the following command: sudo systemctl enable with now option, and will provide snapd.socket name. Hit enter. It created symbolic link, and in case you need to enable classic Snap support, you could enter the following command to create a symbolic link between var-lib snapd snap and snap directory. So let me type it for you, but I won't be running it. You'd run sudo link command -s, then the following path: var lib snapd snap, and you'll link it to /snap path. Let me comment this line. So that's how you enable classic snap support. Now we can go ahead and try to install BTRFS procs using snaps. To do this, simply use the following command: sudo snap install BTRFS-procs. Hope it'll work. Again, we get an error message which indicates that I'm trying to use Snap Package Manager on a system that hasn't been fully set up for Snap usage yet. So let's try to troubleshoot it a bit. First, I'll type sudo systemctl status snapd. And as you can see, service is disabled and process exited status. So let me quit from here by pressing Q, and I'll try to restart snapd. Again, let's check the status. Now it's active and running. Again, to exit from this information, we'll press Q, clear the screen, and try to rerun sudo snap install BTRFS procs. Now it started downloading snapd from channel stable and mounting snapd security profiles and so on, automatically connecting and downloading snaps from channel stable, as you can see. And now it's downloading BTRFS, mounting it, and seems that like it's done. So that's how you troubleshoot package-related, repository-related, and installation of packages-related issues. Let's take a closer look at USB device detection. So to find out which USB devices are attached to your system, we use ls/usb command. And it stands for list USB. This command is handy tool when you need to check what USB devices are recognized by your Linux system. And it's part of USB utils package, which comes pre-installed on most Linux distributions. So as you can see, the output with several lines, and each line follows this format: bus, number, device, ID vendor, product ID, and manufacturer. Now let's try to get more detailed information about a specific device. We'll use the -v flag for verbose output, and you'll need to specify a device using its bus and device number. Let's say we want more info about the device on bus 001. So I'll type sudo ls/usb -v-s and then 001 : let's say device 002. Hit enter, and we get lots of information on this device, including its configurations, interfaces, and endpoints. So it's like getting a detailed spec sheet on your USB device. Here is another cool trick. If you want to see a tree-like diagram of your USB devices, you can use the USB devices command. So I'll clear the screen and type it USB devices, and it'll dump much information about the USB devices on your system as well. And it also gives you a more structured view of your USB setup, showing which devices are connected to which hubs. Now let's say you've just plugged in a new USB device and you want to see what changed. You can use ls/usb before and after, but there is a cooler way. You can use the watch command to see the output of ls/usb in real time. So you could type watch ls/usb, and now the terminal is updated in real time, and this will refresh the output every 2 seconds. Now try plugging in or unplugging a USB device while this is running. You'll see the list update in real time. Let me terminate this command by pressing Ctrl+C. Let's break down what makes info special. The info subcommand is used to query the UDEV database about a device. It provides detailed information about the specified device. It's like having a magnifying glass for your system's devices. In my terminal, I'll type UDEV ADM info, followed by name parameter, and I'll need to specify the name of the device. For this, I'll use equal sign and the device itself, for example, dev SDA. And in this case, I'll get no such device because there is no SDA device on my system. But that's how you use this UDEV ADM info command correctly. And in case this device is present on your system, it will show you detailed information about your primary disk device, the disk device you need to investigate. And we could list all disks with their defined partitions along with size of each with ls bulk command. And now we can see that we've got a VDA device. So we could rerun the previous command, changing SDA to VDA. So as you can see, this command shows you detailed information about your primary disk device. Each line gives you a different piece of information about the device. It's like getting a full dossier on your disk. Okay, let me quit this output. I'll type :Q to exit from this output and clear the screen. I'll type dmessage -- followed by human parameter and another parameter caller equals always. Hit enter. Now what this command does, let me quit here and revert to this command. What it does, the human option makes the timestamps more readable, and caller always adds color coding to the output. Much nicer, right? Now let's explore some other useful ways to use dmessage. Let me command this line by pressing Shift-Alt#, and we'll type another command, dmessage, followed by pipe and tail command. And we can specify a number of lines we want to output. For example, 10. Hit enter and we'll get 10 last lines of this output. Let me clear the screen by pressing Ctrl-L. Now we could pipe the message output to grab command. Example -I USB. USB. Hit enter and that will find all messages containing USB word, and -I make sure we find uppercase and lowercase printed words. So this -I makes the search case insensitive. Now let me clear the screen and type the following command, dmessage -W. Now as you can see, the output hasn't finished because now this command is watching for new messages in real time. And if you're trying to catch an intermittent issue, you can watch for new messages as they happen. This will show you new messages as they are added to the RIN buffer. Now try plugging in a USB device while this is running. Let me break this by pressing Ctrl-C, clear the screen and type the new useful commands used with dmessage. Sometimes, especially after resolving an issue, you might want to clear out old messages. So to clear the RIN buffer, you type sudo dmessage -C. I won't be running this command. I'll comment it with Shift-Alt#, but for your info, this command clears the RIN buffer. Be careful with this one. It'll erase all current messages. Another useful way to use dmessage command to show only error and warning message. If you're troubleshooting, you might only care about errors and warnings. So dmessage dash level equals error, warn. Hit enter and you'll get only warnings and error message. This will filter out all the information messages and show you only the potential problems. Now, a small task for you. Try something interactive using dmessage. Use dmessage to watch what happens when you plug in a device. So first, run dmessage in real-time mode in one terminal and simultaneously plug in a USB device. And as an output, you should see new messages appear in real time showing you exactly how the kernel responds to the new device. So please remember this dmessage command is an incredibly powerful tool for understanding what's happening at the kernel level of your Linux system. Whether you are troubleshooting hardware issues, watching system startup messages, or just curious about what your kernel is up to, dmessage is your go-to command. I hope this hands-on exploration helps you understand the dmessage command better. Feel free to experiment with different options and try viewing the dmessages when you perform different actions on your system. But also be careful with such commands as dmessage -C, because it will erase all current methods. In this video, we'll be talking about run levels for system maintenance and troubleshooting. First, let's explore the different run levels in typical Linux system. And we start with run level 0, which is halt or shut down. Run level 1 is a single user mode. And run level 1 sometimes displayed as run level S or uppercase S, single user mode. In this mode, many services are not started, giving you a bare-bones system to work with. It's like putting your system on a very limited mode. So please remember that run level 1 is your go-to when you need to perform critical system maintenance or troubleshooting. And if we run the following command who-r, we can find that now we are running run level 3. So let's continue. After run level 1, we've got run level 2, which is multi-user mode without network. Then run level 3, it's full multi-user mode with networking, but no graphical user interface, like in my case. Run level 4 not used, and run level 5, it's full multi-user mode with networking and graphical user interface, or GUI. And then we've got run level 6, which is reboot. So run level 0 is halt or shut down, and run level 6, it's reboot. We can also check for which run level we're currently in by using run level command. And again, we'll get number 3. And by the way, this uppercase N means not number. As I've said, it's more convenient to say so, but it means the previous run level is not applicable, like after a fresh boot. And then 3 is the current run level. So some words about run level 1 or single user mode. The use cases where you can run this level are as follows. You could run this run level 1 for performing system maintenance, or resetting a forgotten root password, or repairing file system issues, or recovering from critical system problems. The characteristics for run level 1 is as follows. It's minimal system services running. Network interfaces are usually down and only the root user can log in. File systems are mounted read-only by default. We could enter single user mode if it is needed by switching to single user mode with typing the following sudo init 1. Be careful to run this command. This will stop most devices and might disconnect you if you are using SSH. So let's take a look at how it works. I hit enter. Now if we rerun the previous command, run level 1, we can see that we are running 3 and run level 1. So now if I reboot this system, and we'll need sudo privileges to reboot, first off, I've exited my SSH connection from this system, and if I go to virtual machines in my remote management in Red Hat Enterprise Linux, by the way, let's go back to terminal and try to reconnect to this system. As you can see, I failed to connect with SSH to this system because now it's running at run level 1. So I'll need to connect directly to this virtual machine, and for this I'll switch to virtual machines pane, go to test virtual machine, and use console to connect to this virtual machine. Let me expand it, and now if I'll try to log in with my username and run the command who-r, it appears that I still run level 3. Let's try to rerun the command sudo init1, and as you can see, the Windows has changed. You're in rescue mode, because when we were running it from SSH connection, the system was smart enough to understand this and didn't switch run level 1 to run level 1. But now we get this message, you're in rescue mode. After logging in, type journalctl-xb to view system logs, or systemctl reboot to reboot, or systemctl default or exit. Now we'll need to provide root password for maintain, or press Ctrl-D to continue. Let's try to press Ctrl-D, and if we press Ctrl-D, as you can see, it's reloading System Manager configuration and rebooting to the default run level, which is run level number 3. Let's log in again. I'll type in my password. Oops, misspelled it. So again, we could type run level command to check our run level. And as you can see, it's run level 1, 3. And again, we could type init1, and we'll need sudo command for it, and enter maintains mode by typing in the password for the root. Now we are logged in as root, and if we type run level command, we'll find that it's 3 and 1. So again, I'll type init3 to get back to the run level number 3. And let me get back to my terminal window. It's better to work with it. So let me reconnect to the host with SSH, clear the screen, and we continue with run level. Now, what you could do in a single user mode in run level 1. Once in a root single user mode, you can perform various maintenance tasks. For example, you could check and repair file system. For instance, you could run the following command. First, let me change to user root, and we could type the following command: fsck-f / for example, dev vda. This command will check and repair file systems. I won't be running these commands because I don't need to troubleshoot this system right now. I'm typing them just for demonstration and information purposes. So let me comment this line. And the next command you could run as root in run level 1 is to reset root password. For this you could type passwd, passwd root. This command will reset your root password. The next command you could run in run level 1 as root, you could mount file systems read-write. For this you type mount command -o remount, read-write, and / for root file system, for the root of the file system. Again, I'll command this line. I won't be performing this task right now. And when you are done working with run level example number 1, you can exit single user mode to return to normal operation by simply rebooting your system and type reboot. So let me type it for you, reboot, when you are done to get back to your default run level. Now, it's important to note that modern Linux systems, especially those using System D, are moving away from the traditional run level concept. They use targets instead, which are more flexible, and the equivalent to run level 1 in System D is the rescue target. Again, to enter this mode on a System D based system, you would use sudo. I don't need sudo because I'm running it as root. Let me exit from root user, and now I'll need to type sudo systemctl isolate, and we specify the target, which is rescue.target. So this command will enter run level 1 or rescue target level on your system. I'll also comment this line. I won't be performing it because we've just seen how to change to run level 1. So please remember that single user mode is a powerful tool for troubleshooting and system maintenance tasks, but it should be used carefully. It's like performing system critical tasks. Moving on to system hardware information, let's examine the capabilities of the LSPCI command. This powerful tool is essential for system administrators and users who need detailed information about their system's PCI devices. This LSPCI command can provide a wealth of information, including device IRQ or interrupt request settings, and this data is crucial for understanding how devices communicate with the system's CPU. Additionally, LSPCI can display the PCI bus speed, offering insights into the performance capabilities of your system's PCI connection. Another valuable piece of information that LSPCI can provide is device vendor identification. This feature allows you to quickly determine the manufacturers of various components in your system, which can be invaluable when troubleshooting or updating drivers. It's worth noting that while LSPCI is extremely useful, it doesn't display all types of system information. For instance, it doesn't show the system battery type or Ethernet MAC address. For such information, you'd need to use other specialized commands. Now let's take a question on this command. So what information can the LSPCI command display about system hardware? Is it system battery type, device IRQ settings, PCI bus speed, Ethernet MAC address, or device vendor identification? Press pause here and think about the correct answer. And the correct answers are option B, device IRQ settings, option C, PCI bus speed, and option E, device vendor identification. Now let's explore the capabilities of LSPCI command in our terminal. I'll clear the screen here and type LSPCI. As you can see, it reveals lots of information on different hardware pieces. It displays a list of all PCI devices in our system. We can look at more detailed information. For example, we could type sudo lspci-v. I'll provide my password, and in the output you can look for lines containing IRQ. This shows the IRQ settings for each device. Speed, this indicates the PCI bus speed, and vendor names. This identify the manufacturers of your devices. This information is crucial for understanding your system's hardware configuration. In this question, let's discuss the behaviors of system D when manually mounting file systems that are not listed in /etc/fs tab or otherwise known to the system. This scenario is common when working with removable media or temporarily accessing file system. In this situation, a particularly useful command is systemctl mount sync. This command can create a mount unit based on an existing mount. This functionality allows you to integrate manually mounted file systems into systemd's management, providing better control and monitoring capabilities. It's important to understand that systemd doesn't automatically generate mount units for manually mounted file systems, nor does it automatically unmount them after a short period. These behaviors ensure that your manually mounted file systems remain accessible until you choose to unmount them. While systemd provides powerful tools for managing mounts, it doesn't ignore manual mounts or require the use of systemctl unmount for all unmounting operations. This flexibility allows system administrators to use a combination of traditional and systemd specific tools as needed. Now let's answer one of the possible questions which can be among the exam questions. So what occurs when a file system not listed in etc/fs tab or known to the system is manually mounted? Systemd ignores manual mounts not done using by systemctl mount command. The command systemctl mount sync can create a mount until based on the existing mount. Systemd automatically generates a mount unit and monitors the mount point without altering it. Systemd unmounts the file system after a brief period unless a mount unit is created, or systemctl unmount must be used to remove the mount due to systemd opening a file descriptor on the mount point. And the correct answers are as follows. In this case, it's only one answer and it's option B. The command systemctl mount sync can create a mount unit based on the existing mount. Now, if we switch to the test VM, and for this exercise we'll need a USB drive or another removable media device. If you have one available, insert it into your computer. First, let's find the device name. I've inserted the USB in this device, and I'll type ls bulk. And in my case, it's SDB1, as you can see. It is a USB flash device, so it's SDB1, let's remember it. In any case, it's using SDB name. Now, look for your USB drive in the output, and it will likely be named as SDB1 or SDC1. Now, let's manually mount this device. So I'll clear the screen and I'll type sudo mkdir. Let's say that we'll mount it in mnt directory USB. I'll provide my sudo password. Now let's try to manually mount this device with sudo command again, sudo, and I'll use mount command to manually mount this device. And I'll provide the path to the device, which is dev sdb1. Let's check it. We've got several names with SDB. Let's use SDB1 and we'll mount it to the directory we've just created, which is mnt USB. I'll hit enter. Now, to see how systemd views this mount, let's run systemctl, then list, not lit, but list dash units, two dashes, type equals mount. Hit enter, and you should see your manually created mount in the list. Now we can create a systemd mount unit for this manually mounted file system. For this I'll type sudo systemctl daemon-reload and sudo systemctl start mnt-usb.mount. And now let's check the status of the new mount we've created. I'll type systemctl status mnt-usb.mount. And as you can see, it's active and it's mounted in mnt/mnt/USB drive, USB directory. To exit from systemctl, you press Q. So this hands-on practice should give you a practical understanding of the concepts we've discussed. And of course, remember to safely unmount your USB drive when you're done. For this, you'll use, let me clear the screen. So you'll use, again, sudo command, and we've got umount command, and we'll need to specify the mnt USB directory. That'll safely unmount your USB drive when you're done. The question on log filtering with grep. Which command filters log entries between 8 and 8:59 a.m. from log8.log file? And the options are as follows. Take a look at these options and find the correct answer. Press pause here and I'll reveal the correct answer right now. And the correct answer is option E, grep -E backtick :08, that'll be from 8 till in square brackets from 0 to 9 plus in square brackets from 0 to 9 plus will close backtick log8.log file. So let's explore a bit how to use the grep for filtering log entries. The challenge at hand involves extracting log entries from a specific time range, namely between 8 a.m. and 8:59 a.m. To begin, let's examine the format of our log file. The timestamps follow the pattern day, month, year, and then hour, minute, second. Here it is. Our task is to focus on entries where the hour is 8, representing 8 a.m. So we need 08 for this format. The correct solution utilizes the grep command with the -E option, uppercase E, for extended regular expressions. The pattern 08 and then 2 blocks of square brackets from 0 to 9 precisely matches the desired time range. And let's take a closer look at this pattern. So first, this :08 in single quotes matches the hour exactly. Then the first block from square brackets with square brackets from 0 to 9 matches one or more digits for minutes. And the final block in square brackets matches one or more digits for seconds. This approach ensures we capture all entries within the 8 a.m. hour regardless of the specific minute or second. Now let's switch to the console and try to run this command. For this, I've created this sample log file. Let me hit enter here. That'll create this server.log file. Let's ls the directory and we'll find this server.log file here and we'll run the grep command. Will filter for entries between 8 a.m. and 8:59 a.m. For this, we'll type grep -uppercase E, and now in single quotes, I'll type :08, that'll be from 8 a.m., then followed by colon again, and the first square bracket block from 0 till 9, and we'll add a plus here, colon again, not semicolon, but colon, and the second square bracket block from 0 till 9. Again, plus, and we'll close single quote. Now we'll specify the file we want to filter log entries from, that is our server.log file. Let's hit enter, and as you can see, grep successfully performed the action, and it has taken 3 lines with the specified criteria. The first line was at 8 a.m. sharp, the second line was at 8:30:45, and the third line was at 8:59:59, end of 8 a.m. So that's how you effectively process log files and search for needed information with grep. Command redirection. And the question is, what occurs when executing ls and then followed by the redirect symbol, which is greater than, and will redirect it to files file if files file doesn't exist. And the options are as follows. The output of a displayed will be displayed in the terminal. A new files file is created in ls out with lspow output. An error message appears and ls isn't executed, or files command runs receiving ls output, or finally option E, ls output is discarded. Press pause here and I'll reveal the answer now. So the correct answer here is option B. A new files file is created with ls output. Now let's take a closer look at command redirection. So as you remember, command redirection is used with these greater than or less than operators, and command ls greater than files will redirect the contents of ls command to files file, even if this file doesn't exist. This greater than operator creates the specified file if it doesn't exist, or overrides the file if it does exist. So remember, when you use one greater than operator, it will override the files and the file's contents if it does exist. If you don't want to override it and you want to append the contents, the new contents to this file instead, you'll use double greater than operator. But back to this greater than operator, it also writes the output of the left command to the file, as expected. So it redirects the results from the left command to the right command. And as a result of this command, new file is created, output is written to files, and no output displayed in the terminal. Let's run this command in terminal. I'll clear the screen here, and we'll type, let's say we'll type ls greater than, and let's name a file directory underscore contents. Hit enter, list the directory. Now we'll get this directory contents file created here, and if we get this directory contents file, we'll get that this file is containing the ls, the output from ls command. Here it is. All directories in our current directory, which is tmp, and their listing has been redirected to this directory contents with this redirect operator, which is this greater than symbol. In this question, we'll be using regular expressions and the question on regular expression. So the question is, which regex transforms the output to add .bug before .txt. Here you can find the input txt1.txt, atxt.txt, and txtb.txt. And the output expected is txt1.bug.txt, atxt.bug.txt, and txtb.bug.txt. And the answer are as follows. Take a look at these options from A to E and find the correct one. Press pause here and I'll reveal the correct answer in just a second. And the correct answer is option C. Here it is. And it's s/txt $bug.txt/. So the application of regular expressions in text transformations are as follows. This task involves modifying file names by inserting this .bug extension before the .txt extension. And the correct regular expression for this task was this one. So here s/ at the beginning and / denotes a substitution operation. Then $txt matches txt at the end of the line. As you remember, when we use $, it matches at the end of the line, or string in this case. And finally, bug.txt is the replacement string. This regex works because it specifically targets the txt at the end of each file name. By replacing it with bug.txt, we effectively insert .bug before the original .txt extension. It's important to note why the other options doesn't work. Let's get back to the other options. Here you can see them at the bottom. The first option was s/**.txt and so on. It replaces entire file name. Then the next option was s/txt/bug.txt. It would replace any occurrence of txt, not just at the end. Then the next option was s/**txt $.bug**. It's got invalid syntax. And finally, the last one would replace individual characters, not the whole extension itself. Let's try out this expression and we'll switch to the console, clear the screen, and first let's create some simple files. So I'll type touch file1.txt, file2.txt, and file3.txt. Let's ls the contents. Here we've got 3 files. Now let's use regex to add .bug before .txt. So what we need to find all txt files containing .txt extension. We'll need an asterisk wildcard, right? So asterisk.txt will find all files containing .txt extension. Let's add some scripting here. So we'll add for file in asterisk.txt. What we'll do? Oops, not here. Semicolon will do, and let's add a space here, move, and then we'll rename. We'll use first the file variable, and then for each file, so we'll add file $, so that it'll get file 1, file 2, and file 3, then .txt extension. We'll add bug.txt, double quotes, done. A question on man command. Which command displays the manual page for a command from section 1? Is it man command and in parentheses 1, add 1, man1 command, man1 dot command, man-s 1 command? Press pause here and I'll reveal the correct answer in just a second. So the correct answer is option C, man1 command. So as you remember, man is an invaluable tool which serves as your gateway to understanding the intricacies of various Linux commands and utilities. The man command, short for manual, it provides detailed documentation for commands, system calls, libraries, and more. It's organized into sections, with section 1 typically covering user commands. So to access the manual page for specific commands from section 1, you type man1 command. This format ensures you're accessing the right information from the appropriate section. Now let's try out this command. I'll type man1. Let's say that I want to find information on passwd command. And as you can see, we get the output for section 1, which is the section for the commands, and we get the description. It modifies a user's password and so on. We can read about this command. To quit, I'll press Q. Now let's say that we want to read the information on password document or configuration file. As you remember, we've got this password which is located in if we ls-etc-password. We've got this password file containing all the password information. So if we specify ls and instead of 1 we'll provide 5, we'll read about the password file, not the password command. So now you see how it's important to specify the section if you are looking for some particular information, not to read through the whole document and find the information about the command or the password in the whole documentation. You can directly refer to the mans section you need. Moving on to the ln command question. Let's examine the ln command. And the question on this is as follows. We've got an output. Given the output, here it is. How would you create a new file c.txt with the same inode number as a a.txt with inode which is 52, 53, 85. Press pause here and think about the correct answer. And the correct answer is option C. The command will be ln a.txt c.txt. So first you node this inode and then you use it with ln command. So let's examine this ln command, which is used for creating links between files. Understanding file linking is essential for efficient file management and organization in Linux system. So with this scenario, we see two files, a.txt and a symbolic link b.txt. Let me get back to the files. Here they are. Now, if we want to create a new file, c.txt, with the same inode number as a.txt, we would use ln a.txt c.txt. This creates a hard link, which means c.txt will share the same inode, which is 52, 53, 85, this one, as a.txt. Hard links are powerful tools for creating multiple references to the same data without duplicating the file content. Now let's switch to our terminal, clear the screen, and practice this command a bit more in the terminal. So first let's create a file named original.txt by typing echo. We'll populate this file with some content. So I'll use echo. This is the original file. And let's redirect this string to original.txt document. So that will create a file named original.txt containing this string. This is the original file. If we cat this original.txt file, we'll get this, that it contains this string. Now let's create a hard link to this file. For this we'll use ln command, right? And we'll specify the file name original.txt, and now we'll create a link, which is a link file. So let's name it link1.txt. Hit enter, and now if we ls-la, we'll find this file here, link1.txt. Let's clear the screen. Now let's verify that both files have the same inode number by using ls-i original.txt and link1.txt. As you can see, they share the same inode, 41, 15, 95, 7. Now let's try to edit link1.txt and observe how the changes are reflected in original.txt as well. Let's try creating a symbolic link then. So first, let's edit this file. I'll type nano link1.txt and let's remove this original word and add link file. I'll hit Ctrl X, hit Y to save the changes. Now let's rerun the previous command ls-i original.txt and link1.txt. As you can see, inode is the same. Let's try to view the contents of original.txt file, and as you can see, both files are changed. So when you change one of these files, either original file or its hard link, both files are changed. Now let's try creating a symbolic link. I'll type ls-s original.txt and let's name a new file symlink.txt. And of course, in this situation, we don't need ls-l. That's why we get this arrow. So let me get back to this ls command and change it to ln-s original symlink.txt. So now if we change the original.txt file, first let's check original.txt and symlink.txt with ls-i. We'll check the inodes for these files. And as you can see, the inodes are different. So that's why symbolic link is also called soft link. Now, if we change with nano, and by the way, let's cat first the symlink.txt, we'll get this is the link file, right? And if we cat original.txt as well, again, we'll get this is the link file. So let's change this with nano. I'll type nano original.txt and we'll change link to original. Save the changes, clear the screen, and rerun the previous command. So first, let's check the contents of symlink.txt. This is the original file because it's linked to the original file. And now if we change the contents of this symlink.txt file, I'll type nano symlink.txt and we'll change it to link. Yes. Now if we cat symlink.txt, we'll get this is the link file, and if we cat original.txt, we'll also get this is the link file. So now you know everything about soft links and hard links, and you know the difference between the soft link and hard link. As you remember, the difference is in inode. Hard link and original file are using the same inode, and soft link and original file are using different inodes. And you check it with ls-i original, for example, and symlink. So now we'll get different inodes. And if we rerun it command and change it to link1, we'll get the same inodes. As you can see, the inodes are the same with hard links. A question on the versatile grep command. And the question is as follows. What is the effect of the -v option for the grep command? It enables caller to highlight matching parts, it shows the command's version information, it only outputs not matching lines, it changes the output order, showing the last matching line first, and it outputs all lines and prefixes matching lines with a plus. So press pause here and I reveal the correct answer in just a second. And the correct answer is option C. It only outputs not matching lines. So as you remember, this grep command is a powerful tool to pattern searching and text manipulation in Linux. The grep command comes with various options to refine your searches. One particularly useful option is -v. When you use grep-v, it inverts the match, meaning it only outputs non-matching lines. This can be incredibly useful when you want to filter out specific patterns from your output. For instance, if you're analyzing log files and want to see all lines that don't contain a certain error message, the -v option would be your go-to tool. So let's practice with grep command in the terminal and let's create some temporary practice file. For this we'll use echo command, echo with -e option. Let's say that we'll add apple, new line banana, new line cherry, new line date, new line, we'll need n here, and new line, let's say eggplant. And we'll redirect this to fruits.txt file. Let's list this fruits.txt file. Here it is. Now let's use grep to find lines containing A. So we'll type grep, then in single quotes A, and we'll be searching in fruits.txt file. So all these words contain A, except cherry. As you can see, cherry doesn't contain A, and it is excluded from this list. Now we'll use this -v option to find lines that don't contain A. So we'll get cherry, I guess. So let's type grep -v, and then we'll specify A in single quotes, and again we'll be searching in fruits.txt file. And as expected, we get cherry word, which doesn't contain A. And of course, in real-world Linux environment, you could search for some information, for example, some process started or low disk space or permission denied, and so on. Actually, let's create one more file with echo command. I'll get back to this echo command. Let's rename the file not fruits but log.txt, and let's change all these words to relevant Linux. For instance, this one will type error permission denied, and we'll also add warning low disk space, and we'll add info message. So I'll type info : process started, and finally let's add error again instead of banana. So I'll type error : file not found. So that will create a log.txt file. Let's cat the contents of this log.txt file, and we'll get, and by the way, we don't need this apple, so let's remove it. I'll get back to this apple word and remove it, populate our log.txt file once more, and cat our log.txt file once more. And again, we don't need this extra n, so let's rerun it again to remove this extra n letter. Now it's all in order, and we can work with this file. So I'll clear the screen, and we can use grep-v command, and let's say that we want to get all the messages except error message. So I'll type error, and we are looking the messages in log.txt files. So that will get us all the messages except error. As you remember, we had 2 error messages in our log.txt file. Here they are: error file not found and error permission denied. So this command is working as expected, and it dumps all the messages except error message. A question on default file system created by MKFS. So, which file system is created by MKFS when executed with only the block device name? Is it XFS, VFAT, ext2, ext3, or ext4? Press pause here and think about it. And in just a second, I'll reveal the correct answer. And the correct answer is option C, ext2. So MKFS command. It's a fundamental tool for creating file systems. When system administrators need to create a new file, they often turn to this command. Interestingly, when MKFS is executed with only the block device name and no additional parameters, it creates a specific type of file system by default. The default file system created by MKFS is ext2. This choice reflects the historical importance of the ext2 file system in Linux environments. While newer file systems like ext3, ext4, and XFS offer advanced features, ext2 remains a simple and reliable option for certain use cases. Now let's switch to the test VM. It's a Debian 11 system, and we'll experiment a bit with creating a default file system with MKFS. So let's start by creating a file system using MKFS with its default settings. And first we'll create a file to serve as our block device. For this we'll use dd command, and input file will equal to the following path, dev0, right? And let's add an output file which will equal to testdisk.img extension. And block size will be 1 megs, and let's create 100 such blocks. So we'll add count equals 100. This will create a 100 megabyte file named testdisk.img. I'll hit enter, and if we ls the contents of this directory, we'll find this testdisk.img. We can also run ls-la for this test disk file, and that'll reveal that this file is 100 megs in size. Let's clear the screen. Now let's use MKFS on this file. So I'll type sudo mkfs, and we'll specify the file testdisk.img, provide the password. So observing the output, we can see that ext2 file system is created by default. To verify the file system type, we can use file command. So I'll type file testdisk.img. And as you can see, we've got ext2, here it is, confirming that it's the default file system created with MKFS. Our next question is on system V init configuration. Given these symbolic links in a system V init configuration, etc.rc1.d k01 apache2 and etc.rc2.d so2 apache2. When are the reference scripts executed? Please take a look at these options and select the correct answer. Press pause here and think about it. And the correct answer is option A. so2 apache2 runs when entered run level 2. And option E. ko1 apache2 runs when entered run level 1. So system V init configuration uses symbolic links in specific directories to determine which services should be started or stopped at different run levels. And in this question, you had to consider the symbolic links, these ones. symbolic link 1 and symbolic link 2. These links provide valuable information about when certain scripts are executed. So SO2, a patch 2, is run when run level 2 is entered. The S prefix indicates that the script starts a service, in this case the Apache Web Service, and KO1 Apache 2 is run when run level 1 is entered. This K prefix signifies that the script stops or kills a service. Understanding these naming conventions and execution order is crucial for managing services across different system states or run levels. Now let's explore the system init configuration on our system. First, let's navigate to the run level directories ltype cd etc. And now let's list all files starting with rc, then we'll use asterisk as wildcard, .d. And as you can see, we've got pretty many files. Let me make the font a bit smaller. So please observe here the symbolic links, those starting with S, this one and so on. While those with K are kill scripts. So as you can see, a bit above, we've got several K scripts. To see where these links point to, we'll use ls command. Let me clear the screen. I'll type ls -l rc2.d and let's add uppercase S and asterisk for wildcard. So we can find that this command shows all the services that start when entering run level 2. Similarly, for run level 1, we could get back to this command and change S to uppercase K. This will show services that are stopped when entering run level 1. In my case, it's only one script. A question on Debian package management. Which command locates the package owning etc debian _ version? Is it apt-get search etc debian version, apt-r etc debian version, find dpkg uppercase s etc debian version, or apt file etc debian version? Press pause here and I'll reveal the correct answer in just a sec. And the correct answer is, it's option D, dpkg uppercase s /etc /debian version. So in Debian systems, the command dpkg uppercase s and path to file is used to search for packages owning a specific file. For instance, to find which package owns the file debian _ version, you'd use dpkg uppercase s etc debian version. Here it is in this example. This command is particularly useful when you need to identify the origin of a system file or when you're trying to locate which package might be causing an issue. Let's take a look at this command on our Debian system, testing system. I'll clear the screen. Let me make it the font a bit larger and I'll type dpkg uppercase s and then etc debian version. Hit enter and as you can see, we can find the name of the package that owns this file. Let's try a few more examples. Let's remove this path and let's find the package owning bin bash, for example. And we'll find that bash package owns this file. And if we look for etc pathwd, we'll find that it hasn't found path matching this pattern. Our next question is on archive manipulation. And the question is, after running gunzip on text.tgz containing a.txt and b.txt, what remains? And here are the options: only a.txt, b.txt, and text.tgz, only texts.tar and text.tgz, only a.txt.gz and b.txt.gz, or only a.txt and b.txt. Or finally, only texts.tar remains. Press pause here and think about the correct answer. And the correct answer is option E, only texts.tar remain. So it's essential to understand how different compression tools work. Let's consider a scenario which we've had in this question involving a gzip compressed tar archive. When you have a file named texts.tgz containing a.txt and b.txt, and you run the command gunzip text.tgz. This gunzip command decompresses the .tgz file, which is a gzip compressed tar archive. After decompression, you are left with a .tar file. Therefore, the correct result is that only texts.tar remains in the current directory. Let's give it a try and run this command and see in practice the results of this for this question. So I'll change back to my home directory, and first let's create these two files, a.txt and b.txt. I'll use echo command, so I'll type echo. Let's populate these files with some text, for example, file a, close double quotes, and we'll redirect it to a.txt. And we'll do the same for file b, and we'll redirect it to b.txt. Let's list the contents. So we've got these two files here, a.txt and b.txt. Now let's use this tar command with dash czf. We'll name it texts.tgz. And now we'll specify the files to be put into this archive. So it's a.txt and b.txt. So that will create archive and compress it with gzip. We'll run it, list the contents again, and now we've got this texts.tgz archive. I'll clear the screen. Now let's test if we had selected the correct answer. We'll run gunzip, followed by the archive we want to decompress, texts.tgz. Hit enter and list the contents of the directory. So we see text.tar in our directory along with original a.txt and b.txt. And to extract the contents of the tar file, we can use tar command -xvf and specify the archive, which is texts.tar. This will extract the contents of the tar file. List the contents of the directory again. So in this exercise, we've practiced using tar to archive files and compress them with gzip, and gunzip to decompress archives. Our next question is on BIOS boot sequence. So which statements about PC BIOS boot sequence are accurate? You can select two. Option A, some parts of the boot process can be configured from the BIOS. Option B, Linux does not require the assistance of the BIOS to boot a computer. Option C, the BIOS boot process starts only if secondary storage, such as the hard disk, is functional. Option D, the BIOS initiates the boot process after turning the computer on. And option E, the BIOS is started by loading hardware drivers from secondary storage, such as the hard disk. Press pause here and think about the correct answer. And the correct answers are as follows: option A and option D. Some parts of the boot process can be configured from the BIOS, and the BIOS initiates the boot process after turning the computer on. Now, two key points to remember about the BIOS boot sequence are as follows: that parts of the boot process can be configured from the BIOS. This allows for customization of the boot sequence, which can be crucial for system recovery or performance optimization. And also, BIOS initiates the boot process after the computer is turned on. This is the first step in the boot sequence, occurring before any operating system is loaded. It's important to note that while Linux doesn't require the BIOS to run once it's loaded, the BIOS is crucial for the initial boot process on most systems. The BIOS provides the initial instructions that allow the system to load the bootloader, which in turn loads the Linux kernel. Now, while we can't directly manipulate BIOS settings in the terminal session, we can explore some system information that the BIOS passes to the operating system. So let me launch the terminal here on our test server, and I'll make the font a bit larger. So to view system information, we could type sudo dmi decode and pipe it to less pager, for example. We'll provide the password here for sudo, and let's make it a bit smaller. As you can see, we are getting SM BIOS data from as the output of this command, and we can find various information here like vendor, version, release date, PCI is supported, and so on. We can page through all this BIOS information and find what's needed. The processor information. So I'll exit from this output by typing Q. So this command shows you the kernel RIN buffer, which includes messages from the boot process. Also, please remember that actual BIOS configuration would require rebooting your system and entering the BIOS setup utility, usually by pressing a key like F2 or delete during startup. Our next question is on DPKG, and let me switch to the question. And the question is, which DPKG option ensures configuration files are removed when uninstalling a package? Is it --clean, purge, vacuum, remove, or declare? Stop here and think about the correct answer. And I'll reveal a correct answer in just a second. So the correct answer is option B. It is --purge. So as you remember, one of the Linux package management is dpkg command. And it's crucial to understand how to effectively manage packages, including their removal. When using dpkg to remove a package, we have several options at our disposal. However, one option stands out when we need to ensure a thorough cleanup, and this --purge option is particularly powerful because it not only removes the package but also eliminates its configuration files. This is in contrast to the standard remove option, which leaves configuration files intact. Why is this distinction important? Well, in some scenarios, you might want to completely erase all traces of a package from your system. This could be useful when you are troubleshooting conflicts or when you plan to reinstall the package with a clean slate. Now, let's have a hands-on example. So, let's say that we want to use htop for our practice example. First, let's check if it's present on our system. I'll type dpkg-s htop, and as you can see, it's not installed and no information is available. So let's install it really fast with apt package manager. And by the way, we can check with apt as well by typing apt search htop, and we can now go ahead and install this package. We'll type sudo apt install htop. We'll provide our password here, and it installed htop really fast. And by the way, to install it with dpkg, you'll need first use wget, and you'll need to provide a link here for htop package with .deb extension, and then you'll use dpkg to install it from the package. So now let's get back to our example, and first let's try to remove the package with the standard remove option using dpkg. So I'll type sudo dpkg -remove htop. Hit enter. Now let's reinstall the package and use the purge option. So let me again install it with apt, clear the screen, and I'll get back to this command dpkg -purge htop. So that's how you use this purge option, which will not only remove the package but also deletes all configuration files for it. And you can check and verify the difference by checking the leftover configuration files in etc directory. For this you type ls etc htop. No such files or directory. Let me clear the screen. Our next question is about nice levels. So the question is, what is the default nice level when a process is started using the nice command? Is it -10, 0, 10, 15, or 20? And the correct answer is option B, 0. So process priority in Linux is managed through nice levels, so-called nice levels. The nice command is used to start a process with a modified scheduling priority. Contrary to what one might expect, the default nice level when starting a process with nice command is 0, not 10 or any other value. This is a crucial piece of information for managing process priorities effectively. Please remember that nice values range from -20, its highest priority, to 19, its lowest priority, with 0 being the default. And as usual, we'll test this question in practice. We'll switch to our virtual machine, and in the terminal I'll type nice. And as you can see, we get the default level 0. So without any arguments, this will start a shell with the default nice value. Now in this shell we'll type, for instance, ps -o, lowercase o, pid, then com, then nice, -p, followed by $. Let's run this command. And as you can see, it shows the process ID, command, and nice value of your current shell. As you can see, we've got nice level 0, command bash, and process ID 3176. Our next question is on bash output redirection. In bash, what does inserting 1 greater than $2 after a command redirect? Is it a standard arrow to standard input? Option B, standard output to standard arrow. Option C, standard input to standard error. Is it standard arrow to standard output, and finally standard output to standard input? And the correct answer is option B. It's standard output to standard error. So as you remember, this standard output is a fundamental concept. and output redirection. As understanding how to manipulate standard input, output, and error streams is essential for effective shell scripting. In Bash, as you remember, we use numbers to represent these streams. And here, 0 for standard input, 1 for standard output, and 2 for standard error. So when we see the notation 1 greater than ampersand 2, we are dealing with a redirection operation. Breaking it down, 1 greater than means redirect standard output, and ampersand 2, here it is, refers to the standard error stream. Therefore, 1 greater than ampersand 2 redirects standard output to the same place as standard error. This technique is particularly useful when you want error messages and regular output to appear in the same place, such as when writing log files or displaying both types of information to the user in a consistent manner. It's important to differentiate this from other redirection operations. For instance, 2 greater than ampersand 1 would do the opposite, redirecting standard error to standard output. Now let's get to our test in VM machine. Let's use CentOS. I'll provide my username. We'll launch terminal. And by the way, let me change this local host name really fast, host name. So I'll type sudo hostname ctl set hostname, and let's name it test. I'll provide my password. Oops, I've made a typo. Set hostname. Now I'll reboot this server with sudo reboot, and after it's rebooted, we'll continue with standard input and standard output examples. I'll log into this server with Parallels user really fast and launch terminal again. Now the command line prompt is a bit shorter. I'll make it larger. Now let's practice Bash output redirections. So first, let's create a simple script called test.sh. I'll type vim test.sh. Let's enter insert mode by typing I, and we'll add a shebang here, hash dollar hash exclamation point bin bash, and let's add two echo lines here. Echo, for instance, this is standard output. Let me press dd twice. Oops, not dd, sorry, but YY. And I'll press P to insert this line again, and we'll change this line a bit. So this is standard error. And we'll redirect it to ampersand 2, which refers to the standard error stream. Let's save this file. I'll press :WQ, right quit. We'll list it. Here it is, test.sh. And we'll need to change permissions for this file with change mode plus X to add executable permissions to this file, test.sh. Now we can run this file with /test.sh, and we'll redirect the output of this operation to output.txt, and then we'll add 2 greater than ampersand 1. Let's run this command and see what happens. So as you can see, we've got nothing on our screen, but if we check output.txt file with cat command, so I'll type cat output.txt, we'll get both messages in this file. Now let's run this previous command without this redirection, and we'll get this line. This is standard error on our screen. And if we check, let me clear the screen. If we check output.txt again, we'll get this is standard output line in this text file. So again, if we run this command, we run the script and redirect standard output to a file. And if we run this command, we redirect both standard output and error to the same file. Finally, let's use the 1 greater than ampersand 2 redirection in a script. So let's create one more script. We'll name it test2.sh. Again, insert mode. Again, we'll add shebang here, bin bash, and add one echo line here. Echo, this message goes to standard error, and we'll redirect it to greater than 1 greater than ampersand 2. Let's save this file with WQ, and we'll add execution permissions to this file, which is file test2.sh, and we'll run this test2.sh file and observe how the message is treated as an error message. So let's hit enter. Now we get this message goes to standard error. So I hope this information was useful and it'll help you pass in your exam. Our next question is as follows. Which command print the current working directory in bash? I guess it's quite simple question, but you can get it on your exam. Is it echo $pwd in curly braces and in double quotes? Is it echo $wd print wd pwd, or echo $pwd all lowercase? And by the way, you need to select two options. So the first option is obvious, and the correct option is option D, PWD, right? And the second option is not so much obvious, but it's echo $PWD in curly braces, all uppercase and in double quotes. So print in the current working directory. This operation is frequently used in scripts to verify locations or construct file paths. In bash, we have multiple ways to achieve this, but two methods stand out for their reliability and widespread use. The first method is using the pwd command. Simple and straightforward. Pwd, print working directory, does exactly what its name suggests. The second method involves using the pwd environment variable. By echoing $ and in curly braces pwd, we can display the current working directory. This $curly braces syntax is used for variable expansion in bash. It's worth noting that while echo $wd and pwd all lowercase might seem logical, they won't work as expected. Bash is case sensitive, and these variations don't correspond to correct environment variable. Similarly, the last option was print wd. It's not a standard bash command, and we couldn't use this command as well. Now let's practice a bit with this example in our test virtual machine. So I'll switch back to our CentOS Linux virtual machine, and let's first type pwd. As you can see, it's my user's home directory, this demo user home directory, which is parallels user, and it displays your current directory. Now let's use pwd environment variable. So I'll type echo, two double quotes, and $, then two curly braces, and pwd environment variable inside curly braces. Let's hit enter, and this displays the same directory as pwd, as you can see. Now let's try changing directories and repeat these commands. So I'll type cd. Let's see what we've got here. Let's change, for example, to documents directory and rerun this command. So first, let me clear the screen first. And now I'll run pwd command. As you can see, the working directory has changed to home, parallels, documents directory. And let's run echo command again. So let's type echo, double quotes, curly braces, dollar before curly braces, and pwd, all uppercase. And again, it prints out working directory, accurately reflecting our new location. For comparison, let's try the other options we've got in this example, which were echo and it was dollar and in curly braces, all uppercase, WD. Nothing happens. The same goes for PWD, all lowercase, nothing happens. And the last command was print WD. Command not found. So by practicing these examples, you're gaining hands-on experience with working directory operations. You could use these commands in bash scripts, for example, or some automatization steps. Our next question is as follows. Which commands display the IDs of all processes owned by root? Take a look at these commands. Is it pgrab-c root, pgrab-u root, pgrab-f root, pgrab-uppercase 0, and pgrab-c 0? And in just a second, I'll reveal the correct answer. And the correct answer is option B, pgrab-u root, and option C, pgrab-f root. So in Linux, identifying processes is a crucial skill for system administrators and power users. Let's explore some powerful commands for this purpose. The pgrab command is a versatile tool for process identification. When dealing with processes owned by the root, two particularly useful options are pgrab-u root. This command lists the process IDs of all processes owned by the root user. The -u option specifies the user. And this second command, pgrab-f root, searches for process names and arguments that matches the pattern root. This -f option allows for a full search. It's important to note that while pgrab-uppercase u 0 might seem correct, as 0 is the UID for root, it's not a standard option for pgrab in all Linux distributions. And let's see it in practice. So in my terminal, I'll type the following command: pgrab-u root, and it lists all the processes for root. It's a long list of process IDs, and these are all processes currently owned by root. Now let's try another approach. I'll clear the screen and type pgrab-f root. So this gives us a different set of process IDs. It's searching for processes with root in their names or command line. So compare the outputs, and the difference will illustrate how these commands work and why both are useful in different scenarios. Our next question is on user information extraction. And the question is, which command generates a list of usernames from etc password file, along with their login shell? Is it :-s, chop-c, call-rm, sort-t, or cut-d? Think about the correct answer, and I'll reveal the correct answer in just a sec. And the correct answer is option E, cut-d, F1, 7, etc password. So Linux stores user account information in /etc/password file, as you remember. And extracting specific information from this file is a common task. To generate a list of usernames along with their login shells, the most efficient command is the one which we've had as the correct answer in our question. Let's break this down. First, we've used this cut command. It extracts sections from lines of files. Then -d colon. It specifies the delimiter, in this case a colon. And -f17. It extracts fields 1, which is username, and 7, which is login shell. This command provides a clean, efficient way to extract precisely the information we need from the password file. Let's run this command in our shell and see how it goes. So we'll type cat -d colon -f field 1 and field 7, and the file we need to extract from is etc password. Let's hit enter, and we see a list of usernames and their corresponding login shells. Now, to make it more readable, let's pipe it through colon command. So I'll clear the screen and get back to this command and add a pipeline here, and we'll add colon command -t -s and colon. Hit enter. Now, as you can see, it's much better to read, and it displays the output in a nicely formatted table. So now you know how to practically apply the commands we've just discussed. They show how you can effectively manage processes, understand priority levels, and extract user information in a Linux environment. Our next question is on command path. Which command displays the path to the executable file that would be executed when the command foo is invoked? Is it ls attrr, apropos, locate, what is, or which? And the correct answer is which command. So you type which foo. So that's how you know how to locate the path to an executable file. In Linux, understanding where commands are stored is essential for troubleshooting and system management. And the command that displays the path to an executable file is which. This versatile command searches through the directories listed in your path environment variable and returns the full path of the command if found. It's an invaluable tool for identifying which version of a command you're using, especially in systems with multiple installations. Let's run this command on some shell examples. So we could type which man, for example, and you'll find that it'll run from USR being man, or which ls. It is kept in bin ls. So it's a good idea to run this command before running the command itself, or which ssh, and it is kept in USR bin ssh. Moving on to the next question, and it's on package management again. Which command uninstalls a package but retains its configuration files for potential future installation? Is it dpkg-s, uppercase L, uppercase P, V, or -R? Press pause here and think about the correct answer. And the correct answer is option E. It's dpkg-r and followed by the package name. So in our scenario, you might encounter the need to uninstall a package while preserving its configuration files for future use. The command that accomplishes this task is dpkg-r package name. This command removes the package but keeps its configuration intact, allowing for easy reinstallation if needed. It's important to note that this differs from a complete purge, which would remove both the package and its configuration files. So please remember you use dpkg-r package name to uninstall a package while preserving its configuration file. We move on to the next question, and the question is, what is the process ID number of the init process on a system V init-based system? Is it -1, 0, 1, or it is different with each reboot, or it is set to the current run level? Press pause here and think about it. And the correct answer is process ID of init is option C, it's ID 1. So as you remember, the init process is a fundamental component of Unix-like operating systems, including Linux. It's the first process that starts when the system boots up and is responsible for initializing the system. A key characteristic of the init process is its process ID or PID. In a system with init-based system, these are the older or init-based systems. The init process always has a PID of 1. This is a constant feature, regardless of system reboots or the current run level, and understanding this helps in system troubleshooting and process management tasks. Let's try to verify the PID of init process in a terminal. I'll log into my Ubuntu server, open terminal, and type -p1. And as you can see, let me make it larger. So for this particular system, the PID is indeed 1 and the command name might be systemd as in my case, or init depending on your system. If it's an older system, you'll get init here. If we try rebooting the system and run the command again, we'll notice that the PID of this init remains 1, demonstrating its consistency across system restarts. So let's go ahead and reboot the system. I'll type sudo reboot. And by the way, let me change the name of this system really fast because it's quite long. I'll type sudo hostnamectl set hostname. Let's name it test. I'll provide my password here. And now I'll reboot the system with sudo reboot and we'll run the command to find out the init or systemd process ID once more after the reboot. It'll take about a minute to reboot. I'll log in with Parallels user, provide my password here, and let's launch the terminal once more. So I'll type in search ter, launch the terminal. The host name is changed as you can see, and we can make it larger again and rerun the previous command, which was ps-p1. As you can see, process ID is for systemd again. So it remains 1 even after the reboot. We move on to the next question, and the question is, how can you ensure a faulty kernel module is not loaded automatically at boot? And here you'll get several options using lsmod remove auto clean without specifying the module name, or option B, using mod info-k followed by the offending module's name, or option C, using modprop-r followed by the offending module's name. Option D, adding a blacklist line with the module's name to etc modprop.d backlist.conf, or deleting the module's directory and recompiling the kernel with its module. Press pause here and think about the correct answer. And the correct answer is option D, adding a blacklist line with the module's name to etc modprop.d blacklist.conf file. So it's crucial to know how to prevent problematic modules from loading automatically at boot time. This is a critical skill for maintaining system stability and performance. When a faulty kernel module is causing issues such as problems with the network interface card, you may want to prevent it from loading automatically. The most effective and persistent method to achieve this is by blacklisting the module. And you do so by adding a blacklist line. To blacklist a kernel module, you need to add a blacklist line including the name of the offending module to the file etc modprob.d blacklist.conf. This method ensures that the module will not be loaded automatically when the system boots, providing a long-term solution to the issue. Also remember, while other commands like modprob-r can unload a module temporarily, they don't prevent the module from being loaded at the next system boot. Always opt for the blacklisting method for a permanent solution to problematic kernel modules. Now let's switch to some console. Let's try to investigate it on Z shell first. I'll type ls-mod pipe grep. Actually, we cannot use ls-mod on macOS, so there is a command line tool for macOS which is kext find. Let's try to run this command. And this command line tool allows you to search for kernel extensions based on various criteria. Now let's switch to some Linux system, for instance, Ubuntu system. I'll clear the screen and SSH to Ubuntu system named NAS in my local network. And I'll connect with temp username. As you can see, it can't resolve host name, so let's try to connect by IP address 192.168.1.94. I'll add this IP address to the known hosts. I'll type yes and provide my password if I recall it correctly. Yes, we've managed to log in. I'll clear the screen. Now let's run ls-mod command here. It will list all currently loaded kernel modules. And as you can see, this output includes module name colon, the first one, memory size used by the module, and number of instances using the module. Let's think that this module FJS, the module we want to blacklist. So if you know particularly the name of the module, you could type ls-mod pipe grep ljs. Seems like it was FJS. Here it is. And now let's blacklist the module. For this we'll need to use sudo. So we type sudo nano etc modprob-d blacklist. We'll provide sudo password here. And here we could add the following keyword like blacklist fjs. Now we'd save the file by pressing Ctrl X, yes. And to make sure the change takes effect, you would typically reboot the system. In a real scenario, you'd do this now. And after a reboot, you can verify that the module is not loaded. Let's try to reboot the system. I'll type sudo reboot. It will take a minute or two. Let me try to reconnect with SSH to the system. I'll provide my password. So the system is booting up. I'll clear the screen. Okay, the system has rebooted successfully and we can double check if this module was prevented from loading. So I'll type ls-mod pipe grep and the module's name was FJS, right? And we found out that this module is still being loaded. It means that there could be another module that depends on this FJS module. The next question we'll answer is regarding zipper package installation or package management. So the question is, which command installs all packages with a name ending with a string foo? Is it zipper get foo? Is it zipper update foo, force, install, and add? Press pause here and think about the correct answer, and I'll reveal the correct answer in just a second. So the correct answer is option D, zipper install foo. So as you remember, zipper package manager is used in OpenSUSE or SUSE Linux enterprise distributions. Zipper provides a powerful and flexible way to manage software packages. And when it comes to installing packages with specific name and patterns, Zipper offers robust pattern matching capabilities. And to install all packages with names ending in foo, for example, the correct command is zipper install *foo. This command utilizes this asterisk wildcard character to match any package name that ends with foo. It's important to note that the correct syntax and placement of quotation marks to ensure proper interpretation by the shell. Unfortunately, I haven't got OpenSUSE on my Parallels control center, but we could try launch Windows 10 and then find OpenSUSE package for Windows Linux subsystem. So here I've launched Windows 10 and let me launch Windows Market and search for SUSE. So as you can see, we can get OpenSUSE Tumbleweed or SUSE Linux Enterprise 15, Service Pack 6, and so on. So let's go ahead and try this OpenSUSE. I'll double click it, click Get. I'll have to sign into my Microsoft account and so on. So when I'm done, I'll get back to you. Now I'm in a terminal in OpenSUSE, or in my case, it's not OpenSUSE, it's SUSE. Let me actually reveal the release. I'll type cat etc asterisk rel asterisk, and as you can see, it's SUSE Linux Enterprise Server, and we'll attempt to install all packages ending with foo. Of course, we don't have such packages, but that's just for demonstration purposes. So I'll type zipper install double quotes asterisk foo. Of course, we'll get an error. First off, that we don't have repositories defined here on this system, and the second error, no provider of foo found. But as I've said, it's just for the demonstration purposes of the command itself for this question. If you're on a non-SUSE system or don't want to actually install packages, you can use the dry run option to simulate the installation. For instance, zipper install dry run, and again asterisk foo. Again, we'll get this error, but it doesn't matter in our situation. So that's how you run zipper package manager command on SUSE Linux, and that's how you can use the SUSE distribution on your Windows Linux subsystem. Our next question relates to VI editor, and the question is, which command must be entered before exiting V to save the current file as file a.txt? Is it %s file a, %w, :save, :w, or :s? And the correct answer here is option D, :w, file a.txt. So as you remember, VI is a robust text editor. It's a powerful tool in Unix-like system, and knowing how to use it effectively can greatly enhance your productivity. You'll be editing lots of configuration files with VI, and it's installed in any Linux system by default. So when working in VI, you would want to save your current file before exiting. And the command you need is :w followed by the file name if you haven't provided file name when opening the file. So this command writes the contents of your current buffer to a file named file_a.txt. It's worth noting that in VI, commands are typically preceded by a colon when in command mode. So let's practice a bit with this command. Let me open VI editor here. By the way, you type VI and then press enter to open VI editor. Now let's say that we want to add some text in the configuration file. To do so, we'll need to enter insert mode by pressing I. As you can see, insert all uppercase word appeared in the bottom left corner. And let's add some text. For example, this file is modified on. Now I'll add the date. You can do this in VI as well, but that's not the topic for our question. It's just for information. So I'll press escape to exit insert mode, and I'll enter command mode by pressing colon. Then I'll add R exclamation point followed by date command. Hit enter and that'll add a date after below the command, below the line I'm on. Now to save this file, we again enter the command mode by pressing colon and add W, which means write, and then we specify the file's name, for example, modified file.txt. Hit enter. Now, oops, not notified, but modified. Let's save it once more with the correct name, modified file.txt. Now, as you can see, we've got this file name in the left bottom corner, and we can exit Vim. Now the file is saved, so to exit Vim, we'd press escape again, colon, Q. And by the way, we could do this with one command, WQ, if we wanted to save and quit the file. So if we ls now, we'll find this notified file and modified file. Let's remove this modified file with rm command. And if we cat modified file.txt, we'll find its contents. This file is modified on Tuesday, the 3rd of September, and so on. So that's how you save the file with its name. And by the way, if you want to name the file right when you open it, you could type vi followed by the file name. For example, vi modified file2.txt. That'll open this again notified file. Sorry for that. So that'll create the file with the name you specify and open it for editing. Now, if we add some text here, then we exit insert mode by pressing escape, enter command mode by pressing colon, and add the command write q. That'll save the editing you've done and quit the file. And now we can cat this notified file2.txt containing some text. The next question is on file manipulation commands. So the question is, which command prints usernames and primary groups from etc password? Is it fmt-f 1,4 cat-d :f 1,4 sort-t-k 1,4 paste-f 1,4 or split-c 1,4. Press pause here and think about the correct option. And the correct option is option B, cat-d :f 1,4 /etc password. So in Linux we can manipulate files and extract information in different ways. Let's examine a command that extracts specific information from etc password file, which we've just encountered in the question. And the correct answer was, as you remember, cat-d colon dash f 1,4 followed by the path, etc password. This command uses cat to extract colons from the file, and this dash d sets the delimiter to a colon, and dash f 1,4 specifies that we want to extract fields 1 and 4. The etc password file contains user account information, which with each field separated by colons. Field 1 is the username, and field 4 is the primary group ID. Other commands mentioned in this question have different purposes. FMT, for example, is used for simple text formatting. Sort orders lines of text. Paste merges lines of text. And split splits a file into pieces. Now let's practice a bit with this command. So we'll type, first let's copy the password files to our home directory with sudo. I'll type cp etc password to our current working directory, which is dot. I'll provide my password here, and let's list the directory. So now we've got password file here, and let's manipulate the data in this password file. So let's use the cat command to extract usernames and group IDs. We'll type cat-d colon dash f1 field 1 and field 4, and we'll specify the password file passwd. Oops, not pass but passwd. Hit enter. Now we've extracted the fields we needed. We can modify the command to extract different fields. For example, we could extract field 2 or field 3 and so on. Also, please feel free to experiment with other commands like sort, paste, and split. Our next question relates to VI editor command. So the question is, in normal mode in VI, which character initiates a reverse text search? Is it R, / uppercase F, question mark, or lowercase s? Press pause here and think about the correct answer. And the correct answer is option D, question mark. So one of the VI editor's strength is the ability to search through text efficiently. In normal mode, VI offers two primary search commands. Forward search, you press / to search forward. So you press / and then followed by your search item. And reverse search for reverse, used with question mark for reverse search. So you press question mark followed by your search item. This question mark character initiates a reverse search, looking upwards from the cursor position. This is particularly useful when you need to find previous occurrences of a word or phrase in your document. Other important VI commands include R, which was in our question, for replacing a single character, uppercase F for moving the cursor backwards to a specific character, and lowercase s for substituting character. Now let's practice this / reverse search and other commands used in this question. I'll get back to my terminal, clear the screen. Let's ls and see what's inside. Let's cat the contents of test.sh script. Okay, we can use this script for our example. So we'll open it with v-editor. I'll type v test.sh. Now, as you can see, the cursor is blinking on the 2 number. It is the end of this document. And let's say that we want to find all the words, for example, all echo occurrences upwards from the current cursor position. So for this, we'll press question mark followed by the word we want to search for. In our case, it's echo. Now, if you want to find the next occurrences moving upward, you press N. And again, to search for the occurrence of the word forward, you press /. Let's get to the beginning of this document by pressing GG. So as you can see, the cursor now is blinking on the start of this document, and I'll press / and type echo. Now, as this document is quite short, we don't have much space to experiment, but you understand the technique. Now let me exit this search, and let's say that we want to replace a single character in this echo command. I'll press R and replace it with, let's say, W. So as you can see now, E is replaced with W. And as you remember, uppercase F is for moving the cursor backwards to a specific character. So if we go to the end of this line by pressing $, and now if we press uppercase F and W, that will go to the first word containing W. And S, lowercase s, is for substituting character. So we've removed W, and now we can press E to substitute W with E. Let's exit from this document by pressing escape, Q, and exclamation point not to save the changes. So again, / to search forward, question mark to search reverse, R replace a single character, uppercase F move the cursor backwards to a specific character, and lowercase s to substitute a character. Our next question relates to process signals, and the question is, what signal is sent to a process when Ctrl-Z is pressed? Is it /term, /count, /stop, /kill, or /int? Press pause here and think about the correct answer. And the correct answer is option C, /stop. Now, as you remember, in Unix-like operating systems, signals are a form of inter-process communication. They are used to notify a process that a specific event has occurred. Let's take a look at this signal from the question when you press Ctrl-Z. So when you press Ctrl+Z, the terminal sends a stop signal to the foreground process. This signal suspends the process, effectively pausing its execution. It's important to note that /stop is different from other signals like /term or /kill. /term or terminate asks the process to shut down gracefully. /kill forces the process to stop immediately. And /count is used to resume a stop process, while /int interrupt is typically sent when you press Ctrl-C. Let's practice with some examples from this question. So first, let's start a long running process. For example, I'll type sleep 1000. Now we can press Ctrl-Z and we'll see that the process is suspended. So I'll press Ctrl-Z. We can now type jobs, and we can resume this process by typing BG. This will process the process in the background. If we bring it to the foreground with FG command, we'll get it on the foreground, and while it is running, we cannot issue commands in this particular terminal. Finally, we terminate the process by pressing Ctrl-C. Now, if we type jobs, we won't find any job running or suspended in our list. So this exercise demonstrated how /stop signal is used with Ctrl-Z, and /int Ctrl-C, /int signal is used with Ctrl-C. Moving on to our next question, it's related to command output redirection, and the question is which command displays the output of foo on screen and writes it to tmp foo data directory? Is it foo less tmp foo data, foo cp tmp foo data, foo greater than tmp foo data, foo pipe t tmp foo data, and foo greater than std out 2 greater than tmp foo data? Press pause here and think about the correct answer. The correct answer is only one answer. So the correct answer is option D, foo pipe t /tmp/foo data. Now, there are times when you want to view the output of a command on the screen while simultaneously saving it to a file. This T command is perfect for this scenario. The correct command to display the output of foo on the screen and write it to tmp foo data is foo pipe t and the path to the file. Output of foo is piped to t command, then t displays output and writes to the file. This technique is invaluable for logging command output while still being able to view it in real time, making it a powerful tool for debugging and system monitoring. Let's practice this command in shell. Let me exit this root session and change to my home directory, ls it, and let's say that we want to run ls command. First, let's clear the screen, and then we want to run ls command, and then output the contents, the result of this ls command to some file. And simultaneously, we want to observe it on our screen. For this, we'll use t command, and then specify the file name we want the output to be placed to. For instance, let's name it ls_output.txt. Hit enter. Now we've got the listing of the current working directory on our screen. Let's pwd, it's home parallels home directory. Let's clear the screen, and we can also open with nano, for example, this ls output.txt file, and we'll find all the directory listing in this file. I'll exit by pressing Ctrl X, Y. So that's how you use this powerful, small, but still powerful command, which is T command, to output the command's result on the screen and redirect the output to some file simultaneously. Our next question relates to grub2 files. The question is, which files are present in a standard grub2 installation? Is it boot, grub stages, stage 0, grub i386pe lvm, grub fstab, grub.config, or grub linux vm linux? Press pause here and think about the correct answer. And the correct answer is, again, by the way, there are two correct answers, so if you've selected one, please press pause here again and select one more. And the correct answers are option B and option D, grub.config. So, as you remember, grub2, it's a Grand Unified Bootloader version 2, which is a crucial component in most modern Linux systems. In a standard grub2 installation, you'll find several important files. Two files are typically present, are i386pe lvm.mod and grub.config. The first file is a grub module file, specifically for handling logical volume management or LVM partition, and grub.cfg, it's the main configuration file for grub2 containing menu entries and other settings. Let's switch to our Linux system and explore the grub2 files discussed. So first let's type ls boot grub2, and let's double press tab key. As you can see, we've got this i386pc directory. And by the way, there was a typo here, not PE, but PC. So please remember this correct version for the test. Let's continue with checking our answer. So we'll list i386-PC and double press tab here again. We'll get 290 possibilities. No, we don't need them. So we'll type lvm, hit tab, lvm mod. There is such a file in grub2. Okay. And the second answer was grub2 grub.cfg file. Here it is. We could also examine the contents of this grub.cfg file. Be careful not to modify this file. So let me clear the screen and type cat. Actually, let me rerun the previous command, go back to this ls command and replace it with cat, and we'll get the contents of this configuration file. And by the way, now we are examining grub2 directory. Let's try to replace it with grub directory. I'll double press tab here. So there is no such a directory. If we ls boot, we won't find this grub directory as I've specified in this correct answer. So please remember that the correct for this particular system will be grub2. But if there is no any options on your exam question except grub directory, select grub directory. And again, PC instead of PE. Our next question relates to file search commands. So the question is, which commands locate all files and directories in TMP directory and its subdirectories owned by root? Is it find /tmp user root print filed path tmp -uid root find tmp uid root print find tmp user root or find path tmp user root print? Press pause here and think about the correct answer. And the correct answer is, and by the way, you can specify several answers. So file search commands are A, find tmp user root print, and D, find tmp user root. So this find command is a versatile tool for locating files and directories based on various criteria. In our first example, we're focusing on finding files owned by the root user within the /tmp directory and its subdirectory. And as you remember, the two correct approaches to accomplish this task are find command followed by the path /tmp user root -print. This command searches the tmp directory and all its subdirectories for files owned by root and prints the results. And the second command is similar to the first, but the print option is implicit and doesn't need to be specified. It's important to know that the user option is used to specify the owner, while UID would be used if we wanted to search by user ID instead of username. Let's practice this example in the console and type this command. Let's first change to root directory. Now let's change to root with su command. Okay, I guess root's password not set up here on this macOS. Let me switch to CentOS Linux using parallel. Here it is, and I'll cd back / to change to the root of the file system. Clear the screen here. ls. Let's change to root with su command. And again, root password is not set up here. So let's do the setup of root password. So I'll first sudo su and I'll type passwd root, and let's create a password for root, repeat it. Now I'll exit from this sudo prompt, clear the screen and type su dash, for example. Provide my password, root's password, and now we are successfully changed to root with su command. Now let's create a directory with mkdir and we'll name it tmp. We'll cd to tmp directory and create some files here with touch command. Let's say file 1.txt, and we'll create one more directory, mkdir, followed by let's say sub1, and create one more file with touch command. Let's name it file2.txt, and we'll create it in sub1 directory. Let's list it. Okay, let me get back to my home directory, pwd. As you can see, we are located in root's home directory, which is /root. As you remember, root has got its separate home directory. It's not located in home directory where all regular users are located, but it's located in /root. Let's clear the screen, and now we'll write this find command. From our question example, we'll type find tmp user root followed by print. Okay, as you can see, we've got lots of files from tmp directory. Let's clear the screen and rerun this command without this print option, and it runs successfully as well. So that's how you use find command to locate files and directories based on this particular criteria. When you want to focus on finding files owned by the root user within the tmp directory. So if we clear the screen and ls one of the files with la parameters, and let's type tmp, double hit the tab, we'll find 110 possibilities, and only several of them, as you could see from the previous output, were owned by root. So let's double check it. We'll find some file, let's say this one. I'll copy it, or actually this one is short .xim. So I'll type ls-la tmp.x, and it was xim, I guess. As you can see, it is owned by root. Just to double check that this find command worked exactly as expected. Our next question is related to vi command for deleting lines. So the question is, which vi command deletes two lines, the current and the following line? Is it D2, 2D, 2DD, DD2, or DE12? Press pause here and think about the correct answer. And the correct answer is option C, 2DD. So when we focus on deleting lines in VI editor, as you remember, it's the powerful tool for text manipulation in Unix-like systems, and it's got a wide array of commands for efficient editing. So to delete two lines in VI, including the current line and the one below it, the correct command is 2dd. And actually this command consists of two commands. The first one is dd. It's the command to delete the current line. And when we prefix it with 2 or any other number, VI will repeat the command that many times. So it could be 9dd or any other number. Also, please remember that VI operates in different modes. These commands are used in normal mode. If you're in the insert mode, you'll need to press escape first to return to normal mode before using these commands. Now let's practice these commands, and for this we'll first create several lines document with echo command. So I'll type echo-e, and let's create line 1 followed by \n that tells that the next line is on the next line. Line 2 will be on the next line. Again, we'll add \new line 3, and we'll do the same with line 4 and line 5. Let's close the double quotes and redirect the output to, let's say, practice.txt file. Let's cat this practice.txt file. Here it is, line 1, 2, and 3, 3, and 4, and 5. Now let's open this file in VI editor, so I'll type vi practice.txt. As you can see, we got 5 lines we just created. Now let's delete this third line. So I'll press just dd and the line is gone. Now let's delete 2 more lines. I'll press 2. As you can see, we've got this 2 printed out here. And now I'll press dd. 2 more lines are gone. So now we see only first 2 lines kept in this file. Let's save this file with W and Q for quit. And if we rerun cat command again, we'll get 2 lines left. So please remember that we use prefixing with a number repeats the command that many times. And that prefix could be used with any VI command as dd or yonkin or any other command. Moving on, and the next question is related to reserved space in ext4 file system. And the question is, what is the default percentage of reserved space for the root user on new ext4 systems? Is it 10%, 3%, 15%, 0%, or 5%? Press pause here and think about the correct answer. And the correct answer is option E, 5%. So when talking about file system management and discussing the concept of reserved space in ext4 file systems, by default, ext4 file systems reserve a small percentage of the total space for the root user. This reservation serves 2 primary purposes. It ensures that root can log in and perform essential system tasks even if the file system is otherwise full, and it helps reduce fragmentation by keeping some free space available. And the default reserved space on new ext4 file system is 5% of the total space. This value strikes a balance between providing a safety margin for root operations and maximizing usable space for regular users. It's worth noting that while 5% is the default, this value can be adjusted using the tune to fs command if needed, depending on the specific requirements of your system. Now let's practice this question on our test machine, and we'll start with examining the reserved space on an ext4 file system. Now, let's start with using the tune to fs command to view the current settings. First, we need to identify an ext4 partition. Let me list the block devices here first, so I'll type ls blk. Now let's type sudo. Remember that we use tune to fs with administrative privileges, so we'll need the sudo command first, then tune to fs command -l list, and let's list our dev SDA device. And then we'll grab the following information: reserved block count. So I'll type reserved block count. We'll provide our password here. As you can see, it found a DOS partition for dev SDA device. So it's not an ext4 partition. Let me clear the screen and let's create, or actually let's show the number of reserved blocks for a for some particular partition. Let me rerun this command. And now I'll add SDA1 to this command. Again, we'll get an error because it's not an ext4 partition, but that's the command you'll need to run on ext4 partition. And SDA2, for example, and so on. But if you are running on ext4 partition and get the number, then you'll need to divide the reserved block count by the total block count and multiply by 100 to find out that you should get close to 5% for most of ext4 partitions. This question is related to here document output. And the question is, which command outputs test to the shell? Is it cat less than exclamation point EOT, cat pipe EOT, cat exclamation point less than EOT, cat ampersand less than EOT, or cat double less than symbol EOT? Press pause here and think about the correct answer. And I'll reveal the correct answer in just a second. And it is option E, cat less than EOT, which stands for end of file. So let's take a closer look at this concept of here documents in Linux. A here document, often referred to as a here doc, is a unique method of input redirection. It allows you to input multiple lines of text directly into a command or script. And the correct syntax for a here document is this one, cat less than EOT keyword, or end of line. This command tells the shell to read input until it encounters a line containing only the specified delimiter. And this delimiter, by the way, could be different from this one. Just in this case, it's EOT. And everything between the command and the delimiter is treated as input. In our case, this part will be included in this between these delimiters. And as you can see, we've got opening delimiter and closing delimiter here. So this method is particularly useful for creating a multi-line strings or passing multi-line input to commands without the need for external files. Now let's start a practical exercise on here document. I'll switch to my test machine. I'll log into this test machine with my password, clear the screen. And by the way, I can run it on my local host terminal. So now when our terminal is opened, let's type the following command. Cat, then as you remember, we've got double less than characters and the keyword, which is EOT delimiter. And now when we press enter, you can see that we started here doc. So now we can type all the text we need to be in this document. For example, hello, comma, this is a test of the here document. Now I'll press enter here and we go to the next line. For example, we can type, we can write multiple lines like this. And again, we can go to the third line and type some more text. For example, when we are done, we just type EOT on a new line. So it should be on a new line. When we hit enter, here we'll type EOT and that will finish this here doc. Let me hit enter here. As you can see, we've got this multi-line here doc as an output to the terminal. This technique is incredibly useful for creating multi-line strings or passing multi-line input to commands without needing external files. Now try creating your own here document and remember you can use any word as the delimiter instead of EOT if you prefer. For example, EOF or any other word as a delimiter. The only rule is to use these delimiters on the new line. The next question relates to file system check interval. So which command alters the interval for full file system checks on an ext3 file system? And we've got 5 options here. Is it tuned to fs-d 200-i-c or -n? Or is it tuned to fs-days 200 followed by the device name? Press pause here and think about the correct answer. And the correct answer is option B, tune to fs-i200 followed by /dev sda1. So file system maintenance is quite an important question, specifically modifying the interval for file system checks on an ext3 file system. The question at hand is which command changes the number of days before a full file system check is required during boot for an ext file system on dev sda1. And as you remember, the correct answer was tune to fs-i200 dev sda2. So here is what this command does. Tune to fs, the command itself, is used to adjust various parameters of ext2, ext3, or ext4 file systems. The next part of our one-liner is -i200, which sets the interval between checks to 200 days. And finally, dev sda1 is the target device. So the command is crucial for balancing system integrity with boot time efficiency. Regular file system checks are important, but running them too frequently can lead to unnecessary delays during system startup. Let's take a look at practice how to use this command. And let me create a test ext3 file system image first. I will use dd command for this purpose. I'll type dd, then followed by the input file, which is if, and input file will be at dev-0, not dash, but / sorry. And then we'll need an output file, which will be, let's say, test.img, test image. And now we'll need to provide block size with bs command or sub command, which will be 1 megabyte, right? And we'll create such blocks. We'll create 100 such blocks. Okay, let's run this command. We'll ls the contents. Here it is, test.img file. And now let's make it ext3 file system. So I'll type mkfs.ext3 and provide the image name, which is test.img. Hit enter, done, and we can continue. Now let's view the current file system parameters for this image. Let me clear the screen and we'll type sudo tune to fs command with -l parameter and provide the file name, which is test.img. Then we'll add a pipe here and search for check interval. Okay, we'll provide our password here. Check interval none. Now let's change check interval to 200 days. So again, we'll use sudo tune to fs command -i 200, and then we'll specify the image test.img. As you can see, it has set the interval in seconds. Now we can double check it by verifying the changes. So I'll get back to the previous command, sudo tune to fs-l test.img grep check interval. And as you can see, it's 6 months, 2 weeks, 6 days. And of course, in real world scenario, you'd replace this test.img file with your actual device, for example, dev sda1, and you'd need appropriate permissions to modify system file system. The next question relates to line break conversion. So the question is, which command converts cr-lf line breaks to lf in a text file? Take a look at the options and think about the correct answer. And I'll reveal the correct answer in just a second. So the correct answer is option A. Here it is. That'll solve our task. So when talking about text file manipulation, it's a common task in Linux administration to convert text files between different formats, particularly when dealing with files created on different operating systems. And in our scenario, we have a text file which is userlist.txt with Windows style line endings, which is cr-lf, that you need to convert to Linux style line ending, which is LF. And which command we'll use? As you remember, we'll use this tr-r-d. Here, the command itself is tr. It's the translate command. Then -d followed by, in single quotes, \r. It tells tr to delete all carriage returns. Then the file userlist.txt, it's the input file. And then we redirect it to newlist.txt, it's the output file. This command effectively removes all carriage returns, leaving only the line feeds, thus converting the file to Linux format. Now let's practice with this example. Let's first create a sample Windows style text file. I'll use echo command for this. I'll type echo -e, then in double quotes, line 1. Let's add a space here, followed by \r/new line, and that'll be line 2. And again the same, r/new line, and that'll be line 3. Close double quotes and redirect it to userlist.txt file. Hit enter. Let's cat the contents of this file, but we'll also use -A and the file name, which is userlist.txt. Now, as you can see, we've got this caret symbol followed by $M at the end of each line, representing the cr-lf line ending, which is Windows style. Now let's convert it to Linux format with the command we've had in our question, which was, the correct answer was tr-d. Then in single quotes, we'll add this \r character and we'll input to this command from our userlist.txt file, and then the result will output to the new file, for example, newlist.txt. Hit enter. Now let's read the new file with cat-A. So I'll add new file, newlist.txt file. Now we see only $ at the end of each line, representing just LF file, LF line ending. Moving on, and our next question relates to process signals. So the question is, which signal is sent to a process when the key combination Ctrl+C is pressed? Is it seek term, seek con, seek stop, seek kill, or seek int? Press pause here and think about the correct answer. And the correct answer is option E, seek int. So again, let's recall process management and the signals we can send to processes. These keyboard shortcuts often trigger specific signals, and understanding this can greatly enhance your system control. And when you press Ctrl+C on your keyboard, you're actually sending a signal to the current process. This signal is called seek int, which stands for signal interrupt. It's a polite way of asking a process to terminate. Why seek int and not seek kill or seek turn? Well, seek int allows the process to catch the signal and clean up before exiting. It's like knocking on a door instead of breaking it down. This approach helps maintain system stability and data integrity. So please remember that different signals serve different purposes. While seek int is an interruption, ckill is a forced termination. Here it is. And ccont is used to continue a stop process. Each has its place in the toolkit of a proficient Linux user. Let's practice the signals a bit on our testing machine. I'll clear the screen first and let's initiate a ping command. So we'll type ping google.com. Hit enter, that'll start pinging process, and this time we'll use, instead of Ctrl+C, we'll use Ctrl+Z, and you'll see a message like this: stopped ping google.com, and Ctrl+Z above this line. Now to bring it back to the foreground, you'll use fg command. So let me type fg. Again, it continued to run this command, ping google.com. And finally, we can end it with our trusty Ctrl+C. So I'll press Ctrl+C, and that will terminate gracefully this process. So again, to remind you, Ctrl+Z to suspend the process, not terminate, and Ctrl+C to interrupt the signal and terminate it. Here it is. Our next question is related to grub installation. And again, the question is, which command installs grub boot files into active file systems and the bootloader into the first partition of the first disk? Is it grub install dev SDA, grub install dev SDA1, grub install current dev SDA0, grub install dev SDA0, or grub install current dev SDA1? Press pause here and think about the correct answer. And the correct answer is grub install command. It's for sure. But the path is dev SDA. So here we've got option A as the correct answer. Again, to remind you, grub stands for Grand Unified Bootloader. And again, as you remember, it's a crucial component in the Linux boot process. So the command grub install dev SDA is what we use to install grub boot files into the currently active file systems and the bootloader into the first partition of the first disk. So we've got grub install, the command itself, here it is, and dev SDA refers to the entire first disk in the system. It's crucial to understand that we are targeting the entire SDA disk here, not a specific partition like SDA1. This ensures that grub is installed correctly and can manage the boot process for all partitions on the disk. And again, to have some practice, you'd use ls bulk first to see what disks are available on your system without making changes. This will list all blocked devices, giving you an idea of your disk layout. And then you'll run the command itself, which is sudo. Again, to remind you, you need to use administrative privileges here. So you type sudo, then grub-install dev SDA. That can give you an error because if you have grub version 2 installed, you'll need to use grub2 command, followed by dev SDA. I won't be running this command because it's already installed on this particular virtual machine, but that's the command you need to run and to answer this question correctly. Again, let me remind you the question: which command installs grub boot files into active file systems and the bootloader into the first partition of the first disk? And you don't use SDA1, but use SDA, just SDA. Our next question is about package management. And the question is, which apt-get subcommand installs the newest version of all currently installed packages? Is it auto-update, dist upgrade, full upgrade, install, or update? And the answer is option B, dist upgrade. As you remember, apt is Advanced Package Tool. It's a powerful set of tools used in Debian-based distributions for managing software packages. When it comes to upgrading, and in our case updating all installed packages to their newest versions, the dist upgrade subcommand is your go-to option. Unlike a simple upgrade, or dist upgrade is more intelligent in handling dependencies and will even remove obsolete packages if necessary. And to perform a distribution upgrade, you'll run sudo apt-get dist upgrade. This command will not only update your existing packages but also handle complex dependencies changes, ensuring your system remains stable and up to date. Remember, while dist upgrade is powerful, it's always wise to review the proposed changes before confirming their upgrade, especially on production system. Let's switch to our Ubuntu server. I'll launch Ubuntu 22.04 and let me log in. And here let's run this command and see how it is going. Let me clear the screen. First, let's update our package list. I'll type sudo apt-get update. That'll fetch all necessary updates for this system. And it'll take some time, a minute or two, depending on your internet speed connection speed. Okay, it's done. Let me clear the screen. And now, before running sudo apt-get dist upgrade, let's run the following command: sudo apt-get --dry run dist -upgrade. Hit enter, and that'll show you what would be upgraded without actually performing the upgrade. As you can see, we've got quite a long list of what will be upgraded on this system if we run sudo apt-get dist upgrade. Now, if you are ready to perform the actual upgrade and you are not on a critical system, you can run sudo apt-get dist upgrade. Let me clear the screen, and as it is a test server, I'll run this command. So let me find the command itself. I'll remove this dry run option and run the command. So as you can see, it offers that 581 packages upgraded, 354 standard security updates, and so on. And that'll take roughly 1.3 gigs of space. So if I now hit Y, that'll do the operation. In my case, it's not so much crucial, so I'll hit no to cancel this action because we've needed it to just demonstrate you the concept. The next question is as follows. It's related to RPM package query, and the question is, which command lists all currently installed packages when using RPM package management? Is it RPM query all, RPM list installed, RPM query list, yum query all, or yum list installed? Press pause here and think about the correct answer. And the correct answer is as follows. It's option A, RPM query all. So as you remember, RPM is Red Hat Package Manager. One of the most fundamental tasks in package management is querying the system for installed packages. And the command rpm-query-all is our go-to tool for this task. This powerful command lists all currently installed packages on an RPM-based system. It's important to note that the syntax we use here is 2 dashes for full word options like query and all. So let me switch on to the system based on Red Hat Linux. It's CentOS 9. and try running this command. So I'll type rpm query all, and that will list all the packages installed on this system. As you can see, there are quite a lot of packages. We could use less pager, so with add pipe and add less pager here, and we can press space to go through all these pages of RPM packages, which we can list with RPM query all command. To exit this pager, I'll press Q and I'll clear the screen. Our next question is as follows. Which command installs grub2 into the master boot record on the third hard disk? Is it grub2 install dev sdc, grub mk rescue dev sdc, grub mbr install dev sdc, grub setup dev sdc, or grub install dev sdc? Press pause here and think about the correct answer. And the correct answer is option B, I'm sorry, as I'm reading it, it's not the correct answer. The correct answer is option E, grub install dev SDC. So as you remember, grub2, it is an abbreviation for Grand Unified Bootloader version 2. grub2 is a crucial component of many Linux systems, responsible for loading and transferring control to the operating system kernel. When it comes to installing grub2, the command you use is critical. The correct command to install grub2 into the master boot record of a specific disk is grub install, and you use it with sudo. So the command could look as follows: grub install dev sdc. So please remember that this command requires root privileges and the specification of the target device. It's important to note that the device name, in our case it's dev.sdc, may vary depending on your system configuration. Always double check the device name to avoid unintended consequences. Let's try out this command and switch to our terminal, and let me launch CentOS Stream 9 from the Parallels Control Center. I'll clear the screen here. So we can list the devices I've got on this virtual machine with ls-blk command, ls bulk. And as you can see, I've got only one device, SDA, so I haven't got the second and the third disk to install grub on. But let's run this command, let's type this command without running. So for this we could use sudo grub-install dry run dev, let's say SDA. I'll provide my sudo password and we get command not found here. Let's try grub2 install dry run dev SDA, and we get that it is unrecognized option with dry run. Yes, indeed, we don't have such an option, dry run, for grub2 install. And to read about how to use this command, you could type grub2 install help. Scroll up and you'll get all different options for grub2 install command. But in any case, you use either grub-install followed by the device name, or grub2 install followed by device name. Commands to install the master boot record of a specific disk. Moving on, and the next question is, what is the effect of appending an ampersand to a command? And the options are as follows. The command's output is redirected to dev null. Option B, the command is executed in the background of the current shell. Option C, the command's output is executed by the shell. D, the command is run as a direct child of the init process. And finally, option E, the command's input is read from dev null. Press pause here and think about the correct answer. And the correct answer is option B. The command is executed in the background of the current shell. So as you remember, you can run background processes. When working with the command line, you'll often encounter situations where you want to run a command without waiting for it to complete. This is where the ampersand comes into play. By appending an ampersand to a command, you're instructing the shell to run that command in the background. This means the command will execute independently, allowing you to continue without the terminal for other tasks. It's a powerful feature that enhances your productivity and efficiency when managing multiple processes. For instance, if you are running a time-consuming task like a system update, you might use this sudo apt update followed by the ampersand. This command will start the update process in the background, freeing up your terminal for other operations. Let's practice using this ampersand powerful tool. So, for example, we run the following command sleep. Let's use 6. It will sleep for 6 seconds. As you can see, we cannot use our terminal right now and issue any commands because the terminal is busy running this sleep 6 command. Now, if we add an ampersand at the end of the command, we'll be able to use our terminal. Let's run sleep 600 and add ampersand to this command. Hit enter, and as you can see, we've got the process ID for this command, and we can carry on using our terminal. So this demonstrates how this ampersand runs the command in the background. Just this simple addition. And we can issue any other commands like date, for example, or other commands while the sleep 600 is running at the background. We can bring it to the foreground, as you can see, and now this sleep 600 command is using our terminal and we cannot issue while it's being run at the foreground. And again, background, but before running bg command, we'll need to suspend this command and then run bg command. Moving on to the next question, which is related to VM cloning. So the question is, which properties of Linux system should be modified when cloning a virtual machine? Is it a partition scheme, B, file system, C, dbus machine ID, D, permissions of root, and finally E, SSH host keys? Press pause here and think about the correct answers. There are 2 correct answers for this question. And the correct answers are as follows. Option C, which is dbus machine ID, and option E, SSH host keys. So when cloning a virtual machine, you'll need to remember which properties should be modified. This is a crucial consideration for maintaining system security. 2 key properties require attention: the dbus machine ID and the SSH host key. Why these 2? Well, the dbus machine ID is a unique identifier for each system. When you clone a VM, you're essentially created a copy of the original system. If multiple systems have the same dbus machine ID, it can lead to communication issues and potentially security vulnerabilities. Similarly, SSH host keys are crucial for secure communications. If cloned, VMs retain the original SSH host keys, and it could compromise the security of your network. Imagine if an attacker gained access to one VM, they could potentially access or access all clones with the same SSH keys. It's worth noting that while the partitioning scheme, file system, and root directory permissions are important, they don't typically need to be changed when cloning a VM. Our next question is on process niceness. And the question is, what is the maximum niceness value that a regular user can assign to a process with the nice command when executing a new process? Is it 9, 15, 19, 49, or 99? And the correct answer is 19, option C. So, as you remember, there is such a concept in Linux as process niceness. Niceness is a way to influence the CPU scheduling priority of a process. The nice command in Linux allows users to start a process with a modified scheduling priority. However, there are limitations on how much a regular user can modify this priority. The niceness value in Linux range from -20, it's the highest priority, to 19, it's the lowest priority. Regular users are restricted in how much they can increase a process's priority. They can only make a process nicer, lower its priority, up to a certain point. The maximum niceness value that a regular user can assign to a process using the nice command is 19. This means a regular user can decrease a process's priority as much as possible, but they cannot increase it beyond the default. It's important to know that while regular users can increase niceness or lower priority, up to 19, only the root user can set negative nice values to increase a process's priority. Now let's try this out on practice, and again I'll switch to my terminal and let's start a process with default niceness. Again we'll type nice, that is the command, and now we'll type nice-n0 sleep 1000 seconds, and we'll start this process at the background. So here is speed for this process, and we can continue, we can check its niceness value. We'll type ps-o followed by pid com nice-p dollar exclamation point. And we'll get that nice level is 5, pid 19800, and the command is sleep. Now try to start a process with the maximum allowed niceness for a regular user. So we'll find this command and let's change this 0 to 19, and everything else is the same. Again, we started this process. Let's rerun the previous command, and as you can see, nice level is 20. Now let's try to set a negative nice value. I'll type nice -n -1, for example, sleep 1000, and we'll get set priority permission denied. And that's correct. If we do the same with sudo, so I'll add sudo and then add ampersand here, hit enter. So we managed to start it with root. Our next question is on XFS file system recovery. So the question is, after a power outage, the XFS file system of dev SDA3 is inconsistent. How can the existing file system errors be fixed? And there are 5 options here. Option A, by using mount-f to force a mount of the file system. Option B, by running XFS check disk on the file system. Option C, by mounting the file system with the option XFS repair. Option D, by running XFS admin repair on the file system. And finally, by running XFS repair on the file system. Please press pause here and think about the correct answer. And the correct answer is option E, by running XFS_repair on the file system. So XFS is a high-performance journaling file system, but like any file system, it can become inconsistent due to unexpected events like power outages. When dealing with an inconsistent XFS file system, it's crucial to use the correct tools and procedures. Unlike some other file systems, XFS doesn't use a tool called FSCK for checking and repairing. The correct tool for repairing an XFS file system is XFS Repair. This utility is specifically designed to check and fix XFS file system inconsistencies. It's important to know that you shouldn't try to force mount an inconsistent file system, as this could lead to further data corruption. Also, there is no need to use special mount options for repair. The repair process is separate from mounting. So to fix existing file system errors on XFS file system like dev SDA3 in our example, you'd run the XFS repair command on the unmounted file system. This tool will check the file system for inconsistencies and repair them if possible. Our next question relates to hard links. And the question is, when considering the use of hard links, what are valid reasons not to use hard links? And there are 5 options. Option A, hard links are not available on all Linux systems because traditional file systems such as ext4 do not support them. B, each hard link has individual ownership, permissions, and ACLs, which can lead to unintended disclosure of the content. C. Hard links are specific to one file system and cannot point to files on another file system. D. If users other than root should be able to create hard links, SULN has to be installed and configured. And E. When a hard linked file is changed, a copy of the file is created and consumes additional space. Press pause here and think about the correct answer. And the correct answer is option C. Hard links are specific to one file system and cannot point to files on another file system. Let's create a new file. Let's name it original, and I'll use echo again and some text. For example, this is our test file, and we'll redirect it to original.txt file. Now let's create a hard link to this file with ln command, ln original, and we'll name it hardlink.txt. Let's verify that both files point to the same inode with ls command -li, and we'll find original file and hard link file. As you can see, inodes are the same, 144, 144. Now let's try to create a hard link across file systems. The next question is related to man pages location. So according to the file system hierarchy standard or FHS, which are man pages typically stored? Where are man pages typically stored? Is it option A /opt/man? Is it USR doc? Option C USR share man? Option D var pkg man? Or option E, var man directory. Press pause here and think about the correct answer. And the correct answer is option C. It's located in USR share man directory. So let's discuss a bit the location of man pages in Linux systems. Man pages, short for manual pages as you remember, are an essential resource for any Linux user or administrator, providing detailed documentation for commands, system calls, libraries, and more. According to the File System Hierarchy Standard, or FHS, which provides guidelines for directory structure and directory contents in Linux and other Unix-like operating systems. So according to this system, man pages are typically stored in the USR share man directory. Here it is, and please remember this path. This standardized location ensures that users and applications can consistently find documentation across different Linux distributions. When you use the man command to view documentation, it searches automatically this directory, among others, to find the requested man pages. So, understanding this structure can be particularly helpful when troubleshooting missing documentation or when you're working on systems with non-standard configurations. Let's switch to our demonstration machine and verify the location of man pages on our system. So we'll use find command to search for man pages in the standard location. I'll run the following command. Find, and then usr share man, and then we'll be looking for type, file, F, and I'll add a pipe here. Let's redirect it and find 5 first lines. So we'll do this with head-n5. Hit enter, and as you can see, system found 5 different files in this default man pages location, which is usr share man. So this output confirms that man pages are indeed stored in this location as specified by the file system hierarchy. And by the way, now we are using Z shell. Let's try to switch to bash running on CentOS Linux and rerun this command here. So I'll type find usr share man, and we'll be looking for type file, and again we'll run head-n5 first entries. Okay, now these lines are different, but the location is the same. It is located in usr share man directory. Again, according to specified by the file system hierarchy standard. And one more example, let me launch Ubuntu system really fast and run the command here. I'll type find usr share man type file and head-n5. Again, these entries are totally different, the first 5 entries, but the location of man pages is the same, which is usr share man, according to the file system hierarchy standard. Our next question is related to removing special directory. And the question is, a user inadvertently created a subdirectory named /dir in their home directory. Which command will remove this directory? Is it rmdir ~/2 \sdir, or option B, rmdir ~/dir? Option C, please take a look at this option. Option D and option E, rmdir in single quotes ~/dir. Press pause here and think about the correct answer. And the correct answer is option D. It's ~/dir. So let's address this common issue that many Linux users encounter, dealing with directories that have special characters in their names. Imagine a scenario where a user, like in our question, accidentally created a subdirectory named /dir in their home directory. This / character has special meaning in many contexts, including the command line, which can make it tricky to manipulate such directory. And to remove this directory, the correct command would be the one we had in our answer, rmdir ~/dir. So here this tilde expands to the user's home directory. As you remember, tilde always is associated with user's home directory. And the / character before the dir is treated as an escape character, telling the shell to interpret the next character, in this case D, literally. It's important to note that while other options like using quotes might seem intuitive, they don't always work as expected with the rmdir command. So let me switch to the shell and first create this directory. I'll type mkdir. And by the way, let me change to my home directory. If I pwd, as you can see, it's my home directory, and this tilde shows that it's my home directory. Now I'll type mkdir tilde, which is my home directory, /, and now we'll name the directory /dir. If we ls, we'll find that we've got dir directory in our home directory. If we ls this dir directory, and we've got this tilde directory. Let's ls this tilde directory as well. And if we do so, it ls's our home directory because tilde is our home directory. Okay, how do we ls this directory we've just created or verify its creation? We do this with such a command, ls-la followed by tilde and /, and then we'll grab in quotes, in single quotes, like this, two backslashes dir. And in our case, we don't have such a directory because the directory, the one we've created, is named just dir. This shell hasn't created this directory with /. So let me switch to the bash shell and rerun this command. Again, I'll cd to my home directory and try to create such a directory here with mkdir tilde / dir. Now if we ls, again we don't see such a directory with just ls. Let's try to run ls-la tilde / and then grab in quotes /dir. So again, no results. Let me clear the screen. Let's rerun this command with one / and we'll get this directory. As you can see, the date created is correct. So instead of grab /, we'll grab one / followed by dir. And by the way, we can do this on this shell as well. So let me remove it. And in this case, it doesn't reveal even with one /. Okay, the main task was to remove this directory and to find the correct command. Let's try out this command. rmdir tilde / dir. Let's rerun the previous one, and we haven't got such a directory dir. But in any case, you should remember that be careful with using this special character, such as / when naming the directories. As you can see, you'll get lots of troubles manipulating such directories because bash treats the special characters specially. That's why they are named so. Let me remove this directory here on this shell as well. I'll type rmdir dir. Our next question relates to command handling in shell. And the question is, which command reveals how the shell processes a specific command? And the correct answer is option. By the way, all of these commands or some of these commands are true for Linux system. And the options are where, type, stat, case, file, info. Press pause here and think about the correct answer. And the correct answer is option B, type. So as you remember, the shell is the interface between the user and the operating system, interpreting and executing the commands we input. One particularly useful command for understanding this process is the type command. This command reveals how the shell handles a specific command, providing valuable insights into the command's nature and location. For instance, when you run type ls, you might see output like bin/ls, indicating that ls is an external command located in the /bin directory. Alternatively, for built-in commands like cd, you'd see output stating it's a shell built in. Like in this case, if we type cd, it'll show it's a shell built-in command. Let's try out these commands in our shell, and we'll type ls, and we'll read ls is bin ls. So it's an external command typically located in this directory. Now let's see with type cd. cd is a shell built in. We can try more commands like type which is a shell built in, type git. Git is located in usr bin git directory, and so on. So please try a few more commands of your choice. Executing this will help you to understand the nature of different commands you use regularly. Our next question is on file system information. Which commands can display the inode number of a given file? You should select two correct answers. Is it inode, ln, ls, cp, or stat? Press pause here and think about the correct answers. And the correct answers or options are option C, ls, and option E, stat. So when we need some file system information, specifically focusing on inode numbers, we can use these commands. As you remember, in Linux, every file and directory is represented by an inode, which stores metadata about the file. Two commands stand out for displaying the inode number of a given file. As you remember, they are ls and stat. The ls command, which is used when used with -i option, it'll display the inode number along with other file information. This command is versatile and commonly used for listing directory contents. On the other hand, the stat command provides a more comprehensive view of the file metadata, including the inode number. It offers a detailed snapshot of a file status. While inode, ln, and cp are valid Linux commands, they serve different purposes and don't directly display inode numbers. Let's practice a bit with these commands. Let me clear the screen and I'll type ls first, and let's say that we want to examine this file archive.tgz. So I'll type ls-i followed by the file name archive.tgz, and that'll display the inode number, here it is, with the file name. Now let's use stat command. So I'll type stat archive.tgz. This provides more detailed information about the file, including its inode number. Here it is, ending with 695. Our next question relates to archive management, and the question is, which command shows the contents of a gzip compressed tar archive? Is it gzip archive.tar, pipe tar xvf? Is it option B, tar-fzt archive.tgz? Option C, gzip-d archive.tgz, pipe tar tvf? Option D, tar cf archive.tgz, or option E, tar ztf archive.tgz? And the correct answer is option E, tar ztf archive.tgz. So when we encounter a common task like viewing the contents of a compressed archive, we can use tar command in conjunction with gzip. So it's a very common task for handling archives. The command that efficiently displays the contents of a gzip compressed tar archive is tar ztf and the file name. So The command itself is tar. Tar is the command for tape archiving. Z tells tar to use gzip for compression decompression. T lists the contents of an archive, and F specifies that we are working with a file. This command allows you to peek inside a compressed archive without actually extracting its contents, saving both time and disk space. While other combinations of commands might seem logical, they either perform different actions or are syntactically incorrect. Now let's practice a bit with archiving. Let me list the contents of this directory, and let's say that we want to place these files, which starts with split word, to archive. For this I'll move all files starting with split, and I'll place asterisk here, and let's place it or move it to test underscore dir directory. First we'll need to create it, mkdir test underscore dir, and then rerun this command, move split asterisk test dir. Now if we list this test underscore dir, we'll get all these files there, and if we list the current working directory, these files are gone. Now let's say that we want to archive, create a simple archive of this directory. So for this we'll type tar -czf. Let's name it archive.tgz. And now we'll specify that we want to archive this test underscore dir. Hit enter, let's list the contents, and we'll find this archive.tgz file. Now, to view the contents of this compressed archive without extracting it, we use the command we learned, which is tar ztf, and we specify the name, which is archive.tgz, and that will list all the files we've placed or put to this archive. It also shows the directory itself, which is test underscore dir, and all the files this directory contains. Moving on, and the next question is on file manipulation. Which command divides a file into separate segments of a specified size? Is it R command, cat command, break, split, or parted command? And by the way, these are all commands we can use. Press pause here and think about the correct answer. And the correct answer is option D, split command. So let's focus on the commands on file manipulation. One particularly useful command in this category is the split command. This versatile tool allows us to divide a large file into smaller, more manageable pieces. The split command reads a file and creates separate chunks of a given size from the file's content. This can be incredibly helpful when dealing with large data sets or when you need to transfer files in smaller segments. For instance, if you have a massive log file that you need to analyze in parts, split can be your go-to solution. It worth noting that while other commands like rcat, cat, break, and parted have their specific uses, they don't perform the same functionality as split command. Each of these commands serve a different purpose in the Linux ecosystem. Now let's take a look at the demonstration of how to use this split command in practice. I'll switch to my terminal and we'll create a sample log file first. We'll do this with the echo command again, so I'll type echo. This is a sample log file, and we'll redirect it to, let's say, server underscore log.txt file. Now let's run some simple bash scripting here. So I'll use for keyword I in, and we'll use curly braces here and the range from 1 to 1000, let's say. We need a large file. then we'll add semicolon, do, echo, then we'll add some text, for example, log entry, and we'll use a variable which we've provided here. It's I variable. So for this, we'll add $I and we'll append this information to server underscore log .txt file, then add semicolon once more and add a done keyword. Okay, now if we cat this server underscore log.txt file, that will contain 1000 log entries. And if we run head -n1, oops, forgot the file, head -n1 server underscore log, that will contain our first statement. This is a sample log file, right? Now let's continue. Now let's use the split command to divide this file into smaller pieces, each containing, for example, 100 lines. So we'll type split -l 100 server log, and we'll provide a new name, which is split underscore log, and let's see what happens. If we type ls, we'll get several files, split underscore log underscore AA, AB, and so on. So this split command creates files names split underscore log and names the files accordingly, and each file contains 100 lines from the original log. So if we cat split underscore log underscore AA file, that will contain 99 entries. It contains actually 100 entries, but the last entry is log entry 99. And again, we can verify it with head-n, let's say 5 split log AA. And the first line will be, this is a sample log file, and then 99 more lines. So again, we use split command for dividing large files into smaller. Our next question relates to initial RAM disk. So which statements accurately describe the initial RAM disk in Linux boot process? You should select two correct answers. Option A, an init ramfs is a compressed file system archive examinable when unpacked. Option 2, an init ramfs file contains the MBR, bootloader, and Linux kernel. Option C, after a successful boot, init ramfs contents are available in run init ramfs. Option D, the kernel temporarily uses init ramfs before accessing the real root file system. And option E, an init ramfs is kernel version independent and unchanged post-installation. Press pause here and think about the correct answer. And the correct answer is, or actually two answers. Option A, an init ramfs is a compressed file system archive examinable when unpacked. And option C, the kernel temporarily uses init ramfs before accessing the real root file system. So initial RAM disk is a crucial component in the Linux boot process. The initial RAM disk, often referred to as init ramfs or initial RAM file system. At its core, an init ramfs is a compressed file system archive. This means that you can actually unpack it to examine its contents, providing valuable insights into the early boot process. After a successful boot, you might be curious about what happened to the contents of the init ramfs. Interestingly, they don't just disappear. In many systems, you can find these contents in the run init ramfs directory. Here it is, allowing for post-boot examination. It's a common misconception that the init ramfs contains the master boot record, or bootloader and Linux and the Linux kernel. In reality, the init ramfs is separate from these components. Its primary purpose is to provide the essential drivers and tools needed to mount the real root system or file system. The kernel's use of the init ramfs is temporary but crucial. It relies on the init ramfs to load necessary drivers and modules before it can access the actual root file system. Once the root file system is mounted, control is transferred and the system continues booting from there. Contrary to some beliefs, an init ramfs is typically specific to a kernel version and can change after the initial installation. System updates, especially those involving the kernel or hardware drivers, often require updates to the init ramfs to ensure proper booting with new or modified components. Now let's try to complete some practice exercises with init ramfs. So first off, let's locate our current init ramfs. I'll type ls and it is located in boot directory, not bot, but boot directory. And then init ramfs will add asterisk to find all files. As you can see, we've got 3 files here, 3 image files. Our next question is related to yum configuration. And the question is, which statements are accurate regarding yum configuration? You should select 2 answers. So the options are as follows. A. Repository configuration changes activate after running yum conf update file. B. Yum configuration changes require yumd service restore. C. Package repository configuration can be distributed across multiple files. D. Repository configurations may include variables like base search or release server. And option E, etcum.conf is ignored if etcum.repos.d contains files. Press pause here and think about the correct answer. And the correct answer is option C, package repository configuration can be distributed across multiple files, and option D, repository configurations may include variables like BA search or release var variables. So let's explore the configuration of yum, the package manager used in Red Hat based in Linux systems. Yum's flexibility in configuration is one of its strengths. First and foremost, it's crucial to understand that the configuration of package repositories in yum can be divided into multiple files. This modular approach allows for easier management and organization of repository information. So these repositories configuration files are typically stored in etc yum.repos.d directory. Each file in this directory can define one or more repositories, providing a clean separation of repository definitions. An interesting feature of yum's repository configurations is the ability to include variables. Common variables you might encounter include this BA search or base search and release var. These variables allow for dynamic configuration based on the system's architecture and release version. For instance, base search might expand to x86 underscore 64 on a 64-bit system, while release var could represent the major version number of your distribution. This feature enables a single repository configuration to work across different architectures and versions. Now, it's worth noting that changes to wrapper or repository configuration become active immediately. There is no need to run a specific update command or restart a service. Yum reads these files each time it's invoked. ensuring it always has the latest configuration. Contrary to some misconceptions, the presence of files in etc yum.repos.d directory does not cause yum to ignore etc yum.conf file. Both are used with etc yum.conf providing global configuration and etc yum.repos.d directory files providing repository-specific details. Now let's have some hands-on, and I'll switch to my CentOS Linux distribution. It's CentOS version 9. Let me change one level up from this directory, and I'll ls the contents. So first we'll create a new file system on a... Actually, we won't need it. Let's better start with looking at the main yum configuration file. For this, we'll use cat command, and the yum configuration file is an etc yum.conf file. If I hit enter, we'll reveal the configuration of this file. Now let's examine the repository configurations which we've mentioned in our presentation part of this lesson. So for this, I'll type ls etc yum.repos.d directory, and that'll reveal the contents of this directory. As you can see, we've got two repos right now, and we can go ahead and rerun the previous command, but we could add centos.repo, and that'll contain different files depending on the system. Now let's go ahead and create a new repository configuration. We'll type sudo nano etc yum.repos.d, and let's name it, for example, myrepo.repo. And in this file, and I'll provide my password first. So in this file, we'll need to add a simple repository definition. And the syntax of this definition is as follows. First, you specify the name, my repo, and then you'll provide name is my custom repo, for example. Then you need to provide base URL and specify this URL. You'll need to add the link to your repository. For example, http:// myserver.com repo. Then you could use the variable, for example, release var, and one more variable, base search. Actually, not base search, but base arc. And then you'll need to specify, is it enabled? Yes. And GPG check, something like this. This is just for demonstration purposes, how the custom repository configuration file would look like. And you'll save the file. So that's how you add a simple repository definition on Red Hat based Linux system. Our next question is on Linux boot process. And the question is, what is the initial program started by the Linux kernel during boot when using system v init? Is it option A /lib init.so, option B proxys kernel init, it was option B, and option C, it's etc rc.d rc init, option D sbin init, and option E boot init. Press pause here and think about the correct answer. And the correct answer is option D, it's sbin init. So as you remember, in traditional system v init systems, the first program started by the Linux kernel after it has initialized itself is sbin init. Here it is. Please remember, if you didn't know this yet, this program is crucial as it's responsible for bringing the system up into a usable state. The init process has process ID 1 or PID-1 and continues running until the system is shut down. It's often referred to as the parent of all processes, because it's responsible for starting and stopping essential system services. Now, while System V init has been largely replaced by more modern init systems like System D in many distributions, understanding this traditional boot process is still valuable for Linux administrators. It provides insight into how Linux systems are brought to life and how the various components of the operating system are initialized and managed. Now let's have some practice. And though this system is a system based system, we can still run some commands. For example, ps-p1. That will check the PID of the init process. As you can see, in my case, it's systemd process. If it were an older system, it will be init process. We can also view the init processes command line. For example, by typing cat proc1 command line. And that will reveal the init processes command line. We can also list the running services with systemctl command. So I'll type systemctl or control list units, and we'll need type service. That will list the running services, and please note that this command may vary depending on your init system. To exit from this list, again, we'll type q. So again, to remind you, in system V init, the sbin init is the first program started by kernel, and it has PID-1. Remember this information because you'll get questions on this information from time to time. Our next question is related to file content search commands. And the question is, which command can search file contents using regular expressions? Is it find, locate, grab, reggrab, or pgrab? Press pause here and think about the correct answer. And the correct answer is option C, it's grab. So again, to remind you, grab stands for Global Regular Expression Print. It's one of the crucial tools in the Linux Administrator's Toolkit. So it's a powerful utility that can search file contents using regular expression. This makes it invaluable for tasks like log analysis, code review, and system troubleshooting. While other commands like find and locate are useful for finding files based on names or attributes, grab excels at searching within files. It can search for complex patterns, making it much more versatile than simple string matching. For example, you might use grab to search for all occurrences of an IP address in log file, or to find all lines in a configuration file that don't start with a command character. Let's practice using grab a bit. I'll switch to my terminal again. Now let me clone my GitHub repository. I'll use, by the way, let's find out if we have Git on this system. Yes, we've got Git. So I'll use git clone https github.com learned lessons, and the repository name is Linux Learned. Invalid active developer path. Okay, some troubles on this my local host. I don't want to troubleshoot them. Let me switch to the test VM. And again, I'll check if Git is installed here. Yes, we've got Git here. And again, I'll type git clone https github.com learned lessons Linux learned. Right, we've cloned Linux learned repository. Now if we cd to this Linux learned repository and ls it, we'll get this create simple log shell script, and I'll need to change mod +x for create sample log files.sh, and now we'll run this log file. And by the way, let me reveal the contents of this file. Create sample log file. As you can see, it will create actually one file, server log. Actually, that's not that file I intended to use. We'll use the other file, which is create simple log.sh file. So again, let me change mod plus x to create simple log.sh, and if we cat the contents of this create simple log.sh, we'll get that we are creating 3 lines of access.log file, which we can use for our grep manipulation. So let me run this file, which is create simple underscore log.sh. Now if we ls, we'll get this access.log file here. And now we can run some simple grep manipulations with this file. So let's search for all GET requests here. I'll type grep get, and we'll be searching in access.log file. As you can see, grep manages really fast and efficiently, and it finds all the occurrences of GET requests from this file. Now let's search for a specific IP address. Let's say that we want to find all occurrences of 192.168.1.1 in access.log file. Okay, no problem. Now we can use a regular expression to find all successful requests status code 200. So for this we'll use grep dash uppercase E, and we'll be searching for http://1.1, and we'll also be searching for the occurrences of 200 in access log.txt. And by the way, as you can see, it expects some more commands, because what I've forgotten to do is I've forgotten to use backslash before this double quotes. We don't need grep to identify these double quotes as double quotes, but we needed to identify it as simple string character. Now let's run it, and we get all the occurrences of successful request status code 200. Now to wrap up what we've done in this lesson. First, we've cloned Git repository. To clone a Git repository, you use git clone command and you specify the repository name. In our case, we needed it for getting sample log files, not to type all this information manually. Then we used grep to find get in access.log file. We also searched for IP address with grep, and we used grep with regular expression to find all successful requests, which is status code 200. For this we've used dash uppercase E. Our next question is related to file content search commands. And the question is, which command can search file contents using regular expressions? Is it find, locate, grep, reggrep, or pgrep? Press pause here and think about the correct answer. And the correct answer is option C, it's grep. So again, to remind you, grep stands for Global Regular Expression Print. It's one of the crucial tools in the Linux Administrator's Toolkit. So it's a powerful utility that can search file contents using regular expression. This makes it invaluable for tasks like log analysis, code review, and system troubleshooting. While other commands like find and locate are useful for finding files based on names or attributes, grep excels at searching within files. It can search for complex patterns, making it much more versatile than simple string matching. For example, you might use grep to search for all occurrences of an IP address in log file, or to find all lines in a configuration file that don't start with a command character. Let's practice using grep a bit. I'll switch to my terminal again. Now let me clone my GitHub repository. I'll use, by the way, let's find out if we have Git on this system. Yes, we've got Git. So I'll use git clone https github.com learned lessons, and the repository name is Linux learned invalid active developer path. Okay, some troubles on this my local host. I don't want to troubleshoot them. Let me switch to the test VM. And again, I'll check if Git is installed here. Yes, we've got Git here. And again, I'll type git clone https github.com learned lessons Linux learned. Right, we've cloned Linux learned repository. Now, if we cd to this Linux learned repository and ls it, we'll get this create simple log shell script, and I'll need to change mod plus x for create sample log files.sh, and now we'll run this log file. And by the way, let me reveal the contents of this file. Create sample log file. As you can see, it'll create one file, server log. Actually, that's not that file I intended to use. We'll use the other file, which is create simple log.sh file. So again, let me change mod plus x to create simple log.sh, and if we cat the contents of this create simple log.sh, we'll get that we are creating 3 lines of access.log file, which we can use for our grep manipulation. So let me run this file, which is create simple underscore log.sh. Now if we ls, we'll get this access.log file here. And now we can run some simple grep manipulations with this file. So let's search for all GET requests here. I'll type grep get, and we'll be searching in access.log file. As you can see, grep manages really fast and efficiently, and it finds all the occurrences of GET requests from this file. Now let's search for a specific IP address. Let's say that we want to find all occurrences of 192.168.1.1 in access.log file. Okay, no problem. Now we can use a regular expression to find all successful requests status code 200. So for this we'll use grep dash uppercase E, and we'll be searching for http:/1.1, and we'll also be searching for the occurrences of 200 in access log.txt. And by the way, as you can see, it expects some more commands, because what I've forgotten to do is I've forgotten to use backslash before this double quotes. We don't need grep to identify these double quotes as double quotes, but we needed to identify it as simple string character. Now let's run it, and we get all the occurrences of successful request status code 200. Now to wrap up what we've done in this lesson. First, we've cloned Git repository. To clone a Git repository, you use git clone command, and you specify the repository name. In our case, we needed it for getting sample log files, not to type all this information manually. Then we used grep to find get in access.log file. We also searched for IP address with grep, and we used grep with regular expression to find all successful requests, which is status code 200. For this we've used -E. The next question we've got is related to find command. The question is, which option restricts the find command to search in a specific number of subdirectories in a nested structure? Is it option A, max depth, option B, dir max, option C, max levels, option D, -S, and option E, -N? And the correct answer is option A, max depth. So find command is quite powerful tool and essential for searching through directory structures efficiently. When dealing with nested directories, it's often necessary to limit the depth of the search to avoid excessive processing time or unwanted results. And the find command offers a specific option for these purposes, max depth option. This option allows you to restrict the search to a particular number of subdirectory levels. For instance, if you want to search only the current directory and its immediate subdirectory, you wouldn't use max depth. Without any parameters, you'd use max depth 1. It's important to note that while other options like dir max or max levels might seem intuitive, they are not valid options for the find command. Always refer to the commands manual, man find, for accurate information on available options. Now let's start practical exercise using the find command. We'll open the terminal and we'll explore how to use the max depth option. Let's first create a nested directory structure. Let me check my current working directory. It's my user directory. We'll also ls this directory and change to tmp directory, ls here. And now let's create the next nested structure inside test directory. So for this, I'll type mkdir and I'll use -p option parent. And our parent directory will be test directory. And subdirectory will be dir1 directory. And one more subdir, we'll name it subdir1. Let's also create another directory here. So the parent directory will be test, and inside test we'll create dir2 and subdir2. I'll hit enter. Now if we change to test directory and run tree command, oops, no tree on this shell, but that's okay. We can ls and see that these two directories are in place. Now let's create some test files in this test directory. So we'll type touch. First let me go one level up to use the whole path. So I'll use touch command and the path to our file inside test directory. So it'll be test file1.txt. We'll do the same for test dir1 file2.txt and test dir1 sub dir1, and we'll create file 3.txt. Everything with one go. So we've created a whole tree structure with one go, and we've created 3 files inside of this structure with one command. Now let's use the find command to search for files. So we'll type find and just test. So as you can see, we've got the whole tree, test as the root, then test file1, all files we've just created. Now let's limit the search depth. So I'll type find test and we'll limit it to max depth 1. Notice how this only shows the contents of the test directory, not going into a subdirectory. You can try using different values, for example, max depth 2, or practice with this option for find command. Our next question is related to containers versus virtual machines. So, which statements accurately compare Linux containers with traditional virtual machines? Please select three options. Option 1. Containers use kernel-controlled process isolation and resource management. Option B. Fully virtualized machines can run only operating system for a specific hardware architecture. Option C. Containers only use emulated virtual hardware devices. Option D. Hypervisors create guest environments for fully virtualized machines. And option E. Containers on the same host can use different operating systems. Press pause here and think about the correct answer. And the correct answers are as follows. Option A. Containers use kernel-controlled process isolation and resource management. The next correct option is option B. Fully virtualized machines can run any operating system for a specific hardware architecture. And option D. Hypervisors create guest environments for fully virtualized machines. So let's compare Linux containers with traditional virtual machines. This comparison is crucial for understanding modern virtualization and containerization technologies. Firstly, containers represent a lightweight form of virtualization. In this method, the kernel itself manages process isolation and resource allocation. This approach differs significantly from traditional virtual machines, offering improved efficiency and resource utilization. On the other hand, fully virtualized machines such as those created by KVM, kernel-based virtual machines, provide a more isolated environment. These VMs can run any operating system designed for the specific hardware architecture of the host machine. This flexibility is a key advantage of full virtualization. Now, containers can directly access the host hardware, which contributes to their performance advantages. As for fully virtualized machines, a hypervisor plays a crucial role. This software layer creates the guest environment, providing virtual and emulated hardware devices. This abstraction allows for greater isolation, but at the cost of some performance overhead. Lastly, it's important to understand that containers on the same host typically share the same kernel. They don't create separate kernel executions for different operating systems, which is a limitation compared to fully virtualized machines. Now, the question is on etc/fs tab mounting option. And the question is, what alternatives to explicit devices can be used in etc/fs tab for mounting? You should choose two correct options. Press pause here and think about the correct option. And the correct answers are as follows. Option E, UUID, and option A, label. So this topic concerns the etc/fs tab file, which is fundamental to the Linux file system. This file contains the necessary information to automate the process of mounting partitions. Traditionally, etc/fs tab entries used explicit devices names like dev.sda to identify partitions. So the identified partitions will be dev.sda1, like in this example. However, modern systems offer more flexible and reliable alternatives. Two key options to identify partitions in etc/fs tab are label and UUID. Label allows you to assign a human-readable name to a partition, making it easier to identify and manage. UUID is universally unique identifier, and on the other hand, it provides a long unique string that remains consistent even if the device name changes. It's worth noting that while options like ID, find, and name might seem plausible, they are not valid identifiers for etc/fs tab entries. Always verify the correct syntax and options in the system's documentation or man pages. So by using label and UUID, you can ensure that your system mounts the correct partitions even if device names change due to hardware modifications or system updates. This approach enhances both the reliability and maintainability of your Linux system. Now let's do some practice with fs-tab file. First, let's look at the current etc fs-tab. Let's try to run this command on Z shell and see what we'll get. I'll type cat etc fs-tab and we'll get an error that there is no such file or directory because it's macOS. So let me launch Linux distribution. I'll launch CentOS Stream 9, log into it with my password, and we'll type cat etc fs-tab. So that's how you can look at your current etc fs-tab. Let me make it smaller to be more readable. As you can see, we've got several mount points here. Now let's find the UUID of a partition. We'll use the root partition as an example. So I'll type sudo bulk id and we'll grab the root partition. I'll provide my password and we get / is a directory. Let's rerun this command with just bulk id command and we'll find UUID for SDA1 and UUID for SDA2. Now to practice using a label, you could create a new partition, for instance, with the following command. I won't be running this command, but just for the demonstration purposes, I'll type it here. You'd use sudo fdisk and, for example, dev sdb. You'll need to replace SDB with an appropriate device for your system. Also, be cautious with this step and ensure you have backups or you are running it on test VM. After creating the partition, you'd give it a label with sudo, let me place a command here, sudo e2label command, and for example followed by dev sdb1 and give it a label, for example, my new partition. Again, replace it with your partition. And then you can use either the UUID or the label in etc fs-tab. And the configuration line could look as follows. For example, label my new partition and my mount point, for example, mnt new part. It'll be, for example, ext4, then followed by defaults 02. It's just an example of the configuration line for fs-tab. Or you could do the same, but use UUID here, like UUID followed by your UUID here. Our next question relates to VI commands, and the question is which single character command will insert deleted content below the current line in VI? Is it I lowercase, P uppercase, U uppercase, or U lowercase? And the correct answer is P lowercase. Again, to remind you, one of the most useful features in VI is its ability to manipulate text efficiently. Consider this scenario. You've just deleted 3 lines of text and moved your cursor to a different line. Now you want to insert that deleted content below your current position. Which command would you use? In VI, the lowercase p command is your go-to solution. This simple yet powerful command pastes the previously deleted or yanked text. I personally use it all the time. It's a fundamental part of VI's delete and put functionality, allowing for quick and efficient text manipulation. So Let's start some hands-on practice with VI, and I'll type VI to launch VI and followed by the file name. Let's name it practice.txt. Now let's type 3 lines of text here. For this, I'll press I to enter insert mode and then start typing. This is line 1. This is line 2. And finally, this is line 3. Now to exit this insert mode, I'll press escape. Now let's delete these 3 lines. I'll position on the first line. For this, I'll press GG twice. And next, let's delete these 3 lines by pressing 3 and pressing DD. Now you see all 3 lines are disappeared. Now let's move the cursor to a different line by pressing J, for example. But in our case, we don't have any lines here. Actually, let's add one. Let's add, this is line 4. And now let's say that we want to paste the previous content or insert the deleted content below this current line. So for this, I'll just press P. But of course, I'll need to exit insert mode because if I press P now, that'll just type this P letter. So let me hit escape and press P. As you can see now, these 3 lines we've just deleted, line 1, 2, and 3 are below line 4, as expected. Now to save this file, we'll press write Q, and now if we ls practice.txt file, let's ls it with LA, we'll get that this file was modified at 12:03. Our next question relates to etcfs tab file structure. So how many fields are in a syntactically correct line of etcfs tab? Is it 3, 4, 5, 6, 7? And the correct answer here is option D, it's 6 fields. So as you remember, etcfs tab is one of the most important configuration files in Linux. This file plays a pivotal role in mounting file systems during boot. But have you ever wondered about its structure? A syntactically correct line in etcfs tab consists of 6 fields. These fields provide essential information about the file system, including the device name, mount point, file system type, mount options, dump frequency, and fsck order. Understanding this structure is key to properly configuring and managing your Linux file system. So let's open etcfs tab really fast, and for this I'll launch my Linux distribution virtual machine, and I'll let me type cat etcfs tab. Hit enter. As you can see, we get several lines, each representing a file system. So if we take this line with UUID, this UUID is device identifier. Let me select this UUID, it's quite long. Then we've got mount point, here it is, /boot is our mount point here. Then we've got file system type, in this case it's XFS. Then we've got mount options, in this case it's defaults, here it is. Then dump frequency 0 and fsck order 0. So as you can see, we've got 6 fields, and now you'll remember that this fs tab file contains 6 fields, and it's crucial to know to properly configure your file system in Linux. Our next question is focusing on executing shell scripts. So, which commands directly execute instructions from usr local bin runme.sh without starting a subshell? Select 2 options and press pause here to select the correct option. So, the options are A. Source usr local bin runme.sh, B. usr local bin run me sh, c bin bash usr local bin run me.sh, d dot /usr local bin run me sh, and finally run usr local bin run me.sh. And the correct answers for this question are as follows. Option A, source usr local bin run me.sh, and option D, dot / and the path to the script we want to run. So when working in a bash environment, you might need to execute instructions from a script without starting a subshell. This can be particularly useful for scripts that need to modify the current shell environment. There are two primary methods to achieve this goal. You'll use this source command followed by the script path, and you'll use this dot operator followed by the script path. Both of these methods read and execute commands from the specified file in the current shell environment, allowing any changes made by the script to persist in your current session. Now let's practice executing shell script without starting a subshell. First, let's create a simple script. So I'll type echo and then single quotes and add some script body here. First we'll add shebang and it'll be bin bash. Then we continue our script body. We'll issue export command. Let's say that we want to export test var, and that'll contain the following string: hello, world. Such a rarely used phrase. And then we close single quote. That'll finish our script body, and we'll redirect it to tmp and name the script, for example, test underscore script dot sh. Now if we cat the contents of this script in tmp folder, tmp directory, test script.sh, that'll contain these two lines, as you can see. Now let's add execution permissions to the script with change mod plus x, and it's for tmp test script.sh. Now if we ls-la tmp test script.sh, we'll get the output that it is an executable file. Great. Now let's try to execute this script in two ways that will affect our current shell environment. The first way was to use source command. Let me clear the screen first and type source tmp test script.sh. And we'll use, now we've added this variable, here it is, test var, so it's now in our environment. Now we can refer to this variable with echo command. If we type echo and start typing test underscore var, our working environment, our shell, already knows about this variable, and it contains hello world. So the script ran correctly. It added this test var to our current shell environment. And of course we can use another way to run this script, which was dot, then tmp test script.sh. And again, if we refer to this variable, we'll get the output hello world. In both cases, you should see hello world printed because this script has modified our current shell environment. The question is related to user login restriction. And let me switch to the question itself. Which method prevents a user from obtaining an interactive login section? Is it option A, setting the UID for the user to 0? Option B, running the command chch-sh-s bin false with the username? Option C, removing the user from the group staff? Option D, adding the user to etc no access? Or option E, creating a .no login file in the user's home directory? And please press pause here and think about the correct answer. And the correct answer is option B, running the command chsh-s/bin/false with the username. Now let's take a look at the methods of restricting user login access. One of the most effective ways to prevent a user from obtaining an interactive login session is by modifying their shell. Specifically, we can use the command chsh or change shell with -s parameter and set it to bin false shell followed by the username. This command changes the user's login shell to bin false. Here it is. So bin false is set to the user's shell, which is a binary that does nothing and immediately exits. As a result, when the user attempts to log in, they are immediately logged out. This important step is worth knowing for any system administrator. It's also important to know that while other methods like setting the UID to 0 or removing a user from certain groups may affect their permissions, but they don't directly prevent login access. Similarly, creating .no login file or adding a user to etc no access are not standard methods for preventing login access across all Linux distributions. Now let's practice restricting a user's login access. So I'll open a terminal and first let's create a new user. So for this I'll type sudo add user test user, for example. I'll provide my password and of course I'm running this shell on macOS here. Let me launch Ubuntu distribution and we'll continue practicing on Ubuntu Linux with that. Again, let me retype this command here, sudo add user test user. Again, I'll enter my sudo password and the test user has been successfully added. Now we can add a password for this user and retype it. Full name, like test, user, room number, okay, 21, work phone, 555-55-55. Oh, so many default settings for test user on this distribution. Okay, home number will be like this. Other, nothing special. Is the information correct? Yes. So we've successfully added this test user. Now if we cat etc password file, we'll find this test user is here. And by the way, you can find user's shell, which is bin bash. Now let's restrict, by the way, we can go ahead and try to change to this user by su test user. And now we've successfully logged in with this test user. And we can check our shell with commands. For example, we could type echo $ and check the shell variable. As you can see, it's bin bash or ps-p followed by $2. Again, as you can see, it's bash. And one more method to check it by using base name command. So I'll type base name and $shell. So let me exit this user. As you can see, we can successfully log into this user. This user can perform different actions. Now let's say that we want to restrict this user from logging into their bash shell. And we do this with change shell command, as you remember. And of course, we'll need sudo privileges for that. And we'll add -s parameter and we'll restrict it to bin false shell. And now we'll need to specify the user, which is test user. Hit enter. Now, if we try to change to this test user, providing his password. As you can see, nothing happens. We're still using parallels user, not test user, because this test user is now restricted. And if we rerun this cat etc password command, we'll find that test user now has got bin false shell. And of course, you could also need to revert the changes. You do this with sudo again and change shell again, and again the same options as, and you just add bin bash to test user. Now again, let's check password file. Test user is bin bash, and let's try to su to test user. And now we can again log into the test user's shell and issue any commands like pwd. And by the way, let me exit test user and rerun this su command, but we'll add dash here. Oops, wrong password. Let me rerun it. So if we now type pwd, we'll get test user's home directory. That's because we've used this dash. So we now use all the variables and environment of test user, including the home directory. So test user can run the commands and use bin bash shell without any limitations. So again, let's wrap up. To modify user shell, we use chsh command -s bin false, followed by the username. And we use this bin false shell, which performs user immediately log out upon login attempt. Our next question is focusing on TCP wrapper. So what is the purpose of TCP wrapper? Is it option A to manage and adjust bandwidth used by TCP services? Option B, bind a network service to a TCP port. Option C, encapsulate TCP messages in IP packets. Option D, add SSL support to plain text TCP services. Or option E, limit access to a network service. Press pause here and think about the correct answer. And the correct answer is option E, limit access to a network service. So moving on to network security, let's discuss a bit the TCP wrapper. Contrary to what some might assume, the primary purpose of a TCP wrapper is not to manage bandwidth or bind services to ports. Instead, its main function is to limit access to network services. TCP wrapper acts as a host-based networking ACL, or access control list system, allowing you to specify which remote hosts are allowed to or denied to access the internet services. It provides an additional layer of security by controlling access to various network services based on the source IP address of the incoming request. This tool is particularly useful for enhancing the security of services like SSH, FTP, and other that rely on the TCP protocol. By configuring TCP wrapper rules, system administrators can significantly reduce the attack surface of their systems. Now let's explore TCP wrapper configuration, and we'll open hosts file with sudo nano, and the file is etc hosts.allow. I'll provide my sudo password, and of course I'm working as test user, and this user doesn't have sudo privileges, so let me exit it and rerun the previous command sudo nano etc hosts.allow. Now we can add a rule to allow, for example, SSH access only from a specific IP. Let's go to the bottom of this file, and the rule could look as follows: sshd For example, 192.168.1. Let me first save this file and check the IP configuration for this host. So let's use this IP. It's the local host IP. It's 10.211.555. Let me reopen this file, and the IP was 10.211.555, right? Let's double check it. Yes, 10.211.555. So the rule is SSHD colon 10.211.555, and that will allow SSH access only from this specific IP address. Let's exit this file, clear the screen, and try to SSH to the local host. Now let's try to SSH to 10.211.555. Connection refused because SSH could be disabled on this particular virtual machine. We could check it with systemctl status sshd, or just ssh. Service not found. Let's try to start this service with the sudo command systemctl start ssh. Okay, unit ssh service not found. No problem, let's update this server then with sudo apt update command. That'll take some time, a minute or two. I'll press pause here and get back to you when it's done. Now let's install the SSH server package with sudo apt install, and the package is open ssh-server. Okay, yes, we'll need to install it, and that will install the server really fast. It's processing some triggers, and it's done. Now let's recheck the status of SSH service. Now, as you can see, it's active and running. Great. I'll press Q here to exit. And by the way, to enable SSH service to start on the boot, you'll need to run the following command: sudo systemctl enable SSH. That will add the links, and the service will be started when the system is rebooted. Now let's rerun the previous command, which was ssh 10.211.55.5, and we'll add this host to trusted. Now we'll provide our password, and we've successfully logged in with SSH. We can run APA command to check our IP address here. Here it is. So let's try to add the deny rule with TCP wrapper. And again, we do this with sudo nano, and the path is etc hosts.deny. And we can add the rule here like, oops, I'll retype my parallels password. So let me go down to the bottom. And as you can see, all is paranoid. We are denying all except the IP address we've just used to allow. So to deny all hosts being able to access SSH, you just type sshd colon all, right? Now we'll press Ctrl X, Y, and please remember that it's only the testing machine. Don't do this on production machines. The actions we are performing right now are just for testing purposes. Now we can restart the SSH service with sudo systemctl command, and the subcommand is restart, and we'll need to restart SSH. We can double check it with sudo system, oops, not sudo, but sudo systemctl status SSH. It's running, and we can try to use SSH connection once more. So I'll type SSH 10.211.55.5. Provide my password. I've successfully logged in because I'm logging in from this particular IP address. As you can see, last login, Friday, September 6th, and the IP address is 10.211.55.5. Now, if we minimize this window, which is our Ubuntu server service virtual machine, but actually it doesn't matter. You can set up this TCP wrapper on any Linux machine. So let's try to pin this 10.211.55.5, and we can successfully pin this virtual machine. So we can try to log in with SSH to this virtual machine. So I'll type SSH, then I'll provide my parallels user and the IP address, which was 10.211.55.5. See what happens? And as you can see, we get connection reset by peer. We cannot connect to this virtual machine. Now let's go ahead and switch to this virtual machine again, and we'll exit this SSH session, rerun the command with which we denied all other hosts, or actually let's add one more host, which is our local host, not local host, but the host we are running this Ubuntu server on. So I'll open host.allow file. Now I'll check my new host IP address with if config command. Let me find the needed IP address here. And here it is, 10.211.55.2. Okay, let's switch back to our Linux server and add one more IP address here, SSH d10.211.55.2. We'll save the file and restart SSH service with systemctl restart SSH. Now let's minimize this window and go back to our source host and try to reconnect to this destination host. Now, as you can see, the output is different. It offers to add this IP address to known hosts. I'll type yes and provide my parallels password, parallels user password, and we've successfully logged into this .55.5 IP address, where we've set up this TCP wrapper allow hosts rule, which is now allowing two hosts to connect to this server. Let me reveal this host once more with sudo nano etc hosts.allow. And as you can see, now we are allowing two hosts, and we've successfully tested this host can connect to this particular host. And as you remember, we deny all other hosts to use SSH to connect to this server. Okay, I guess now it's clear. To wrap up, we've successfully installed SSH server on Linux distribution, and we've successfully started SSH service and added it to be enabled after the reboot. Then we've configured etc hosts allow TCP wrapper rule to allow two hosts to connect to this server, and we've configured etc hosts deny to set up the rule that all other hosts except these two hosts cannot use SSH to connect to this server. The next question focuses on private IPv4 networks, and the question itself is which of the following IPv4 networks are reserved by IANA for private address assignment and private routing? You should choose three correct options for this particular question. So option A is 10.0.0.0/8. Option B, 127.0.0.0/8. Option C, 169.255.0.0/16. Option D, 272.16.0.0/12. And finally, option E, 192.168.0.0/16. Press pause here and think about the correct answer. And I'll reveal the correct answer in just a sec. And the correct answers are as follows. Option A, 10.0.0.0. Option D, 172.16.0.0. And option E, 192.168.0.0. So let's examine the concept of private IPv4 networks. This IANA is an abbreviation for Internet Assigned Numbers Authority, and it has reserved specific IPv4 address ranges for private use. These private networks are crucial for logical area networks or LANs and are not routable on the public internet. The three IPv4 networks reserved by IANA for private address assignment and private routing. And the networks are, which we've just specified in the correct answer for the question. Here they are, 10.0, 172.16, and 192.168. These private IP ranges allow organizations to use IP addresses within their local area networks without conflicting with public IP addresses. They are widely used in home networks, corporate environments, and anywhere a private non-internet routable network is needed. It's worth noting that while 127, let me get back to our question, this one, 127.0.0.0/8 is a special purpose IPv4 network, and it's used for loopback addresses. And this one, 169.255.0.0, is used for link local addresses. Neither of these two are considered a private network in the same sense as the three mentioned in this question. Now let's practice identifying private IP ranges. Let me log into my test VM server and open a terminal and use IP command to view your network interfaces. For this, we'll type IP ADDR, that's an abbreviation for address, show. And by the way, you could use just SH, but I'll type show. And we can look at IP addresses assigned to our interface and identify which ones are private. So let's scroll through this information, and as you can see, we've got the first one is the loopback address, and this second interface, which is 10.211.55.5, it's the private IP address. And the third one is the IP version 4 IP address. Now we can try pinging some addresses from different private ranges. For example, if we ping 10.0.0.1, we'll get a destination unreachable error. We'll do the same for 172.16.0.1. That's another private virtual address. And the third one was 192.168.0.1, for example. These are three more private ranges which could be used for different configurations, and depending on your network configuration, these are accessible or not accessible. In my case, all three networks don't respond because they are not set up in this particular testing environment. Now, we can use, for example, the whois command to check if an IP is private or public. So we'll type whois and let's say 10.0.0.1. And on this particular system whois command not found. Let's install it by sudo as they offer. So I'll type sudo apt install whois. That'll install this command really fast. Install the documentation for this command and we'll rerun it with like this. So now we get all the information on this IP address. Let's scroll up and read about this IP address. As you can see, it's private address. The information is from IANA special use, and you can read about these addresses. These addresses are in use by many millions of independently operated networks, which might be as small as a single computer connected to a home gateway, and so on. So you can use this whois command to identify any IP address. For example, if you type whois 8.8.8.8, that's Google's IP address, you'll find the information on this particular IP address. So if we scroll up, we'll find the network range for this IP address. It's network mask, register date, updated date, organization name, which is Google LLC, and so on. You can use this whois command for any IP address to identify is it public or private and whom this IP address belongs. The next question focuses on Braille display. What does the term Braille display refer to in Linux? Is it a standardized high-contrast graphical theme for desktop applications? Is it a Linux desktop environment similar to KDE and GNOME? Is it a legacy display technology superseded by LCD? Is it a physical representation of characters using small dots, or is it a standard file format for data exchange similar to XML? Press pause here and think about the correct answer. And the correct answer is option D, a physical display, a physical representation of characters using small dots. So some words about this Braille display. It's an important assistive technology. In essence, a Braille display is a device that provides a tactile interface for visually impaired users to interact with digital content. It accomplishes this by creating a physical representation of characters using small raised dots. Unlike some misconceptions, a Braille display is not a graphical theme or a Linux desktop environment or an outdated display and so on. So it's an important tool to translate digital text into a format that can be read by touch, enabling visually impaired individuals to access and interact with computer system effectively. Our next question focuses on Linux user management. And the question is, which file assigns a user to its primary group? Is it option A, etc group, option B, etc shadow, option C, etc password, option D, etc group, and option E, etc G shadow? And the correct answer is, of course, option C, etc password. In the Linux file system, this critical information of group assignment is stored in a specific file, etc password. It's important to note that while there are several other system files related to user management, such as etc shadow, which is for encrypted passwords, etc group, which is for group definitions, and etc gshadow encrypted groups password. This etc password file is unique in that it contains the user's primary group assignment along with other essential user information. And now let's switch to the console and perform some hands-on tasks in it. So first let's reveal this cat etc password file. Here it is. We've got users containing different fields like representing a user account, and the fields are separated by columns. And the first field of each line represents the user's primary group. Now try to identify your own user account in this file. Rerun the command and find your account and the primary group for your user's account. Our next question is on IPv6 addressing. So which of the following is a valid IPv6 address? Please select from these 5 options, option A, B, C, and D. Press pause here and think about the correct answer. And I'll reveal the correct answer in just a second. And the correct answer is option C, this one. So IP addressing, IP version 6 addressing, it's a crucial component of modern networking. IP version 6 was developed to address the limitations of IPv4 addressing scheme, primarily the exhaustion of available IPv4 addresses. An IPv6 address is significantly longer and more complex than IPv4 counterpart. A valid IPv6 address consists of 8 groups of 4 hexadecimal digits separated by colons. For example, this example from the question. Now, key points to remember about IPv6 addresses are as follows. They use hexadecimal digits from 0 to 9 and from A to F. So please remember this, from A to F. Colons separate groups of digits, and double colons can be used once in an address to represent multiple groups of zeros. Also, please remember that invalid representations include using letters beyond F, using percentage signs or periods as separator, or using double colons more than once in an address. So now take a look at the previous example, at the previous question, and find what's wrong in all other incorrect options, like using percentage here, or like dot separators here, or letters beyond F here, and so on. Now let's practice identifying valid IP version 6 addresses, and I'll use my Linux distribution, so consider the following IP version 4 address. I'll type IP-A and we'll get IP version 6 IP address example here. As you can see, it has got colon as separator. It hasn't got letters beyond F here, and it hasn't got more than one double colon symbol. Our next question relates to IP version 6 header, hop limit field. So what is accurate about the hop limit field in the IPv6 header? Please read these 5 options. Option A, the field remains unchanged during packet transport. Option B, the field is transmitted within a hop-by-hop extension header. Option C, each forward router increments the field's value. Option D, each forwarding router decrements the field's value. And option E, for multicast packets, the field's value is always 1. Press pause here and think about the correct answer, and I'll reveal it in just a sec. And the correct answer is option D, each forwarding router decrements the field's value. So let's take a closer look at this specific aspect of IPv6 header, the hop limit field. This field plays a crucial role in preventing packets from calculating indefinitely in the network. This hop limit field in IPv6 serves a similar purpose to time to live or TTL field in IP version 4. Its primary function is to limit the lifespan of a packet in the network. Contrary to what some might assume, the hop limit field is not static during packet transport. In fact, each router that forwards the packet decrements the field's value by 1. This mechanism ensures that packets don't get stuck in routing loops or persist indefinitely in the network. It's important to note that the hop limit is not transmitted within a hop-by-hop extension header. Instead, it's a part of the main IPv6 header, making it more efficient to process. For those wondering about multicast packets, it's worth mentioning that the hop limit field doesn't always have a value of 1 for these packets. This value can vary depending on the specific multicast implementation and requirement. Our next question relates to email forwarding with ~/.forward. So the question is, what is accurate regarding this ~.forward file? And the options are as follows. When properly configured, ~.forward can route incoming mail to one or more additional recipients. Option B. Users must execute new aliases after modifying this forward to notify the mail server of changes. Option C. Root can set up any email addresses in home directory.forward file while other users are restricted to their own. Option D. The forward file owned by the MTA requires the edit aliases command for user modifications. And finally, option E, by default, only forward files of users in the mailing group are processed. Press pause here and think about the correct answer. And the correct answer is option A. When properly configured, this tilde, it's our home directory, forward file can route incoming mail to one or more additional recipients. So let's start exploring the functionality of this ~.forward file in Linux email systems. It's an important file in email management and forwarding. Firstly, it's important to understand that when properly configured, the .forward file can route incoming mail to one or more additional recipients. This feature is particularly useful for users who want to redirect their emails to another account or share incoming messages with colleagues. There are some misconceptions regarding this .forward file. Unlike some other email configuration files, users do not need to run the new aliases command after modifying this .forward file. The change takes effect immediately, making it a user-friendly option for mail management. As for permissions between root and regular users, while root has the privilege to set up forwarding for any email address using .forward, other users are restricted to configure only their own email addresses. This limitation helps maintain system security and prevents unauthorized email redirection. It's also worth noting that this .forward file is typically owned by the user, not the mail transfer agent or MTA. This means users can edit the file directly without needing special commands like edit aliases. This direct access gives users more control over their email forwarding settings. The next question relates to IP version for subnetting. So, which of the following are valid host addresses for the subnet 203.0.113.64/28? You should select two options. Press pause here and I'll reveal the correct answer in just a second. And the correct answers are option B and option C. So let's shift our focus on to IPv4 subnetting, a fundamental concept in network administration. So let's examine this specific subnet and determine valid host addresses within it. Let's consider the subnet 203.0.113.64/28. Notation is crucial here, as it indicates that the first 28 bits of the IP addresses are used for the network portion, leaving 4 bits for host addresses. To identify valid host addresses, we need to understand the range of possible addresses in this subnet. The network address is the IP address we've just read, here it is, and with a /28 subnet mask, this one. We have 16 total addresses, including the network and broadcast addresses. The valid host addresses range from .65 to .78. The address .64, which we've got in our example, this one, is the network address, and .79, the next after .78, is the broadcast address, neither of which can be assigned to hosts. Therefore, .78 and .65 are both valid host addresses within this subnet. However, .80, let me get back to the question, .80 and .81 fall outside the range of the subnet and are thus invalid for this particular network. So let's take a closer look at IPv4 subnetting. As you know, it involves dividing a larger network into smaller, more manageable subnetworks. This process is crucial for optimizing network performance, enhancing security, and making efficient use of IP addresses. Now, let's take IPv4 address, and an IPv4 address is a 32-bit number represented in dotted decimal notation. It consists of 4 octets, each containing 8 bits, separated by dots. For example, this IP address 192.168.1.1. This address is divided into 2 portions, namely network portion, which identifies the network to which this device belongs, and host portion, which identifies the specific device within that network. Now, the subnet mask determines which part of IP address belongs to the network and which to the host. It can be represented in 2 ways. Dotted decimal notation, like this, 255.255.255.0, and CIDR notation or CIDR, classless inter-domain routing. It is notated with /, for example, /24. This CIDR notation indicates the number of bits used for the network portion. For example, like this, 192.168.1.0 / 24, meaning that the first 24 bits are used for network, leaving 8 bits for host addresses. Now, subnetting involves borrowing bits from the host portion to create additional network bits. This process allows for the creation of smaller subnetworks within a large network. Key points to remember here that each bit borrowed doubles the number of possible subnets. So it doubles the number of subnets when you take each bit. Each bit borrowed halves the number of possible hosts per subnet. And the goal is to balance the number of subnets with the required number of hosts per subnet. Now some words about key address calculations. For any given subnet, there are several important addresses to calculate. First off, network address. The first address in the subnet. It's the network address. All host bits set to 0. Then broadcast address. It's the last address in the subnet. All host bits set to 1. Then first usable address. That's the second address in the subnet, and it is calculated network address plus 1. And last usable address, it's the second to last address in the subnet, and it's calculated minus 1 from broadcast address. Then additionally, important for calculations is total addresses. It's calculated 2 to the power of and number of host bits. And usable addresses, it's total addresses minus 2. Now let's take a look again at our example from the question. So here we've got CIDR notation first, /28. This CIDR notation /28 means 28 bits are used for the network portion, leaving 4 bits for hosts. And here we've got network address 64, broadcast address 79, usable range from 65 to 78, and total addresses 16, 2 to the power of 4. So in this particular subnet we'll get 14 usable addresses. So if we take a look at binary representation of this IP address, it'll look as follows. Take a look. So 203 will be this number in binary representation, 113 will be this number in binary representation, that will be 0, and 113 will be this number in binary representation, and 64 will be this number in binary representation. Now, this /28 tells us that it's the network portion. So if we count 28 numbers from here and up till here, that'll be the network portion. The last 4 bits represent the host portion. So these last 4 bits represent host portion. Now let's take a look at subnet mask. As you remember, the subnet mask here will be 20 /28, and if we translate it to decimals, we'll get such a mask, 255.255.255.240. And it is all ones in binary notations, except 4 last zeros. So here, ones correspond to the network portion of address. So all these ones are network portion of this IP address. And zeros correspond to the host portion. Now, when we calculate the network address, we perform a bitwise AND operation between the IP address and the subnet mask. Our next question relates to process ID information. And the question is, what information is provided by the echo $$ command? Is it option A, the process ID of the current shell? Option B, the process ID of the following command? Option C, the process ID of the last command executed? Option D, the process ID of the last command placed in the background? And finally, option E, the process ID of the echo command. Press pause here and think about the correct answer. And the correct answer is option A, the process ID of the current shell. So as you remember, it's crucial to understand process management in Linux. One common task is retrieving the process ID or PID of various processes. Let's explore a specific command that provides this information. The command echo $. It's a powerful tool in Linux shell and it displays the process ID of the current shell. This is particularly useful when you need to identify which shell instance you are currently working in, or when you are writing shell scripts that need to reference their own process. To break it down, echo is a command that prints its arguments to standard output, and $$ its special shell variable that represents the process ID of the current shell. When you run echo $, you are essentially asking the shell to print its own process ID. This is different from other process-related commands that might show information about child processes or other running programs. So let's run really fast this command in our shell. I'll type echo $, and we'll get process ID of the current shell. If we run it on another Linux distribution, for example, CentOS Linux, I'll type echo $. This process ID will be different. So it is changing depending on the shell you're running it on. It's not consistent. Our next question relates to DNS configuration. And the question is, which keywords can be used in the file etcresolve.conf? Please choose two correct options. Press pause here and think about the correct answer. And the correct answer or answers are option C, search, and option D, name server. So let's discuss a bit this domain name system and how it's set up in Linux systems. This file, etcresolve.conf, plays a crucial role in DNS resolution. Here it is, it's /etc/resolve.conf. This configuration file can contain several keywords that define how DNS queries are handled. Two important keywords that can be used in etcresolve.conf are search. This keyword specifies the default domain name to be appended to unqualified host names. It's useful in environments where you frequently access machines in the same domain. And name server keyword. This keyword is followed by the IP address of a DNS server. You can have multiple name server entries which the server or the system will query in order. Let's examine this etcresolve.conf file in our console. For this, I'll open the file with a text editor. I'll type sudo nano /etc/resolve.conf. I'll provide my password. And here it is. So in this particular case, we don't have any keywords because I haven't modified this file yet. If you don't see these keywords, you can add them for practice, but be cautious about making changes to system files. For instance, you can go to the bottom of this file. And by the way, here it is. I was wrong. I've got one configuration line here named server and my default router. So you could add like this search google.com and you could add name server 8.8.8. That's Google's IP address. Then you'll need to save the file and exit the editor. I won't be saving these changes, so I'll hit N not to save the changes. And again, to view the contents of this file, you type cat etc resolve.conf and let's add a pipe here and tail-n1, and that will output the last line of this etcresolve.conf file. The next question relates to environment variables. Which command displays all environment and shell variables? Is it get args option B ls env, option C ls, option D inf, or option E ls shell. Press pause here and think about the correct answer. And the correct answer is option D inf or env. So environment variables in Linux are dynamic named values that affect the way running processes behave on a computer. They are part of the environment in which a process runs. To view all environment and shell variables, you can use env command. This command displays a list of the current environment variables and their values. It's a straightforward way to see what variables are set and what values they hold. The env command is particularly useful when you need to debug environment-related issues or verify that certain variables are set correctly or understand the current state of your shell environment. Let's have some practice viewing and manipulating environment variables. So first I'll run this env command, and that'll reveal all the environment variables currently set. You can look for common variables like path, here it is, or home, here it is, or user. Now let's set a new environment variable. We do this with export command, so I'll type export, and for instance we want to set a new variable named myvar and assign a value to this variable, for instance hello. Let's add hello Linux, and we'll change uppercase I to lowercase I and add exclamation point here. Now we'll run this command, and as you can see on macOS, in this shell it behaves differently than in Linux. We get the continuation of our command prompt with D quote. So I'll exit from here and switch to another distribution, not this one, that's an installation. Let's open CentOS Stream 9 Linux command prompt and run the command here. So I'll type again export my_var containing hello Linux string, hit enter, and now this environment contains my var variable. Now we can run this env command and grep search for my var, and that'll find our variable containing hello Linux string. To see just this variable, you can use echo. Then to refer to the variable, you start it with $sign and then provide the variable's name. For example, my var. And it contains hello Linux string. You could also echo any other environment variable like this, $home or $path or $user. And it'll output your user environment variable value. The next question relates to DNS query commands. And here is the question. Which command might have produced the following output? Please read this output and read the options for the answer on this question. Is it option A, dig-t mx3w.example.org, just dig, option B, option C, dig-t ns record, option D, dig-t a record, and option E, dig-t source of authority record. Press pause here and think about the correct answer, which I'll reveal in just a second. And the correct answer is dig-t ns3w.example.org. That is option C. So let's focus on DNS queries. The dig command is a powerful tool for interrogating DNS servers. It allows us to retrieve various types of DNS records, providing invaluable information about domain names and their associated resources. So in our example, let's consider this example. when we get this output is characteristic of a specific dig command. The key to identifying the correct command lies in question section, which shows 3wexample.org in NS. This indicates a query for name server. Here it is. This command that produced this output dig-t ns3w.example.org, and here the -t ns option specifies that we are looking for ns records on the domain example.org. It's crucial to understand the different records or record types that can be queried using dig. For example, MX is for mail exchanger, A is for IP version for address. The next one, for ACE, is for IP version 6 addresses. SOA, or start of authority, and TXT for text records. Also, we've got CNAME, its canonical name. Each record type serves a specific purpose in the DNS ecosystem, providing different types of information about a domain. Let's start by querying with dig on practice in this hands-on exercise. So I'll switch to my terminal and I'll type dig-t. Let's start with ns, and let's say we want 3wgoogle.com. And we'll get the requested information. We'll get this ns1.google.com, the information on name service. Now let's try querying for MX records. So I'll type dig-t mxgoogle.com. Now we'll get this MX record, as you can see. And finally, let's look at the A record. I'll type dig-t a 3wgoogle.com. And again, we are getting a record for this particular domain, its IP address, and additional information on this query. So that's how you use DNS records when used with dig command, and in particular dig-t command. So if we get back to our question, you'll see that the output was about NS record, and the answer we've selected is indeed correct. Our next question focuses on network services configuration. So which file can be used to enable and disable network services on a Linux system? Is it option A, etc profile, option B, etc xinetd.conf file, option C, etc ports, option D, etc services, and option E, etc host.conf file? Press pause here and think about the correct answer. And the correct answer is option D, etc ports. Sorry, I said option D, which was etc services. So this etc services is used to enable and disable network services on a Linux system. So this file is one of the key files that play a role in this process of managing network in your system administration. This file is instrumental in enabling and disabling network services on a host. The etc services file serves as a mapping between human-readable service names and their corresponding port numbers and protocols. It's a critical component in networking configuration, allowing the system to associate specific services with their standard ports. For instance, when you see an entry like http 80/TCP, like in this example, in this file, it means that the HTTP service typically runs on port 80 using the TCP protocol. This information is used by various networking tools and applications to ensure proper communication. It's important to note that while etc services doesn't directly enable or disable services, it provides the necessary information for other system components to manage network services efficiently. Modifying this file should be done with caution, as it can impact the functionality of network-related applications. Now let's start examining this etc services file. I'll type sudo cat etc services, provide my password, and as you can see, I've got lots of services here. The file contains a list of service names mapped to their port numbers and protocols. Let's use grep to find HTTP service. So I'll type grep HTTP and provide the file name etc services. And that'll grab all services related to HTTP. We can also use less pager to scroll through the whole list. And as you can see, it starts with HTTP 80 TCP or UDP. So this tells us that the HTTP service typically uses this port 80 for TCP protocol. And we can search for any information we need. For instance, HTTPS. Let's add S here. And we'll find that 443 is used for HTTPS. Or we could use SSH service. Again, port 22 or FTP. Let's change SSH to FTP. Port 21 and so on. You can get information from here which service typically uses which port. So please remember this configuration file, it's quite important, etc services. The next question focuses on systemd timer commands. And let me switch to the question itself. And the question is, which command displays all active systemd timer? Is it option E, systemctl timer show, option B, timectl list, option C, systemctl-t, option D, systemctl list timers, or option E, time queue? Press pause here and think about the correct answer, and I'll reveal it in just a second. And the correct answer is option D, systemctl list timer. So let's discuss systemctl timers a bit. There are powerful tools for scheduling tasks in modern Linux systems, offering more flexibility than traditional cron jobs. And to view all active systemd timers, the command is systemctl list timers. This command provides a comprehensive list of all currently active timers, their last and next trigger times, and the units they activate. The other commands related to systemd management include systemctl status, start, and enable. Now let's switch to the Linux test distributive and run some commands using systemctl. So let's execute the following command: systemctl list -timers. And we'll get 4 timers for this particular system listed, and the detailed information about their last activation and when they are next scheduled to run. Now let's check the status of a specific timer. Let me press Q here first and make the font a bit smaller and rerun the command to get some specific timer. Let's make it even more smaller. Okay, we can take one of this timer, for instance, mlocate update db timer, and check the status of this timer. So for this, we'll type systemctl status, and we'll specify this timer. Let me type its name, mlocate -update db.timer, and we'll get the information on this particular timer. As you can see, it's active and in waiting state, and we can get also some extra detailed information on this timer. To see all available timers, not just the inactive state or not just the active ones, we'll use systemctl list timers all. Again, let me run this command. I'll type systemctl list timers -- all. And on this particular system, we've got just 4 timers, and these 4 timers are all in active state. If we switch to some other Linux distribution, for instance, let me launch Ubuntu Linux distribution and run the same command here. I'll type systemctl list timers. Here we'll get a bit more timers. Not 4 like on CentOS Linux, but more than 10 as I can see. And again, we can make the font smaller. I'll decrease the font, press Q and rerun this command, and we can get the timer's name. For instance, this one, apt daily upgrade timer. So we can try running systemctl status apt daily, oops, not daily, but daily. I'll hit tab twice and we'll add dash upgrade dot timer and we'll get its state. Now again we can run systemctl list timers -- all. So that'll be all timers including inactive which are available on this system. So to wrap up, you use systemctl list timers command to view all active system D timers. And you can get the status of the timers status subcommand as well. Our next question relates to IP routing. And the question is, given the following routing table, how would an outgoing packet to 192.168.2.150 be handled? Take a look at the output itself, and the options for this question are as follows. It's passed to default router, which is .1 on WLAN 0. Option B, directly transmitted on ETH0. Option C, passed to default router .0 on ETH0. Option D, passed to router .1 on ETH0. Or option E, directly transmitted to WLAN 0. Press pause here and think about the correct answer. And the correct answer is option D, passed to router 192.168.1.1 on ETH0. So let's consider this routing table first on my screen and take a look at the process of routing a packet. So when routing a packet to 192.168.2.150, the system follows a specific process. First, it looks for the most specific match in the routing table. Then the entry 192.168.2.0 with network mask 255.255.255.0 matches, and then the gateway. This entry specifies a gateway of 192.168.1.1 and an interface of ETH0. So if we get back to this routing table, we'll find this gateway here. Therefore, the packet would be passed to router 192.168.1.1 on ETH0 interface, and this will demonstrate how routing decisions are made based on the destination IP and the routing table entries. Now let's switch to the terminal and have some practice. So first I'll type route-n command. As you can see, it's not available on this particular system. Let's try IP route show, not available as well. Let's switch to our Linux system because I'm running this on Mac. Let's try typing it here, route-n, and we'll get IP routing table here. It's quite short. We can try using IP route show. That'll show the routing table as well, but in different output, as you can see. And here we can observe different columns, meaning the destination column, gateway column, the gateway address for this route, then gen mask, it's the net mask for the destination network, flags, various routing flags, U, route is up, and G, use gateway, and so on. Then metric column, it's distance to the target, typically used by routing protocols. Ref, number of references to this route. Use, count of lookups for the route. And if interface, interface to use for this route. So if we analyze the routing table, the first line 4 zeros is the default route. All traffic that doesn't match a more specific route will be sent to .1 via interface ENP OS5. Now let's try to understand how a packet would be routed. Suppose we want to send a packet to 10.211.55.0 with the network mask 255.255.255.0. This entry tells us to use the directly connected network via ENP OS5 network interface. Now let's take a look at several examples. How would packets be routed to this destination? We've got my routing table here, and let's see at the first example. Take a look at the first example, 10.211.55.50. How the routing decision will be made. And the answer is directly via ENP OS5 because it matches the 10.211.55.0 network. This IP address doesn't match any specific network in our routing table. Sorry, it matches the address within this .55.0 network, which is directly connected to this ENP OS5 interface. And the packet will be sent directly on this interface without going through a gateway. Now, the second IP address is 192.168.1.1. How the routing decision will be made? And the answer is it will be made via the default gateway 10.211.55.1 on ENP05. This IP address doesn't match any specific network on our routing table, therefore it will use the default route, which is 4 zeros, which sends all unmatched traffic to the gateway 10.211.55.1 via the ENP OS5 interface. And finally, another IP address as destination is 48 IP address, how the routing decision will be made. And the answer is via default gateway. Again, similar to the previous case, this public IP address doesn't match any specific network in our routing table. It will also use the default route, the first line in our routing table, sending the packet to the default gateway, which is .1 via ENP OS5 interface. So key takeaways from this lesson. Direct routing. It's when packets destined for IPs within directly connected networks, like in my case 55.0 network. And the packets are sent directly on the interface without a gateway. Then default gateway, it's any destination that doesn't match a more specific route will be used for the default gateway. This is how your local network connects to the broader internet. The next question we've got is related to DNS debugging tools. So which tool used for DNS debugging reports both the name server response and query detail. Is it option A, DNS queue, option B, host name, option C, dig, option D, DNS lookup, or option E, zone info? Press pause here and think about the correct answer. And the correct answer is option C, dig command. So let's focus on DNS debugging a bit. DNS or domain name system is crucial for translating human-readable domain names into IP addresses. And when troubleshooting network issues, having the right tools at your disposal is essential. One particularly powerful tool for DNS debugging is dig command. Unlike simpler tools, dig not only provides the response from the name server, but also offers detailed information about the query itself. This comprehensive output makes dig an invaluable asset, while other tools like DNS queue, hostname, DNS lookup, and zone info have their uses. Dig stands out for its ability to provide a comprehensive picture of the DNS query and response process. This level of detail can be crucial when diagnosing complex DNS issues or understanding the intricacies of your network's DNS configuration. Let's switch to our terminal and try to run some commands, some examples using dig command. So first let me type dig linux.org. Look at the output and notice how dig provides not just the IP address, but also query time, server used, and other details. If we scroll up, we'll find this query time line, server line, when requested, and so on. Now let's run the previous command, but we'll add, for example, MX record, and we'll get an answer retrieving the mail exchanger records for linux.org. And we can also observe additional details in the query section. For a concise output, we could try the following command, dig linux.org plus short. And we'll get only IP addresses, and we can compare this output with the previous outputs and see how dig can provide both detailed and summarized information. The next question relates to password storage in Linux. And the question is, which character in the password field of the etc password file, here it is, indicates that the encrypted password is stored in etc shadow? Is it option A asterisk, option B dash, option C S, option D hash, or option E X? Press pause here and think about the correct answer. And the correct answer is option E, it's X. So let's discuss how Linux system stores password. In modern Linux distributions, the etc password file no longer contains encrypted passwords directly. Instead, a special character in the password field indicates that the actual encrypted password is stored in another file, which is etc shadow file. The character used for this purpose is X. When you see an X in the password field of the etc password, it's a clear indicator that the system is using shadow password. This separation of password information enhances system security by restricting access to encrypted passwords to privileged users only. It's important to know that other characters like asterisk, hash, dash, s may have different meanings depending on the specific Linux distribution or configuration. However, X is the standard indicator for shadow passwords in most modern systems. Now let's examine how passwords are stored in Linux. If I switch to the terminal and type cat etc password, on this particular system, its macOS system will find that it's asterisk here. Now let's switch to the Linux distribution and compare with it. So let me type cat etc passwd. And here we'll get X at the second field of each line between the first and second columns, and you should see X in most Linux distributions. To the opposite from Mac OS, as we've seen in previous example. Now let's try to view etc shadow file. I'll clear the screen and type cat etc shadow. Of course, we'll get permission denied because for this operation we'll need sudo privileges. So I'll add sudo cat etc shadow, add my sudo password, and please remember that unless you are root, you should get a permission denied error. So this demonstrates the security benefits of shadow password, and we'll get the password in such an output. It's a long string and it's encrypted as well, so you cannot view the password directly, though you are root or sudo privileged user. You won't see the password itself here. You'll just see the encrypted string. But nevertheless, you'll get such a view to the opposite of the etc password, which contains only X. Moving on to the next question, and it's on SSH client configuration. Which configuration file contains the default options for SSH clients? Is it option A, etc ssh underscore config file, option B, etc ssh file, option C, etc ssh underscore config file, or two last options, option D, client file, or SSH client file. Press pause here and think about the correct answer. And the correct answer is option C, etc /ssh underscore config file. So let's explore SSH client configuration. I'll switch back to my terminal. And let's view the contents of the SSH client configuration file. So I'll type cat, we'll need cat, etc ssh underscore config directory or config file. And we can scroll through this file and observe various options. And as you can see, many of these options are commented out. And if you scroll down to the file, you'll notice this host line, configuration line. This shows you any host-specific configuration. And by the way, we can search for such a line with grep. I'll type grep in double quotes host space close double quotes and specify the file, which is etc ssh underscore config file. And we'll find the same records in this file. Of course, we can create a user-specific SSH config as well. So you do it with nano, for example, editor. You'll type nano tilde / dot SSH. That's the directory where the user's SSH-related files are located, and config. And you can add the configuration lines here, like, for example, host, followed by the host's name, for example, my server, and then you'll provide host name, for instance, example.com, and you'll provide user, for instance, my user name. So that's how you create a user-specific SSH config file. I won't be saving this because I've created it for just demonstration purposes. But in case you're using real-life example, you'll then save and exit from this file, and you can then connect simply by typing SSH followed by my server. So let me press Ctrl X and type N not to save this file. The next question we've got here is related to network manager behavior. And the question is, what is accurate regarding network manager in a Linux system utilizing its distribution's network interface configuration mechanism? And we've got 5 options here. Option A, network manager reconfigures all network interfaces to use DHCP unless specifically managed by network manager. Option B, network manager requires explicit enablement of for each interface it should manage. Option C, by default network manager does not alter already configured interfaces. Option D, network manager deactivates all interfaces not configured by itself. And finally, option E, network manager can be set to utilize the distribution's network interface configuration. Press pause here and think about the correct answer. And the correct answer, and by the way, if you've selected one correct answer or one answer, you'll need to select one more because this question contains 2 correct answers. So if you've selected only one, please press pause here and select one more. And the correct answers for this question is option C. By default, Network Manager does not alter already configured interfaces. And option E. Network Manager can be set up to utilize the distribution's network interface configuration. Now let's begin exploring the behavior of Network Manager on Linux systems that utilize their distribution's mechanisms for configuring network interfaces. Network Manager is a powerful tool designed to simplify network configuration and management. Firstly, it's important to know that Network Manager by default respects existing network configurations. This means that if an interface is already configured, Network Manager will not automatically change its settings. This behavior ensures that pre-existing network setups are not disrupted when Network Manager is introduced to the system. Moreover, Network Manager offers flexibility in its integration with different Linux distributions. It can be configured to work alongside the distribution's native network interface configuration method. This feature allows for seamless integration with various Linux environments, making Network Manager a versatile tool for network management across different distributions. It's worth mentioning that Network Manager does not automatically reconfigure all network interfaces to use DHCP, nor does it disable interfaces that it didn't configure itself. These behaviors would be too intrusive and could potentially disrupt existing network setups. So let's open our terminal and examine Network Manager's behavior on our system. I'll maximize one of my test VMs, log into it, and we can start. So first, in Open Terminal, I'll run the following command to view the current network interface configuration. I'll type nm-cli, Network Manager command line interface, and then I'll add connection show subcommands, and that'll let us observe the list of network connections and their states. Now let's check if Network Manager is using the distribution's network configuration. So let's type grep-i and let's search for managed and then specify the configuration file, which is etc network manager.conf file. We haven't found anything. So if you see managed equals true, Network Manager is using the system's configuration. Now let's try adding a new connection without modifying existing one. For this, we'll use sudo privileges. Actually, let me clear the screen and type it on the blank page. So I'll type sudo, then again network manager CLI, connection, add, type, for example, Ethernet, and then we'll specify connection name. Let's name it, for instance, I don't know, my new connection. And now we'll need to specify interface name. For instance, if name Ethernet 0, for example. I've got another name, so this command will fail. I'll add my password, and as you can see, it hasn't failed because the connection is created, but it's not using the correct interface. If we rerun this command, we'll get that we've got this device, ENP0S5. And as you can see, we've got this new line, my new connection. It's UUID, type Ethernet, and device, which is 2 dashes, non-existent device. Notice how this doesn't affect your existing connection. So you are free to add your new connection, and it won't affect your existing connection. Moving on to our next question, and it is related to file system comparison operators. So which comparison operators for the test command operate on file system elements? Is it option A -Z, option B -EQ, option C -A, option D -F, and option E -LT? And by the way, you'll need to select two options here. There are two correct answers. Press pause here and think about the correct answers, and I'll reveal them in just a second. So the correct answers here are option option C-A and option D-F. So let's discuss a bit file system comparison operators used with the test command on Linux. These operators are essential for shell scripting and system administration tasks that involve file system operations. Among the options presented, two operators stand out as specifically designed for file system comparison. This option, or the -A operator, this checks if a file exists. It's a versatile operator that can be used to verify the presence of any file system object. And the next one, -F operator, this tests if a file exists and is a regular file, not a directory or device file. It's important to know that operators like -Z, -EQ, and -LT are not specifically designed for file system comparisons. Instead, they are used for string and numeric comparisons in shell scripts. Now let's practice using these comparison operators with the test command, and again I'll switch to my console, and first we'll create a test file. So I'll type, let me list the contents here, and let's create a file with touch command, and we'll name it testfile.txt. Let's clear the screen and ls our test file. Here it is. Now let's use the -A operator to check if the file exists. For this we'll use if keyword, and we'll type if test -A. We'll be using -A operator here, and then we'll specify the file's name, testfile.txt. So this part of our one-liner is finished, and we'll press semicolon here to finish this part of the line. What we do then, we'll run echo command, and that will inform us that file exists, right? This part is finished again. And if it does not exist, we'll use else keyword here, and then we'll run echo command, but this time that will inform us that file, let's correct it, file with I lowercase does not exist, right? And finally we'll close this block, if block, and for this we've got if command, but opposite to if command, it's fi command. Okay, let's hit enter here, and as you can see, it checked if the file exists and reported that file exists and ran as expected. So here it is, the informational message, file exists. Now we can try these operators with a directory. For instance, if we create a directory with mkdir, but first let's remove this mkdir and let's run one more one-liner with -f operator to check if it's a regular file. So if we get back to this one-liner and get back to this -a operator and remove it and change it to -f operator, and we can change the message as well. For example, if it's a regular file, we'll inform the user that it's regular file. Otherwise, we'll report the user that it's not a regular file. Okay, let's run it. And as you can see, we get the response regular file because it's indeed a regular file. So that's how you test or use these two operators. As you can see, they are quite handy when using in bash shells or shell scripts, bash scripts or shell scripts. That could be not only bash but other shells as well. And now we can test these operators with a directory. So let's create a directory again. So I'll type mkdir testdir. I don't know if there is such a directory already here. In any case, here it is, testdir. And we can find the previous command. Here it is, test A. Now we are testing not testfile.txt, but we are testing testdir here. And again, we'll change file exists to directory exists. And in the second output, again, we'll change file to directory and hit enter. Okay, directory exists. So you can use this operator with directories as well, because directory is also a file, but a special file in Linux. Now let's use -f operator. That could be interesting, and we'll find this one-liner here, go to test file and change it to testdir and run this command. As you can see, we get a response that not a regular file, because of course we know that it's not a regular file. And by the way, I forgot to remove this .txt extension here. Let me remove it and rerun it. In any case, we get not a regular file because we know that it's a directory, not a regular file. So please notice the difference in results between -a and -f for directory. Now let's recap really fast. We check if a file exists with -a operator, and we check if the file exists and a regular file with -f operator. Our next question is on journalctl time frame parameters. So which parameters are used with journalctl to restrict the output's time frame? Is it option option A, dash since, B from, C until, D up to, and E date? And again, you'll need to select two options. There are two correct answers here, and I'll reveal the correct answers in just a second. So the correct answers are option A, since, and option C, until. Now let's explore the parameters used with journalctl to limit the time frame of its output. Journalctl is a powerful tool for querying and displaying logs from the systemd journal. Two key parameters stand out for specifying time ranges in journalctl queries: the since parameter This allows you to specify a start time for your log query. It's incredibly useful when you want to view logs from a particular point in time onwards. And until parameter, this sets an end time for your log query. It's particularly helpful when you need to investigate issues that occurred before a specific time. These parameters can be used together to define a precise time window for your log queries, making it easier to focus on relevant log entries during system troubleshooting or monitoring tasks. Please remember, while from and up to might seem intuitive, they are not valid journalctl parameters. Always refer to the journalctl man page or documentation for the correct syntax and available options. Now let's practice using journalctl with timeframe parameters. I'll switch to my test VM and let's view logs from the last hour, for example. For this, I'll type journalctl dash dash since 1 hour ago. Hit enter and we'll get all the log lines what happened on our system during this last hour. And to exit, we'll press Q, and to clear the screen, we'll press Ctrl L. Then let's view logs from yesterday until now. Again, I'll type journalctl since, and we'll change 1 hour to yesterday, and then we'll add one more parameter, which was until, as you remember, and we'll specify until now, just like this. And we'll get all the lines, log lines from yesterday till now. Now let's view logs from a specific time range. For instance, if I press Q and find this previous command, let's change yesterday to, let's say, 2024 dash, let's say from 1st of September 09-01. And let's say we are looking from 12 a.m. So I'll add 00 colon 00 colon 00. And let's say that we are looking for logs until 2024-09- today's date. It's 8th of September. And again, we'll add time like this and try to run this command. So we'll get all these logs. As you can see, we started from September 2, and if we scroll down by pressing space button, we'll go through all these log files. As you can see, there are pretty many log files. So now it's September 3, September 4, September 5, and so on. So that's how we view logs from a specific time range, as it was specified in the question. Now let's try combining this with other journalctl options. For instance, we could run the following command: journalctl dash dash since, let's use 1 hour again, 1 hour ago, and we could add such a parameter -u ssh dash service. No entries for SSH service. A question regarding Network Manager states. So, which states can Network Manager display regarding system network connectivity? Please select two correct options, press pause here, and think about the correct answer. And the correct answer is option B and option C. So these are two correct options. So let's begin by exploring the various states that Network Manager can display regarding a system's network connectivity. Network Manager is a crucial tool in Linux systems for managing network connections efficiently. Network Manager can show several states, but we'll focus on two key ones. Portal. This state indicates that the system is connected to a network, but it requires additional actions before full internet access is granted. Typically, this occurs when connected to a captive portal such as those found in some public Wi-Fi hotspots. And full, as the name suggests, this state signifies that the system has full network connectivity. All network services are available and the system can access both logical and internet resources without restrictions. Let's start examining network manager states in real time. For instance, on this my test VM, let's check the current state of our network connection. I'll type network manager CLI and then I'll add general status. That will reveal the output indicating the state of your connection. Now let's simulate a portal state. We'll need root privileges for. I'll type sudo network manager CLI, and for instance we'll need to use device Ethernet 0. So for this we'll specify device disconnect Ethernet 0. We'll need to provide our password. In this case I'll get device Ethernet 0 not found because it's a non-existent device. And then we'll connect this device. We'll change disconnect to connect subcommand. Again, hit enter and get an error device Ethernet not found. So you'll need to replace Ethernet 0 with your actual network interface name. And again, you'll need to, or you might catch the portal state before it transitions to full with this sudo general status. So as you can see here, we get full connectivity. Moving on, and the next question is on print queue commands. Which commands display a list of jobs in the print queue? Again, select two options. There are two correct answers here. Press pause here and think about the correct answer, and I'll reveal it in just a second. So is it option A, caps dash dash list, option B, LPRM dash L, option C, LP start, and option D, LPR-Q, or option E, LPQ? And the correct answer is option C, LPstat, and option E, LPQ. So these are commands used to display a list of jobs in the print queue. Effective print queue management is essential in both personal and professional settings. Two commands stand out here. LPstat. This versatile command provides status information for the printing system. When used without options, it displays the status of all print jobs. And LPQ. This command specifically shows the current state of the printer queue, including jobs that are waiting to be printed. Both of these commands are invaluable tools for system administrators to know and to remember when managing print jobs in a Linux environment. Now let's practice managing print queues. First, let's check the current print queue using LPstat. So let me type LPstat, and this will show you any current print jobs. As you can see, no print jobs right now on this test system. And that's obvious because I don't have even printer connected on my network. Now let's use LPQ to view the queue. I'll type LPQ. No default destination available. Now, you could try to add a print job and see the commands in action if you've got printer connected. So you could print a test page, for instance, etc password file with LP command and then specify etc passwd. But in my case, we'll get an error, no default destination. And if you have a printer connected, you'd quickly check the queue again with both commands when you are printing this file. And you should see your new print job in the queue. Our next question relates to user account modification. What information related to a user account is modified using the ch command? Is it option A, default ownership for new files? Option B, group membership? Option C, set of commands available to the user? Option D, password expiry information? And option E, default permissions for new files. Press pause here and think about the correct answer. And the correct answer is option D, password expiry information. So let's delve into user account management a bit, specifically focusing on the change command. This command is a powerful tool for modifying user password expiry information. This CHH command is used to change the password agent information for a user. This includes setting the minimum and maximum number of days between password changes, setting the date of the last password change, setting the expiration date of an account, and setting the number of days of warning before a password change is required. This command is crucial for maintaining security in multi-user environments, ensuring that passwords are changed regularly and that user accounts are properly managed over time. Now let's practice using this change command. First, let me check the users on this system. I don't remember actually. I'll type cat etc passwd, and here we've got only parallels user. Let me go to this my local computer and also run cat etc. I'm looking for test user. I remember that I've created test user somewhere, and I guess it was on Ubuntu Linux. So let's launch Ubuntu Linux and check for test user there. So again, I'll type cat etc passwd. Yes, we've got test user here and we've got new user here. So let's practice with these two users. Actually, I'll be using one of them, one of these accounts. So first, let's view the current password agent information for test user. So I'll type sudo ch-h-l, oops, not k, but l, test user. Let me make the font smaller. So as you can see, last password change was on September 6, year 2024. Now let's modify the maximum days between password changes. For this we'll use again ch command and we'll need to provide sudo privileges for this operation and we'll use dash uppercase M option. Let's set it to 90 days and we'll set it on test user account. Now let's add a warning period. So again, we'll use sudo change dash uppercase W warning 7 days for test user. This will warn the user 7 days before their password expires. And finally, let's check our changes again with sudo change-l test user. Now we've got 90 days, maximum number of days between password change, and warning before 7 days. So as you can see, we've got updated maximum days and warning period. Of course, we can set all other settings here like account expires or account disabled after a certain period of time and so on. But that's outside of the question we've got for this particular case. Our next question is on virtual machine video output protocol. So which protocol is designed to access the video card output of a virtual machine? Is it option E, KDE, option B, X11, option C, XFCE, option D, SPICE, or option E, XD-MCP? Press pause here and think about the correct answer. And the correct answer is option D, SPICE protocol. So let's begin by exploring the protocols used for access and video card output in virtual machines. In the world of virtualization, efficiently transmitted graphical data is crucial for seamless user experience. Among the various protocols available, SPICE, or Simple Protocol for Independent Computing Environments, stands out as a solution designed specifically for this purpose. SPICE is not another remote desktop protocol, it's tailored for the unique needs of virtual machines. Unlike general purpose protocols, SPICE is optimized to handle the video output from a virtual machine's graphics card, ensuring low latency and high quality display performance. It's important to note that while other options like KDE, X11, XFCE, and XDMCP are related to graphical environments or remote display protocols, they serve different purposes. KDE and XFCE are desktop environments. X11 is a windowing system, and XDMCP is a network protocol for remote logins to X terminals. None of these are specifically designed for virtual machine video output like SPICE is. The next question is on X11 configuration file structure. So here is the question. How is the content of a section named section name represented in X11 configuration file xorg.conf or xorg.conf? Is it option A? It is placed in curly brackets and in section name. Option B, it is placed between the text section name. Option C, it is placed between the line containing section name and a line containing end section. Option D, it is placed after the row section name. And option E, it is placed after an initial indented section name and must be indented by exactly one tab character. Press pause here and think about the correct answer, which I'll reveal in just a second. And the correct answer is option C. It is placed between a line containing section name, and a line containing end section. So let's delve a bit into the structure of X11 windowing system primary configuration file, which is xorg.conf. Understanding this structure is crucial for anyone working with X11 based system. The xorg.conf file uses a specific format to organize its settings into sections. Each section in this file follows a consistent pattern. It begins with a line containing section name, and ends with a line containing end section. All the configuration options for this particular section are placed between these two lines. This structure is different from other common configuration formats. It's not using XML style tags or INI style square brackets or JSON style curly braces. The X11 developers chose this format to its readability and simplicity. Our next question relates to IPv6 characteristic. So, which statement is accurate regarding version 6? Is it option A? IP version 6 no longer supports broadcast addresses. Option B. With IP version 6, the TCP port numbers of most services have changed. Option C. IP version 4 addresses can be used without any change with IP version 6. Option D, IP version 6 no longer supports multicast addresses. Or option E, for IP version 6, UDP and TCP have been replaced by the Rapid Transmission Protocol RTP. Press pause here and think about the correct answer. And the correct answer is option A. IP version 6 no longer supports broadcast addresses. So let's discuss some key characteristics of IP version 6, the successor of IP version 4. As we transition to this new protocol, it's crucial to understand its features and how they differ from IP version 4. One significant change in IP version 6 is the elimination of broadcast addresses. In IP version 4, broadcast addresses were used to send packets to all devices on a network segment. However, this approach could lead to unnecessary network traffic and potential security vulnerabilities. Instead of broadcasts, IP version 6 relies more heavily on multicast addresses. This allows you for more efficient and targeted communication within networks. It's a common misconception that IP version 6 doesn't support multicast. In fact, it has enhanced multicast capabilities compared to IP version 4. It's also important to know that the fundamental transport layer protocols such as TCP and UDP remain unchanged in IP version 6. The port numbers for most services are the same as in IP version 4, ensuring compatibility and ease of transition. Lastly, while IP version 6 addresses are different from IP version 4 addresses, there are mechanisms in place to help with transition. However, IP version 4 addresses cannot be used directly in IP version 6 without some form of translation or encapsulation. Now let's look at some IP version 6 configurations, and I'll switch to my console. And if I run ifconfig here, oops, not iconfig, but ifconfig, we'll get IP version 6 INET 6 address. So this ifconfig will output you both IP versions 4 addresses if we scroll up and IP version 6 addresses for our interface. And of course you'll notice how IP version 6 addresses are much longer and use colons as separators. Now let's try to pin an IP version 6 address. We'll use IP version 6 loopback address. So I'll type pin ::1. And on this particular system it cannot resolve ::1. Let me switch to Linux distribution and run pin ::1. So on this CentOS Linux, we successfully pinned this loopback address, comparing to macOS system, which doesn't know anything about such loopback address. And this command demonstrates that we are using IP version 6 and that our system is configured for IP version 6 communication. Finally, let's examine our system's IP version 6 routing table. So let me stop this operation by Ctrl+C and clear the screen and type IP-6 route. And in this output you can see how our system is configured to route IP version 6 traffic. Notice that there are no broadcast addresses listed, which aligns with what we learned about IP version 6 not using broadcast addresses. Let's take a look at the next question we've got, and the question is, which file is not directly read by a shell login shell, by a bash login shell? Is it option A, ~/.bash rc, bash underscore profile, bash underscore login, bash, dot profile, or etc profile file? Press pause here and think about the correct answer. And the correct answer is option A, .bash rc file. So let's take a look at bash login shell files. It's crucial to understand which files are read directly by a bash login shell, as this knowledge forms the foundation of user environment configuration. When a user logs in, the bash login shell reads several configuration files in a specific order, and these files include etc profile file, .bash bash_profile.bash login and .profile files. However, it's important to know that bash RC is not directly read by a bash login shell. Instead, it's typically sourced by .bash_profile file or other startup files. This distinction is vital for properly configuring user environments and troubleshooting login issues. Now let's start examining the bash login shells or shell files on our system. In an open terminal, I'll first look at the global profile. So I can type cat etc profile. And on this particular system, it's this shell will get such an output for the profile file. If we launch one of the Linux distributions, for instance, Debian GNU Linux version 11, let me start this Linux and I'll log in with my Parallels user, launch console, so I'll type terminal here and launch it. Now if we type cat etc profile, the output will be quite the same as you can see. Let me make it a bit smaller. Though the file is a bit longer than in my local host system, but it's quite the same. We'll get the script with system-wide settings defined here. Now let's check your user-specific files. So for this I'll type ls-la grep bash. And here it is, .bash history, .bash logout, and .bashrc file. If we switch to this shell again and retype this command again with ls-la grep bash, we won't get any files here because it's macOS and we don't get such an output as on Linux system. Now let's launch CentOS Linux and type the command there. So I'll type ls, let me close this window, ls-la grep bash. So here we get bash history, logout profile, and bash rc. And now if we add tilde here, the output could be different, but it's not, it's the same. Now let's examine the content of these files. So I'll type cat tilde / and I'll press dot and double press tab to get the files. For instance, let's start with bash_history, and that'll reveal all the commands I've typed in this system. Now let's move on to bash_profile. Again, we'll get the script, and by the way, as you can see, we'll get that it's reading .bashrc file. So if we cat tilde / .bashrc, we'll get the script we've already seen here. So please remember that this file isn't directly read by the login script, but is often sourced by other files like bash profile, like in my example. We have a reference to the bashrc file here. Our next question is related to network manager command. What is the result of the following command? nmcli device Wi-Fi connect Wi-Fi OI device name, and we've got several options for answers here. Is it option A? It opens a new public hotspot with SSID Wi-Fi OI. It creates an unconfigured virtual network interface named with Wi-Fi OI. It creates and activates a new Wi-Fi connection, returns an error if connection doesn't exist, or returns an error due to invalid Wi-Fi device name. Press pause here and think about the correct answer, and I'll reveal it in just a second. So the correct answer is option C. It creates and activates a new Wi-Fi connection. with the name specified. So as you remember, NMCLI is a powerful tool in Linux, and it's an abbreviation for Network Manager. NM stands for Network Manager and CLI for Command Line Interface. And if we focus specifically on this command, NMCLI device Wi-Fi connect, this command showcases the versatility of Network Manager in handling wireless connection. When executed, it doesn't merely attempt to connect to an existing network. Instead, it creates a new Wi-Fi connection named Wi-Fi OI and immediately activates it. So understanding this behavior is crucial for effective network management and troubleshooting. Let's take a look at this command in practice. I'll switch to the test terminal. And first, let's list available Wi-Fi networks with this nmcli command. I'll type nmcli device Wi-Fi list. No devices here because no Wi-Fi on this particular VM. We can create and connect a new Wi-Fi network taking the command from the question we've got, from the example question we've got. So for this, we'll type nmcli device Wi-Fi connect, and for instance, we'll name it my network. Hit enter. Now I'll get an error, no Wi-Fi device found, and that's expected because on this test VM I haven't got Wi-Fi device. But that's the command you can use for creating and connecting to a new Wi-Fi network. And then you could list all connections again with nmcli connection show command. You'll get the Wi-Fi device here listed if you have such one. And if you don't need it anymore, you could disconnect it from network with, again, nmcli device disconnect. Oops, not deconnect, but disconnect. And for instance, you'd like to disconnect device from the network WLAN 0. So in this case, you'd use replace this WLAN 0 with your actual wireless interface name. The next question we've got relates to nsswitch.conf configuration file, and the question is, which statement is valid in the etc nsswitch.conf file? Is it option A, multi-on, option B, IP address.dns-server record? Is it option C, namespaces net mount procs? Or option D, include etc nsswitch.d, or option E, hosts files DNS. Press pause here and think about the correct answer, which I'll reveal in just a second. And the correct answer is option E, hosts files DNS. So let's turn our attention to this name service switch configuration file, which is located in etc directory, and the file's name is nsswitch.conf. This file plays a pivotal role in system configuration, determining the source of various system databases and their lookup order. Among the various possible entries in this file, the statement hosts files DNS, this one, is particularly significant. This configuration instructs the system to first check the local files, typically etc hosts, then resolving names, and then to query DNS if the host name is not found locally. This setup offers a balance between local control and network-based resolution, allowing administrators to override DNS entries for specific hosts or to provide name resolution in the absence of a DNS server. So it's important to understand the configuration to manage name resolution and Linux systems effectively. Now let's exercise and examine and modify the nsswitch.conf file in the terminal. First, let's look at the current configuration. I'll type cat. Again, cat is one of the most frequently used commands to view the configuration file. So we'll type cat etc nsswitch.conf. And here it is. So if we find the line which was mentioned in the example question, here it is, hosts, colon, and then tab, files, DNS, my host name. Now we can go ahead and modify this file. And for this, of course, we'll need root privileges. So we'll type sudo nano etc nsswitch.conf file. We'll provide our password here and go ahead and scroll down this file. We'll find hosts line. Here it is. And as you can see, the file already contains the configuration line hosts files followed by DNS, which ensures the system checks local files before querying DNS. So please remember that you'll need nsswitch.conf file to configure these settings, and in particular you'll need to modify hosts configuration line containing files, then DNS, to first check local files, typically relocated in etc host, and then query DNS if the host name is not found locally. The next question we've got here relates to connection types in Network Manager. So which connection types may exist in Network Manager as displayed by nmcli connection show? And you need to select three options. Press pause here and think about the correct options, and as you can see we've got 5 options and you need to select 3 of them. Is it tab, Ethernet, Wi-Fi, IP version 6 or bridge? And I'll reveal the correct options in just a second. And the correct options are option B, Ethernet, option C, Wi-Fi, and option E, bridge. So if we are talking about connection types in Network Manager, and as you remember, Network Manager is a powerful tool for managing network connections on Linux systems. So if we run the command nmcli connection show, you'll see a list of available connection types. Of course, the ones present on your system. And you could get Ethernet connection type there. This is the most common type of wired network connection. Ethernet connections are reliable and typically offer high speeds, making them ideal for desktop computers and servers. Or you could get Wi-Fi as wireless networks connection types. So Wi-Fi connections are essential for mobile devices and laptops. And Network Manager simplifies the process of connecting to and managing Wi-Fi networks. And you could meet bridge. Bridge connections are used to connect multiple networks or network segments. They are particularly useful in virtualization environments or when setting up complex network topologies. Now, if we switch to the terminal and run this command, nmcli connection show, for this particular device we get only one connection type, it's Ethernet. Of course, we could try to create a new connection, for example, one more Ethernet connection or Wi-Fi connection. So for this, we'll use nmcli again and followed by connection subcommand add. Then we'll specify type and, for instance, Ethernet, and then we specify connection name. For example, let's put it in double quotes, my Ethernet. Now, if we rerun this nmcli connection show, we'll get my Ethernet among all other connections. Or we could try to rerun this command, the one we've created with, and specify, for instance, connection type Wi-Fi, right? And we'll get SSID argument is required here. And for sure, we'll need to modify this line a bit so that will contain nmcli connection at type Wi-Fi, then connection name, for example, my Wi-Fi. Then we'll need to specify interface, if name, for instance, WLAN0. It's a non-existent interface just for this example. And then we'll need to specify SSID, for instance, SSID, non-existent as seed, but it's just for this example. And again, we'll rerun this nmcli connection show and get my Wi-Fi connection name with connection type Wi-Fi. The next step could be then set the password. For instance, I'd run an nmcli connection, and instead of this add subcommand, I type modify, then I'll remove all these subcommands, will be modifying my Wi-Fi, and will remove this part as well. And by the way, to remove the part of command line, you'd press Ctrl K. That will remove from the blinking cursor till the end. And then you'll add Wi-Fi -sec.key -management subcommand, and then you'd add encryption type VPA, for example, PSK, and then again Wi-Fi -sec.psk, and you'll need to specify your password here. So that's how you'll set the password for my Wi-Fi connection. And finally, you could go ahead and activate this Wi-Fi connection with nmcli again, connection up, followed by my Wi-Fi connection name. I won't be running this command because it's non-existent Wi-Fi connection and I don't even have Wi-Fi module here. But that's how you use Network Manager to manage Wi-Fi connections, to connect, to create, to activate network connections. And again, to remind you, let's wrap up really fast, that among the connection types in Network Manager, you could meet Ethernet connection, Wi-Fi or bridge connection, TAP or IPv6 or some other such kind connections are not standard connections and you won't meet them in Network Manager. Our next question relates to global shell variables configuration. So which configuration file should be modified to set shell variables globally for all users? Is it etc profile, etc bash rc, bash underscore profile, etc dot bash rc, or etc shell environment? Press pause here and think about the correct answer. And the correct answer is option A, etc profile. So when talking about system configuration and setting shell variables globally for all users, it's important to remember that it's a crucial aspect of system administration as it allows you to define environment variables that will be available to all users on the system. And this etc profile file serves you exactly for this purpose. This file is read and executed whenever a login shell is started, regardless of the specific user. By adding your variable definitions to this file, you ensure that they are available system-wide. It's worth noting that while other files like etc bash rc or .bash underscore profile are important for shell configuration, they don't provide a global scope we're looking for in this case. Now let's practice setting a global shell variable. And first off, let's open the global profile file with a text editor. And you'll need sudo privileges to perform this action. And also let me launch Linux distribution here. Now I'll type sudo nano etc profile. I'll provide my password. And now let's add a new line at the end of this file. So I'll scroll down till the bottom of this file and type export, and let's name our new variable like global underscore var variable. And that will contain well-known expression which is hello, comma, world, exclamation point. So that will add this variable globally to this system. Now we'll save this file, hit yes, and we can go ahead and test this variable. I can log out from this system by typing logout. I'm not sure if there is such a command. Yes, there is no such a command here. So we type exit, or even let's go ahead and restart the system. So I'll type sudo shutdown -r now. Provide my password. That will restart the system. And when the system is up and running, we'll log in with our credentials, launch the terminal here, and go ahead and test this variable with echo command. Echo $, then followed by global var. And now if I hit tab, as you can see, it automatically finishes this line, meaning that the system knows about this global variable. And if we hit enter, that will get back to us with hello world string. Let me make it a bit smaller. So remember, this etc profile is the correct file for setting global variables, not etc-rc or this, if we type ls-la, or actually let's grab bash here, and of course we'll need to place it to add grab bash. So that's not the files we need to configure this global variables. We need the file which is cat etc profile, this file. And here is our variable we've just added. Our next question relates to environment variables in locale.conf. So which environment variables can be defined in locale.conf? And you should choose two options for this particular question. And the options are as follows: LC all, LC username, LC UTF-8, LC geography, or LC time. And I'll reveal the correct answers in just a second. And the correct answers are option A and option E. It's LC all and LC time. So let's examine the environment variables that can be defined in the locale.conf file. This file is used to set system-wide locale settings which determine things like language, character encoding, and time formats. Two important variables that can be set in this locale.conf file are lcall. This is a master variable that overrides all other lc underscore variables. It's typically used to set all locale settings at once. And lc time, this variable specifically controls the format of date and time output. While these variables are crucial for system localization, it's important to remember that variables like LC username, LC UTF-S, or LC geography are not standard local variables and cannot be set in locale.conf files. So all other options in this question are not standard for this file and cannot be set in this file. Now let's practice setting local variables, and I'll switch to one of my test servers console with open terminal, and I type, by the way, you'll need sudo privileges to work with this file, so I'll type sudo nano etc, and the file is locale.conf. Hit enter, provide my password, And we'll get one line here, setup, language US, English US, UTF-8. We can go ahead and add one more line here, for example, LC underscore time equals English dot, for instance, Great Britain GB dot UTF universal time format dash 8. I'll hit Control X, save the file. And now to see the effect, you may need to log out and log back in, and then type in terminal the command, for instance, date. As for now, it is set to EEST standard, and if I exit, it'll exit from my console. Let's check if it works. So I'll relaunch the terminal window and type date again. Again, it's EEST. So I'll need to hit activities. Actually, not activities, but this icon in the right upper corner. Find power off logout and select logout. Confirm. Now let's log back in with my password and launch terminal again. And as you can see, my terminal crashed after setting this configuration. So please be very careful with configuration files, system-wide, especially system-wide configuration files. Something can go wrong. So after adding LC time English GB.UTF-8, I cannot launch my terminal. As you can see, if I press terminal, it starts launching, but it fails to launch. So that's why you need to create snapshots and backups all the time before implementing system-wide configuration changes. In this particular case, I'd need to troubleshoot this local setting I've set up, but it's out of the scope of this question, so I'll go ahead and just press actions in my Parallels desktop settings and select Manage Snapshots. And I have Smart Guard snapshot creation enabled here. That's why I'm able to select this snapshot and select Go to Snapshot. I don't want to save this snapshot, so I'll click Don't Save, and that'll revert the state of my virtual machine to the previous state before I've implemented this LC time equals English GB.UTF 8 locale setting. So let me log into this machine again, and I'm logged in to the state before this change. So if I cat etc local.conf file, that will contain just one line. And if I want to proceed and set up this LC underscore time equals English underscore GB dot UTF 8 setting to this file, I'll need to troubleshoot and see what goes wrong. Maybe something connected to this Parallels VM, maybe something else. So that'll be troubleshooting process, and I'll need to find the root cause of this action, of this error, and so on. But as I said, it's out of the scope of this question. Now, to recap, you can set up different settings in this configuration files, and these two settings, LC all and LC time, are among the settings you can set up in this file. The next question we've got here is related to sudo configuration. So take a look at this sudo configuration. Jane any equals no password, bin killed, bin ID, password as bin fdisk client. And the question is, which statements are accurate? You need to select three correct answers. Is it Jane can execute bin ID only after providing her password? Is it Jane can execute sbin fdisk after providing root's password? Is it C, Jane can execute as bin fdisk after providing her password? Or is it Jane can execute bin kill without providing a password? And finally, Jane can execute bin ID without providing her password. Press pause here and think about the correct answers. There are three, as I've said. And I'll reveal the correct answers in just a second. So the answers are option C. Jane can execute sbin fdisk after providing her password. Here it is, password sbin fdisk in this configuration line. The second option, correct option, is option D. Jane can execute bin kill without providing a password. Here it is, Jane any no password bin kill. And finally, option E, Jane can execute bin ID without providing her password. Here it is, the configuration line allowing Jane to execute ID command without providing her password. So let's examine a crucial aspect of system administration, which is sudo configuration. The sudo command allows users to execute commands with elevated privileges, and its configuration determines what actions users can perform. And considering this following pseudo configuration, which we've had in our question, Jane any no password, and then we've got password part as well. So this configuration first off grants specific permissions to the user Jane. And let's take a closer look at this configuration line. The no password directive indicates that Jane can execute certain commands without entering a password. And the password directive, on the other hand, requires Jane to enter her password for specific commands. And based on this particular configuration, Jane can run kill command and ID command without entering a password, and fdisk command. In this case, Jane must enter her own password, not the root password. That's why we have this pseudo process, because it means that the user uses their own password, not the root's password. And this particular configuration does not grant Jane the ability to run these commands with root's password. So understanding the pseudo configurations is crucial for maintaining system security, while allowing users to perform necessary tasks efficiently. Now let's exercise with creating a pseudo group, adding it to the sudoers file, creating user named Jane, and adding her to the pseudo group and configuring specific pseudo permissions for. So I'll create a pseudo group on this system. So I'll type sudo group add and we'll name it sudo. So 2 pseudo words. I'll provide my password. Now let's open the sudoers file for editing. So I'll type sudo vsudo. It's a special sudoers file which we modify in VI editor. So as you can see, we've got one group added here, which is will. Let's add sudo group here. So I'll hit I to enter insert mode, then add percent sudo, and again all equals in parentheses all, again all, lots of all. All. Now let's save the file first. So I'll hit escape, write q, and we'll create the user Jane with sudo command again, sudo user add -m -s, that's for shell, Jane shell, that'll be bin bash, and the user's name Jane. Now let's change password for Jane, password Jane, and we'll provide the password, Jane's password here. Now let's add Jane to the sudo group. We'll do this with sudo usermod -a and uppercase G. We'll modify user Jane, and we'll add her to sudo group, and her name is Jane, like this. Now let's configure the specific sudo permissions for Jane. Again, I'll reopen this sudo file, go to the end of this file, hit I to insert, and remove this pound or hash, and add the following line: Jane, all. Please note that's the correct syntax for this file. You specify all, not any. And here we'll add all as well. Then no pass, wd colon, and we specify the commands, for example, bin kill, comma, bin id, comma, and with password, passwd, Jane will need to provide password to run as bin fdisk command. Let's save this file. I'll hit escape, right Q. So let me reveal this line once more. I'll type key cat. Actually, I'll need to use the sudo command again. So this line allows Jane to run bin kill and bin id commands without password, no password, and as bin fdisk with password. Okay, let me exit with Q, and we'll now need to switch to Jane's account with su-jane account. I'll provide her password here, and now we act as Jane, and we can test this command sudo bin kill-l, for example, and she can run it. Then sudo bin id, and she can run it. And finally sudo sbin fdisk-l, and she needs to provide root's password. Okay, now when she has provided root's password, she can run this sbin fdisk command. Let me clear the screen, exit Jane's console. Now, if we want to remove Jane and her home directory, we type sudo userdel -r Jane. And we could do the same for sudo group del and, for example, sudo group. I won't be doing this because I'll need this group later on, but that's how you delete the group with group del command. So again, to recap, in this question, first off, please pay attention to this any no password. It's incorrect syntax. You use all in this sudo command. But in any case, if you encounter such a question, you'll know that any means all in a question. And the configuration line containing no password means that the user can execute without password the commands, and passwd, it will require the password, the root's password, for performing the action. Our next question relates to SPICE protocol features. So which features are provided by SPICE? Is it option A, connecting local USB device to remote applications? Option B, accessing graphical applications on a remote host? Option C, replacing Xorg as local X11 server? Option D, downloading and local installing applications from a remote machine? And option E, uploading and running a binary program on a remote machine. And by the way, you should select two correct options here. So press pause here and think about the correct answers, which I'll reveal in just a second. And the correct answers is option A, connecting local USB device to remote applications, and option D, downloading and locally installing applications from a remote machine. So these are the features which are provided by SPICE among other features. Now, SPICE, as you remember, stands for Simple Protocol for Independent Computing Environments, and it's a powerful tool in the world of remote computing. Let's take a look at its features First off, remote application access. One of SPICE's primary functions is enabling users to access graphical applications on a remote host. This capability is crucial for remote work and administration tasks. Then, local device integration. SPICE allows for connection of local USB devices to remote applications. This feature bridges the gap between local hardware and remote software, enhancing the user experience. Application installation. SPICE facilitates the downloading and local installation of applications from a remote machine, and this capability streamlines software deployment across networks. X11 server interaction. It's worth noting that while SPICE interacts with X11 servers, it does not replace Xorg and as the local X11 server. This distinction is important for understanding SPICE's role in the display server ecosystem. And finally, remote execution limitations. SPICE does not provide functionality for uploading and running binary programs on remote machines. Its focus is on display and interaction rather than remote execution. The next question relates to systemd timer unit. So, which section is present in a systemd timer unit? Is it option A, events, option B, timer, option C, cron, option D, schedule, and option E, trigger? And the correct answer is option B, timer. So let's discuss systemd a bit. As you remember, it's a suite of basic building blocks for a Linux system. One of its components is the timer unit, which allows systemd to activate services or run commands at specified times. In a systemd timer unit file, the key section is timer. This section defines when and how often the timer should activate its associated unit. Other sections like events, cron, schedule, trigger are not standard in systemd timer units. The timer section can include directives such as onBootSec, which defines a timer relative to when the machine was booted up. OnUnit ActivateSec, it defines a timer relative to when the timer is activated and was last activated. And on calendar, it defines real time, for example, wall clock. Timers with calendar event expression. Now let's switch to console and practice a bit systemd timer unit. So first let's create a new service file. For this I'll type the following command: sudo nano, and we'll open etc systemd followed by system directory, and let's create, for example, hello.service file. Now we'll add the following content to this service file. First, we'll declare that it's a unit. So in square brackets, I'll type unit, and then let's add description. For example, say hello. Then we'll create service block, again in square brackets, and it'll be type one short, for example, and exec start will be bin echo command, which will output the following string. Again, very popular phrase, hello, comma, world. And then we'll add one more section we'll add blank space, and in square brackets we'll add one more section, install, and we'll add wanted by keyword dash user dot target. Okay, we'll save this file. I'll press yes to save the file, and now we are ready to create a timer file. Again, we'll rerun the previous command, but this time we'll remove the service extension and add timer. Again, we'll modify this file. Unit, let's add description and for example, say hello. Let's make hello from uppercase every 5 minutes. Now we'll add timer block in square brackets, so I'll type timer and that will be activated on boot sec equals 5 mins or min. And one more parameter on unit active sec, again 5 min. And install block will contain wanted by keyword timers target. Let's save this file by pressing Ctrl X, yes. Now we can enable and start the timer. For this we'll use sudo command again, systemctl enable hello.timer. And as you can see, if I press tab, the system already knows about this hello timer. It auto-completes this command. So I'll hit enter here and this timer is enabled. And we'll do the same, not the same, but I'll rerun this command, find this command and rerun it with start subcommand. So now this timer is started. And we can go ahead and check the status of our timer with sudo systemctl command and status subcommand, and we'll check hello.timer timer. As you can see, it's active, waiting, and the trigger will work in 4 minutes 33 seconds. If we queue and rerun this command, now it's 16 seconds left to run this trigger. So to exit from this status, we press Q, and that's how we activate the timer. Our next question relates to command sequence output. So what is the output of this command sequence? Echo 1, 2 through 6 in double quotes, then pipe, while, read ABC, do echo result, CBA, done. So that's a one-liner with while block, and the options we've got: option A, result 654, option B, from 1 to 6, option C, from 3 to 6 and 2, 1, option D, result from 6 to 1, and option E, result 3 to 1. Press pause here and think about the correct answer, and I'll reveal it in just a second. And the correct answer is option C, 3, 4, 5, 6, 2, 1. Let's check this answer, but first let's recall a bit the bash scripting techniques, and let's analyze a command sequence to understand how shell scripting works. So this sequence demonstrates the use of pipe, first of all, here it is, and a while loop with the read command. So we start with this while keyword followed by the read command. So first the echo command outputs the string from 1 to 6, right? This output is piped to while loop. So echo outputs from 1 to 6 and it is piped to this command, while, read, and so on. Then the read command assigns the first 3 space separated values to variables A, B, C. So 1 is assigned to A, 2 is assigned to B, and 3 is assigned to C, respectively. The loop then echoes these variables in reverse order. So this command echoes these variables in reverse order. Now, read assigns only 3 variables. So A gets 1, as I said, and so on. C gets 3, 4, 5, 6, all remaining values. So now let's practice this command sequence and see it in action. So first let's open a text editor and create a new file named sequence.sh, for example. So I'll type nano sequence.sh, and we'll add shebang here. That's hash, exclamation point, bin, bash. Next, we'll add our loop. First, echo command, and that was 1, 2, 3, 4, 5, 6. Now we'll add a pipe and while loop. So it starts with while keyword followed by read command, and we'll add variables here a, b, c. Right? Now we finish this part of the while loop, and we continue it with do keyword. So while it is processing this, do the following, and we'll specify what to do. Echo result colon, and now we are referring to these variables c, variable b. As you remember, to refer to the variable we use $, and a. And when we are done, we add such a word, done, keyword. Now let's save this file. I'll press Ctrl X, Y to save the file, and we'll add +X. It means that we can execute this file. So we'll specify sequence.sh and ls-la sequence.sh, and we'll see that it is an executable file with access for user, group, and so on. So we can go ahead and run this file with /sequence.sh. Hit enter, and we get the result 3, 4, 5, 6 to 1. That is the correct answer for this particular question. And by the way, you can run this sequence.sh file by adding a keyword bash sequence.sh, and that will run this script as this method /. Our next question focuses on date command capabilities. The question is, which tasks can the date command accomplish? Is it option A, set the system's date and time? Option B, set the system's date but not the time? Option C, calculate the time span between two dates? Option D, print a calendar for a month of a year? And option E, display time in specific format. Press pause here and think about the correct answer. And the correct answer is option E. It sets the system's date and time. Now, date command in Linux is a versatile tool for time-related operations. Let's examine its functionalities. So first, time setting. The date command can set both the system's date and time. This is a powerful feature for system administrators managing time-sensitive operations. Then date-only setting. Contrary to what some might think, the date command cannot set the system's date independently of the time. These two aspects are intrinsically linked in the command's operation. Then the next option was time span calculations. While useful for many tasks, the date command does not have built-in functionality to calculate the time span between two dates. For such operations, additional tools or scripts would be necessary. The next option was calendar display. The date command itself does not print calendar for month or year. This functionality is typically provided by separate commands like cal and custom time display. One of the most flexible features of the date command is its ability to display time in a specific format. This allows for customized time outputs tailored to various needs. Now let's practice date command. I'll switch to my console. I'll now use the date command to set our system's date and time. And the syntax is sudo date, and the format is as follows: month, day, hour, minutes, and year, seconds. So that's how you set the date on your system. So if, for example, you want to set the date for your system like this, sudo date, you want to set it, for instance, for to January 1, 2025, 12 p.m., you type sudo date 0101 1200, then 2025.00. Hit enter and that'll update your date and time on your machine. Now we can display custom time format in custom time format. Let's use the date to display the time in a specific format. We'll use date and in single quotes I'll type plus %year, then dash %month, dash %day, %hour, then I'll add colon here between hours and minutes, %minutes, again colon, %second. Let's try this command, and as you can see, it outputs the date and time as asked. So this gives us the year, month, day, followed by hour, minute, and second in a neat customized format. And we could add dash here between 10 and 12, so let's go ahead and add a dash here, rerun it, and now it looks as so. The next question focuses on find command usage. So which command finds all files owned by root that have the set UID bit set? Is it find / followed by dash user root dash perm dash 4000? Is it option B, find / user 0 mode plus s? Option C, owner root dash set UID, option D, owner 0 dash perm bits 0x and 10 million, and option E, find dash dash filter UID equals 1 dash dash filter pers equals UTS. Press pause here and think about the correct answer. And the correct answer is option A, find / dash user root dash perm dash 4000. So as you remember, the find command is a powerful tool for locating files and directories. Let's focus on specific use case. To find all files owned by root with the set UID bit set, the correct command was find user root. Here it is. So let's take a closer look at this command. This / starts from root directory, then dash user root filters for files owned by the root user, and this dash perm 4000 looks for files with the set UID permission set. This command is crucial for security audits, for example, or system administration tasks. It helps identify potentially sensitive files that have elevated execution privileges. Now let's practice using this find command to locate files with specific attributes, and we'll use this command to find all files owned by root with the set UID bit set, and for this we'll run sudo because we are looking for root's files, and then followed by find command. Then we'll add / start point is root of the system, and then user root perm dash 4000. Let's run this command, and that'll be searching and revealing the files we need. So again, it started from the / which is root of our system, and it is looking for user root, filters for files owned by the root user, and it looks for files with the set UID permission. And as a result come in, we can see various system binaries and executables. These files can run with root privileges, which is why it's crucial to be aware of them for security reasons. Our next question focuses on time zone configuration. And the question is, which command sets the system's time zone to Canadian Eastern Time? Is it local gen-t-f USR share zone info Canada Eastern, and this string redirected to etc local.tz. Option B, tzconf etc local time. Option C, system sysctl -w clock tz equals Canada Eastern. Option D, modprop tz underscore Canada underscore Eastern, or option E, ln-sf USR share zone info Canada Eastern etc local time. Press pause here and think about the correct answer. And the correct answer is option E, using link command -sf USR share zone info Canada Eastern, and we're linking this to etc local time. So let's explore the details of time zone configuration in Linux system. A crucial aspect of system administration is ensuring that your system's time zone is correctly set. This is particularly important for maintaining accurate logs, scheduling tasks, and synchronizing with other systems. The question at hand asks about setting the system's time zone to Canadian Eastern Time. Among the options presented, the correct answer was this one, using ln command. This command creates a symbolic link from the specific time zone file to etc local time. It's a standard method for changing the system time zone in many Linux distributions. The -s option creates a symbolic link, while -f forces the creation, overriding an existing file. It's worth noting that other options such as using tzconfig or time-date-ctl may also be valid on some systems but weren't among the choices given. Now let's start practicing how to change the system's time zone to Canadian Eastern Time, and I'll switch to my test virtual machine, and let's issue time date ctl command. As you can see, various information on different aspects of time date ctl output. Now let's change the time zone to the one we've met in the question. So I'll type sudo ln-sf usr share zone info Canada Eastern, and we'll link it to etc local time. Hit enter, and now let's verify with time date ctl. Now, as you can see, it's changed to the one we need. So we see that the time zone has been updated to Eastern time. We can find it in this line. Time zone Canada Eastern. Our next question relates to user profile configuration. Here is the question: what is true about .profile file in user's home directory? Option A, it must be executable. Option B, it must call the binary of the login shell. Option C, it must use a valid shell script syntax. Option D, it must start with a shebang. Or option E, it must be readable for its owner only. Press pause here and think about the correct answer. And the correct answer is option C, it must use a valid shell script syntax. So moving on to user profile configuration, we encounter a question about the .profile file in a user's home directory. This file plays a significant role in setting up a user's environment when they log in. The correct statement about the .profile file is that it must use a valid shell script syntax. This is crucial because the file is sourced or executed when a login shell starts, and syntax errors could prevent the shell from starting correctly. So it's important to understand that while other options might seem plausible, they are not strictly required. The file .profile doesn't need to be executable. It's sourced, not executed directly. It doesn't have to call the binary of the login shell explicitly. A shebang isn't necessary since it's sourced, not executed as a script. And while it should have appropriate permissions, it doesn't have to be readable only by the owner. Now let's switch to our VM, test VM, and have some hands-on practice with user profile file. First, let's view the contents of the file. For this, we'll use cat command. I'll type cat tilde / dot profile. And on this particular system, this file does not exist. Let's check it on the other system. Let me launch Ubuntu system and check it there. So again, I'll type cat tilde / dot profile. And here we can find this file. So you can examine and go through the contents of this file. And when you are done, you can go ahead and add a simple valid shell command to this file. For instance, we could type echo and in double quotes, again, we'll run echo and our well-known expression, which is hello, comma, world. Or actually, let's add something else right now. Let's add hello from dot profile, exclamation point. And now and by the way, we need to close single quotes here, and we'll append it to tilde / dot profile file. Hit enter, bash event not found. So in this particular case, the command I've tried to run encountered an error. Bash exclamation point event not found. It suggests that the shell is interpreting the exclamation mark in my command as a history expansion character, which is causing the issue. Now let's try to fix this issue, and we can use the escape character, and we can go ahead and escape the exclamation mark, or we could use single quotes for the entire string. So let's correct this command. I'll bring it back. Actually, I cannot find this command because it was not executed, so I'll need to retype it, echo, and now we'll run echo command once more. Again, hello dot comma, oh, actually we don't need this comma, hello from dot profile. And by the way, that is a good example of using these escape characters, how to escape the special characters, special symbols in Bash. And exclamation point is one of the special symbols used in Bash. So we'll need to escape it with backslash. We escape the special symbol to show the Bash that it should interpret the special symbol. In our case, it's exclamation point as an ordinary letter, as a string. And again, we'll close single quotes, close double quotes, and try to append it to tilde / dot profile file. Let's try to run it once more, and now it's okay. So it worked to add the desired line to our dot profile file without triggering the history expansion error. Ubuntu suggests me to update. So it suggests me to update to version 24.04 or actually upgrade. So I'll press ask me later. Now we can go ahead and cat the contents of our profile file. It's tilde / profile, and we'll get this line here, which should be executed when running or reading dot profile file. Now, to test it, you can simulate a login. So I'll type bash -- login, and we'll get this line hello from profile. And by the way, it's displayed not that correctly, though we've managed to add this line to the dot profile file, it's displayed not that correctly. So there is another way how we could add this line with echo command. So let me find the command. Something wrong with my history here. I'll need to check it, but no time for that. Okay, let's retype the correct command. I'll type echo, again, single quotes, followed by echo command again. Then I hope I won't be mistaken here because we'll need a lot of quotes here. We'll start with single quote, then double quote, and single quote inside of double quotes again. So this is a double quoted single quote. It's a way to insert a single quote into the string. And then we'll type, again, single quote, and type hello from dot profile, exclamation point, and close single quotes here. Again, we'll add double quotes, single quote inside of these double quotes. It's another double quoted single quote to close the string. And we'll add an empty set of single quotes here to properly close the outer echo command. And now we'll try to append this to our tilt dot forward slash, tilt forward slash dot profile file. Let's try to run this command. And now let's rerun bash login command. So I'll type bash dash dash login. Now we get this typed out correctly. Hello from dot profile. So we can go ahead and open this nano tilt forward slash dot profile file and find the previous line, this one, and delete it. Actually, I can do this with Vim because that will be more convenient to delete the line in Vim. So again, Vim tilt forward slash dot profile. Command Vim not found. It can be installed. Okay, let's try to run VI. We'll go to the end of this file with uppercase G. So Shift G will put us to the last line of the file, and we'll press K to move one line up, and we'll press DD to remove the line. And by the way, it seems like it could be the easiest way to add this line to this file. Just open it with a text editor and add the line. But I wanted to show you how you could add this line from the command prompt in case you'll need to use it in some automatization and you need to do the things automatically. Okay, that will finish up this lesson on dot profile, which is user profile configuration file. Welcome to our lesson on Red Hat Enterprise Linux. In this lesson, we'll explore the fundamental concepts and features that make RHEL a preferred choice for enterprise environments. As we delve into this robust operating system, you'll gain insights into its key strengths and capabilities. So let's begin examining the core features that set RHEL apart. First and foremost, RHEL is renowned for its enterprise-grade stability and security. This makes it an ideal choice for organizing the enterprise networks in organizations that require a reliable and secure platform for their crucial operations. Another standard feature of RHEL's long-term support and update cycle. This ensures that your systems remain current and protected over extended periods, which is crucial for maintaining the integrity of IT infrastructure. Moreover, RHEL comes equipped with comprehensive management tools that simplify system administration tasks. These tools enable IT professionals to efficiently manage and monitor their systems, reducing complexity and improving productivity. Lastly, but certainly not least, RHEL boasts powerful virtualization capability, which we'll be using for building our lab. This feature allows organizations to optimize their hardware resources and create flexible, scalable environments to meet their diverse computing needs. Now let's turn our attention to the installation process. RHEL's versatility shines through in its ability to be installed on various platforms. Whether you're working with physical servers, virtual machines like those on Hyper-V, or cloud environments, RHEL can be deployed to suit your specific requirements. And I personally will be installing RHEL on Hyper-V, which is available on my laptop. It's worth noting that before any installation, it's crucial to verify the system requirements. This ensures a smooth installation process and optimal performance of your RHEL system. Moving on to package management, RHEL utilizes DNF or Identified UM as its primary package manager. DNF is a powerful tool that simplifies the process of managing software on your RHEL system. With DNF, you can easily install, update, and remove software packages. It also handles repository management, ensuring that you have access to the latest software and updates. One of DNF's most valuable features is its ability to automatically resolve dependencies, saving you time and preventing potential conflicts. Now, RHEL provides a robust set of system administration tools, and I'll be actively using one of these tools. So these tools empower IT professionals to manage their system effectively, saving their time. Let's explore some of these key tools. First, we have Cockpit, a well-balanced web-based administration interface that allows you to manage your RHEL systems through a user-friendly GUI. This tool is particularly useful for those who prefer graphical interfaces over command-line operations, and I'll be actively using these tools during the demonstrations. It's also useful to connect several remote RHEL servers and switch between these servers. Next, there is systemd, which serves as both the init system and service manager for RHEL. Systemd is responsible for bootstrapping the user space and managing system processes after booting. For network security, RHEL includes firewalld, a dynamic firewall manager. Firewalld makes it easier to configure and manage firewall rules, enhancing your system's security posture. Lastly, we have SE Linux, or Security Enhanced Linux. This powerful security module provides an additional layer of access control, allowing for fine-grained security policies that go beyond traditional Unix permissions. RHEL has got also a robust virtualization capability, specifically focusing on KVM, or kernel-based virtual machine. KVM is integrated into RHEL, providing a powerful platform for creating and managing virtual machines. I'll be using KVM to create virtual machines, actually nested virtual machines, because I'll be creating them on top of virtual machine. So first I'll create a virtual machine based on Hyper-V, and then I'll create nested virtual machines in this RHEL host virtual machine. So with KVM, you can efficiently utilize your hardware resources, in my case that'll be virtual resources, by running multiple virtual machines on a single physical host. In my case, that'll be nested virtual host. This capability is particularly valuable in environments where resource optimization is crucial. KVM also supports live migration, allowing you to move running virtual machines between physical hosts with minimal downtime. Это надо будет вырезать. With minimal, это тоже надо будет вырезать. Allowing you to move running virtual machines between physical hosts with minimal downtime. This feature enhances flexibility and facilitates maintenance tasks. An interesting aspect of KVM is its support for nested virtualization, as I've already mentioned. This means you can run virtual machines within virtual machines, opening up possibilities for complex testing environments or multi-tiered virtualization scenario. And by the way, I've never used level 2 nested virtualization. I used it on Windows Server virtual machines, but I haven't used it on Linux virtual machines. Now, before we begin, let me introduce you to our simple lab environment. We're working with a virtual machine named RHEL9, which is running on Hyper-V. This VM server serves as our primary RHEL system and will also act as a host for nested virtualization, allowing us to create and manage additional VMs within it. Here are some details of our lab environment. I'll name this virtual machine simply RHEL9. I'll give it an IP address 192.168.1.22. Its purpose will be server for nested VMs, and management interface will be remote SSH connection and cockpit. We'll be using the cockpit web interface to connect to RHEL9 and manage our nested VMs and the RHEL9 VM itself. This setup will allow us to explore RHEL's capabilities in a controlled environment while also demonstrating its powerful virtualization feature. Welcome to our lesson on installing VirtualBox on Mac. We're going to explore the process of setting up this powerful virtualization tool on your Mac computer. VirtualBox allows you to run multiple operating systems simultaneously, making it an invaluable resource for developers and IT specialists, and anyone interested in exploring different operating environments. Before we dive into the installation process, let's take a moment to discuss the system requirements. To ensure a smooth experience with VirtualBox, your Mac should meet the following criteria. You need a Mac running a recent version of macOS, at least 4 gigs of RAM, although 8 or more is recommended for optimal performance. Sufficient free disk space to accommodate your virtual machines. It's worth noting that the performance of VirtualBox largely depends on Mac's hardware capabilities. The more powerful your machine, the better your virtual machines will run. Now that we covered the requirements, let's move on to obtaining VirtualBox software. Please follow these steps to download VirtualBox. So open your preferred web browser and navigate to the official VirtualBox website. Let me open one tab more, and I'll type VirtualBox and click the first link, which is Oracle VM VirtualBox. Now look for the prominent download button on the homepage and click it. Here it is. Right now it's VirtualBox 7.0. But your version could be different. I'll go ahead and click this button. Click on the version specifically designed for your operating system. In our case, it's Mac OS, and I'll locate this link and click it. You'll get a warning, do you want to allow downloads on virtualbox.org? I'll click Allow, and that'll start the download process. Please remember that it's crucial to always download software from official sources. So please double check that you're located on virtualbox.org official website. Now, while it's being downloaded, let me go back to the presentation and we'll see what we've got here to be completed. Let's go on and see what's next. Next, we are going to open the downloaded .dmg file, double-click the virtualbox.pkg file, and then we'll follow the installation wizard and enter our Mac password when prompted. Now, with the VirtualBox installer downloaded, we are ready to begin the installation process, and for this I'll open Downloads. As you can see, here it is in my right upper corner, the arrow pointing down. So I'll go ahead and double click this VirtualBox.dmg package. Now I'll need to locate the downloaded .dmg file. Here it is, number 1, and click this VirtualBox.pkg link to start downloading process, to start installation process. That will open Install Oracle VM VirtualBox, and you can read about this version for macOS, and when you're done, click Continue. Now you are welcome to select a destination for your VirtualBox installation, and you can choose either to install for all users of this computer, or install for me only, or install on a specific disk. So I'll go ahead and click Continue with installation for all users of this computer. And as you can see, that will take roughly 260 megabytes of space. So I'll click Continue. Again, you can change installation location in this window, but I'm okay with this one, and I'll click Install. That will require your administrator's password, and I'll insert it and click Install Software. And that will take less than a minute to install this software. I'll click Close, and I'll select Move to Bin, not to keep this installation file on my disk. I won't be needing it anymore. So I'll click Move to Bin, and that will close the installation window. Now we are ready for post-installation steps. So after the installation wizard completes, there is one more crucial step to ensure VirtualBox functions correctly on your Mac. This step involves granting VirtualBox permissions to load its kernel extension. So for this, you'll need to open the system preferences on your Mac. You can do this by clicking on the Apple menu and selecting System Preference. So let's click Apple and select System Settings. Now locate Privacy and Security. Here it is. So that's the place we need for further steps. So first let's try to launch VirtualBox. To perform our first launch, for this I'll press Command Space and start typing virtual, and that'll offer me virtualbox.app. I'll click it, and I'm ready to add new virtual machines here. So I can click this big green plus to add virtual machines. For now, I'll click Cancel and close this application. Now, in case you get this message in System Security and Privacy menu, for example, like System Software from Developer Oracle America Incorporated was blocked from loading, you'll get next to this message that you should see an Allow button. Click the Allow button to grant VirtualBox the necessary permissions. And you can be also prompted to restart your Mac for these changes to take effect. If so, go ahead and restart your computer. So that'll finish up our demonstration on Oracle VirtualBox installation on macOS. First off, let me create a virtual machine with Red Hat Enterprise Linux 9. For this, I'll use Hyper-V hypervisor, but you could also use any other hypervisor like VirtualBox, VMware, or Vagrant virtual machine, VirtualBox. So I'll right-click my Hyper-V Manager, Host, click New, click Virtual Machine, give it a name. It'll have a host name rel9. I'll also select a new location for this virtual machine. It will be located on drive D in VM folder. And when I'm done, I'll click Next. So I'll browse to the necessary folder and select it. Then I'll accept the defaults for CPU, virtual memory, and I'll select networking external adapter for this particular machine. And now I can select an ISO image with Red Hat Enterprise Linux 9. So I'll click Browse and find the necessary image file. Click Next and click Finish. And we are done with installing, with creating a new virtual machine and ready to move on. So I'll connect to this virtual machine by double-clicking it and click Start. And now we get this window with selecting options for startup. We can select to check installation media, and we can select troubleshooting. And the first option is to install Red Hat Enterprise Linux 9.2. Now it's the latest version I found, so I'm installing this one, but your version could be different. I'll press Enter and the installation process starts. When all the necessary files are loaded, we get this installation summary window where we can change different options for this fresh installation, like selecting keyboard, language, time and date. We can connect to Red Hat, but for this you need to have this registration on Red Hat Linux official site. It's very important that you get this free development license, which you can use for your testing purposes. It gets lots of benefits, and the most important benefit is to update and install different Red Hat packages. Now we can select installation source and we can select software to install. For this installation, I choose server with GUI with all the defaults. And when I'm done, I press this blue Done button. Then we can configure networking. Here I could type in a host name, which is rel9, and set up networking configuration, static or dynamic. So I'll add, for example, 192.168.1.109 IP address for this particular virtual machine, like an example, and net mask 255.255.255.0, gateway settings like 192.168.1.1, and DNS servers could be also configured here. When I'm done, I click Save and Done. Now we should configure root password. I'll type in some simple password for this particular testing server. We could also allow root SSH login with password here. And user creation, I'll type in full name and username, which would be Shumi. And don't forget to make this user administrator and type in password and then repeat the password and click Done. When I'm finished with all the settings, I'll click Begin Installation. It will take some time, so I'll press pause here, and when the installation is finished, I'll get back to you. So now it's done, and I can press Reboot System. When the reboot is done, the system will launch, and I can log in with my credentials, typing in my simple password, and as you can see, we can register system right away. So Red Hat offers to register system right away, and I strongly recommend you to do this because it will give you lots of benefits. Especially you can do this with free of charge for development purposes. In this lesson, we'll be registering Red Hat Enterprise Linux from the command line. This process is essential for accessing Red Hat subscription management, downloading updates, and obtaining support. So I'll guide you through the steps needed to successfully register your RHEL system using command line tools. And by the end of this lesson, you'll be able to understand the importance of registering your RHEL system. Use command line tools to register and manage your RHEL subscription, and verify the status of your subscription, of your registration, and manage subscription. Please note that to reproduce these steps, you need to have valid Red Hat subscription credentials. As demonstrated in earlier lesson, you can sign up for these credentials and for development, for the credentials as a developer on RHEL official site. So Red Hat Subscription Management is a service provided by Red Hat that allows users to manage subscriptions and entitlements for Red Hat products. The importance of registration is that you can access the software updates and security patches, you can get support from Red Hat, and you can access Red Hat software repositories. Now, to register your system, open the terminal. In our case, it'll be our newly created Vagrant virtual machine, VM1. So I'll type Vagrant SSH VM1, and I'll type the registration command, which is sudo subscription manager register -- username and my username and -- password, my password. In your case, you have to replace username and password with your subscription credentials. Now, when it's done, we can attach a subscription by typing in the following command: sudo subscription manager attach -- auto. This command automatically attaches the most suitable subscription available for your system. Next up, we verify and manage our subscription. So to verify your registration and confirm that your system is registered, type in the following command: sudo subscription manager status. Now we can list available subscription and view all available subscriptions with the following command: sudo subscription manager list -- available. Now, if you need, you can change or update your subscription using various subscription manager commands. In this video, we'll be installing KVM on RHEL system, which is running on Hyper-V virtual machine. So I've got RHEL 9 virtual machine on which I want to use nested virtualization with KVM, so that I'm able to create virtual machines inside virtual machine. And I can do this with KVM or with Vagrant, for example, which will be using KVM virtualizer. First off, you need to turn on nested virtualization on your Hyper-V virtual machine. You do this with sat VM processor command, then VM name. In my case, the name of my virtual machine is RHEL 9. Then you need expose virtualization extensions parameter set to true. I'll type $true and hit enter. Right now, I'll get an error because, first of all, this virtual machine is running. You do this when your virtual machine is in turned off state. And I don't have permissions here because I'm running this session not as the administrator. But in my case, this parameter is already turned on and I can switch to the step 2. First, I'll connect to this virtual machine. It's 189 IP address, it's RHEL 9 system. And the second step is to check if the virtualization is turned on, and you can use virtualization on your computer. If you are using physical computer, you run this command as well, because you need to know if your physical computer supports virtualization. And we do this with ls cpu command, then pipe grep. We need to find vmx pipe svm. Or you can search for grep virtualization. And as you can see, we've got full and VTX support for virtualization. I'll clear the screen, Ctrl L, and we continue to the step 3, which is install KVM or CAMO. First we'll run sudo yum update -y. We'll ask for password. The system is being updated, and after it's complete, we'll perform a reboot. Now when the system is updated and upgraded, we can continue and reboot it. We can continue. I'll log in into RHEL 9 system, and we continue installing KVM. We'll install the following packages for KVM virtualization. The first one is libvirt, the libvirt virtualization library and management tool. So we'll type sudo dnf, another package manager, install libvirt. It'll check the repositories first and then install the package. I'll click OK, Y, Enter. That is the first package we need. The second one is virt install. It's a command line tool for creating virtual machines. So I'll press up arrow and replace libvirt with virt install. We'll need the password again. Wrong password. How you can make a typo in password which is 123. I just did it. And after it is done, we'll do the same for libvirt-client, camo-kvm, camo-img, and libguests-fs-tools packages, which are also needed for the KVM virtualization. libvirt-client is a package which provides command line client tools for managing libvirt-based virtualization environments. Camo-kvm is the Camo emulator with KVM support. Camo-img, it's a tool for manipulating disk images used by virtual machines. And libguests-fs tools is a set of tools for accessing and modifying virtual machine disk images. So let me bring back this command, and I'll add these packages to this command. Actually, I'll clear the screen, and here we'll need libvirt-client, camo-kvm, camo-img, libguests-fs tools, and we'll use -y parameter not to answer if we want to install the package all the time. And it starts installing. I'll hit pause here and get back to you when it is done. Now, when it's installed, let's check if the packages have been installed successfully. I'll run rpm-q camo-kvm. Good. Now let's enable the KVM service at system startup and check the status. We'll run sudo systemctl enable now libvirt daemon. And let's check the status of this system. We'll type sudo systemctl status libvirt daemon. It's running. To exit the status, we hit Q. And finally, let's verify that KVM has been installed and that we can create and manage virtual machines. We'll type sudo virt host -validate. Not validate, I had a typo. So this is pass. It doesn't fit the screen. I've made the text larger here because for you to better see the demonstration. Now we can go ahead and install Cockpit to manage KVM from a web interface. So first I'll run the following command. Sudo yum install Cockpit and Cockpit machines. I'll hit yes here, and the installation is complete. Let's start Cockpit by running sudo systemctl start cockpit. Now, if we switch to graphical user interface and start Mozilla, for example, I'll type localhost colon 9090. Hit enter. We can log in with our username. I'll type mine and very secure password, which is 123, and hit login. Let's save it. So you can find system information in this cockpit window. We'll be talking about cockpit in much more detail a bit later, but for now we need this virtual machines link. I'll click it, and we can try creating a new virtual machine by clicking this create VM. For now, I'll cancel this process because we don't need to create a virtual machine right now, so I'll click cancel. I guess we are done with KVM installation on RHEL 9 virtual machine. In this hands-on demonstration, we'll focus on installing Red Hat Enterprise Linux system. It's RHEL 9 system. As you can see, I've launched this virtual machine server. Its name is RHEL 9, and it's with cockpit activated. So I've switched to remote management of my Red Hat Enterprise Linux virtual machine. That's the Red Hat Cockpit, and to connect to your Red Hat Cockpit, you'll need to enter the IP address or host name of your virtual machine, of your RHEL virtual machine. In my case, it's 192.168.1.189, and you'll need to add colon 9090. That'll connect you to the cockpit of your virtual machine. But for this, you'll need this feature to be installed on your server. To do this, you'll need to perform yum install cockpit and then enable this service with systemctl enable --now cockpit.socket. So let me hit enter here to refresh the connection. When you connect to your cockpit, you'll get authorization window. You'll need to enter your username and password, and then you can take a look at the system overview. As you can see, I've got 8 gigs of RAM installed on this RHEL system, 8 CPU usage, memory, host name, here it is. You can even domain join here to Active Directory domain controller. We can go to virtual machines here and create a new virtual machine, and we'll be creating virtual machines for Ansible Lab environment. And by the way, you can get a terminal right from here. Let me increase font size here, and I'll demonstrate how you can install Cockpit in the terminal of your RHEL server, in case it's not already installed. So you'll need to type in sudo command yum install cockpit. Hit enter, add your password, administrative password. It will check for subscription management repositories. By the way, you'll need this system to be registered. Hit yes here. And in my case, it's upgrading the cockpit to the latest version. Let's clear the screen, and then you'll need to run the following command: sudo systemctl enable now cockpit.socket. Hit enter, and you'll also need to add some firewall rules, namely one firewall rule with sudo firewall-cmd. It could be done by default, but in case it's not added, you can do this with this command: sudo firewall-cmd --add service equals cockpit --permanent. So it'll permanently add this firewall rule. Hit enter. As you can see, it's already enabled on my system, but in case it's not enabled on your system, you'll need to reload firewall with the following command: sudo firewall-cmd reload. And of course, we'll need to add this 2 dashes before reload. Okay, success. Now back to creating our Ansible lab with the help of Red Hat virtual machines. So to create a virtual machine on Red Hat Enterprise Linux is quite simple task. We'll hit this virtual machines tab and we'll hit create VM. Here it is, this button. This will create from local or network installation media. Now you'll need to fill in the details. For example, memory, storage limit, the minimum is 10 gigs for virtual machine. And we can select download an OS, cloud-based image, or local install media, ISO image. I'll select download an OS, and we can now select the operating system we want to download. Let's install Red Hat Enterprise Linux 9.3, the latest version, and you'll need to generate offline token to install this virtual machine to download it from official Red Hat site. So when you do this for the first time, you'll get the link, generate the token. You can click it and it'll lead you to Red Hat site, and on this site you'll be able to generate this token. You'll hit generate button and then you can copy it like I do, and you'll need to get back to your virtual machine creation and paste it here. When it's done, you can go ahead and click create and run. That'll take some time to download this image from Red Hat site, from 1 till 10 minutes, depending on your internet connection speed. But in my case, I've already done it, and as you can see, the state changed to green running, and we can hit this link with the name of our virtual machine. I'll hit it, and we can see the details, the overview of this virtual machine. The state is running, memory 2 gigs, CPU 2 vCPUs, the usage of resources, network interface, and so on. Now we can go ahead and continue the installation of this Red Hat Enterprise Linux 9.3. We can click this expand button and hit enter to get this process started. That'll take some time to perform some initialization tasks, normal Red Hat initialization tasks. It'll check the system and the resources. Now, while it's being booted, let me switch back to Red Hat portal and demonstrate you how the subscriptions tab looks like. So I'll switch to subscriptions here. That'll display all your valid subscriptions. As you can see, I've got Red Hat Developer subscription for individuals, it's free, and Red Hat Beta Access, it's free. And the quantity you've already used. Now, if you go to Manage and click Activation Keys, you'll get the ID of your organization, and here you can create a new key. For example, you can hit New, give it a name, service level, and attach the subscription to this. I'll get back to the previous page, and as you can see, I've already created one key. I can use this key to register my Red Hat VM, which is now being installed. So I'll use my organization ID and the key I've created. Of course, you'll get your own organization ID. It'll be different from mine, but that's how you create the activation key for your organization. So I'll get back to installation of RHEL 9 system, and it offers me to select language. I'll leave the defaults, English, United States, click continue, and we are getting this installation summary page where we have to complete some configuration details. First off, let's go to installation destination. As you can see, the default drive is selected. It's okay. I'll click done. Then we can connect we need to connect this Red Hat server to the Red Hat registration site with the details I've just demonstrated. So we'll need to select activation key, the organization, and the activation key itself. When it is done, I'll click Done. That'll take some time to register this system. And you'll need to select also role here, Enterprise Linux Server, Self-Support, Usage, Development Test, and hit Register. So it's now registering this system. It'll take about a minute, and seems like I've made a typo here, so I'll correct the key and hit Register again. Okay, now it's done. Here is the subscription details, start date, end date, one consumed, system purpose, method, and insights. Okay, I'll click Done. And now we'll need to add root password, retype it, click Done, and user creation. I'll type in full name of my user and username, make him administrator, and add the password. Hit Done, and it warns us to please complete the mark with this icon before continuing to the next step. So we'll need to select software. Let's do this for minimal install, standard installation. Click Done, and now we can begin the installation by clicking this big blue button in the right bottom corner. Here it is, I'll click it, begin installation. Again, that'll take some time, and when it is done, I hope the system will be up and running and we can connect. Now when the virtual machine is installed, we can log into its console with the user I've created before and password as well. If successfully logged in, we can run the command IP-A to get its IP address. And by the way, we can scroll down and find the IP address of this virtual machine right here in network interface. It's .122.10. Let me copy this address. Now we can switch to the terminal and try to SSH to this virtual machine. I'll allow the text and images to be copied into the clipboard. Hit Enter, and as we log into this virtual machine for the first time, we'll need to type yes. We trust this connection. And that's it. The virtual machine is set up. Let me enter the password. We can check its version with cat etc asterisk release asterisk, and it's version 9.3. Now we can get back to the virtual machines section, roll up. Let's shut down this virtual machine. We'll shut down, go to virtual machines tab, and we can click these three dots to the right and hit clone. Let's give it a name, for example, control. That'll be our control node. So we'll hit clone. It'll take about a minute, as you can see. And after the clone is done, let's create two more nodes. Actually, let's create one node for the starter. So we'll click clone and name this node RH. Actually, let's name it rel9 and rel9. Hit clone. I'll also rename this control node to ANS control. Rename it. Right now we've got two virtual machines. Let's start them. I'll hit run here and run here. This will power up these virtual machines. The first one is up. Let's click the link and check its IP address. For now it's unknown. I'll refresh this site, and it's still unknown, so we can go ahead and edit it. I'll select in interface type, I'll select direct attachment, click save. Actually, I won't be changing this setting because let's go ahead and leave it as virtual network. So the IP address is right here. Let me copy it, go to terminal, and SSH to this IP address type yes again, password, and exit. I'll check the IP address for the second virtual machine, so I'll return to virtual machines. Here it is, and select ANS rel9 and copy its IP address. It's .115. So I'll go to terminal again, SSH to the second virtual machine, yes, enter my password, and it's done. I'll exit for now. Now we are ready to configure these two virtual machines, and I'll start with control node. So I'll SSH to .205, clear the screen, and we'll first display the current host name. For this we'll type nm name CLI general host name. It's the local host, and now let's set that the host name to be control node. So I'll type nm CLI control node, and we'll need to perform it as administrator, so I'll type sudo in the beginning of this command. Now we'll need to reboot, so I'll type sudo reboot. It will take some time. Try to connect, add the password, and the name is changed. I'll exit from control node and connect to rel9 node. Let me clear the screen, and we'll do the same with sudo nm CLI general host name, and we'll name it rel9 node. We'll need the password for this operation and reboot the server again. Now when it's done, don't forget to take snapshots occasionally on your virtual machine. So to do this, I'll click Virtual Machines tab, go to Virtual Machines, and let's make a snapshot of Ansible control node first. So I'll scroll down and find this Create Snapshot and name it host name change. Actually, let's add it as description, and the name of this snapshot will be initial installation. It'll take a minute to create this snapshot. Go back to virtual machines and do the same for Ansible rel9. Scroll down, find snapshot, add the description and the name, initial. In this video, we'll install Vagrant on our rel9 virtual machine, and the first thing we want to do is we need to add the repository containing additional packages and development tools. So we'll run the following command: sudo subscription manager purpose dashes enable, and I'll paste this name, code ready builder for rel, and we need for rel9. I'll add my password. So first we refer to the subscription manager tool, which helps manage subscriptions and repositories on rel systems, and then we'll enable a specific repository, which is code ready builder for rel9. That is the repository that contains additional packages and development tools. So install and executing this command will enable this code ready Linux builder repository, giving us access to additional software and development tools. It'll take some time, about 2 or 3 minutes, and I'll pause video until it's done. Next, we'll install several packages for virtualization and development tools. So I'll type sudo yum install -y and paste the tools we need to install. So here we are installing virtualization hypervisor tools, development tools, libvirt development tools, and Vagrant itself. I'll hit enter. It will check server status, begin to download these packages from Red Hat Code Ready Linux Builder repository, and it says it can't find Vagrant because I forgot to add one more repository, which is Vagrant's repository. So I'll run sudo yum config manager add repo --, and I'll paste in this repo link. hit enter. Now we can run sudo yum install -y vagrant, searching for the package in HashiCorp repository. It's 146 megabytes in size. It's done, and we can install libvirt plugin. So we'll type vagrant plugin install vagrant -libvirt. It will take some time to install, and we get an error because we haven't installed this libvirt yet. So let's rerun this command, this one, and I'll exclude vagrant from here. It starts installing. There are 107 packages, so it will take some time. I'll click stop here and get back to it. Done, and we continue. Let's try installing vagrant plugin once more for libvirt. And now we need to modify group membership. So of a user named Shumi, it's my regular user on this system, with user mod command. So I'll type user mod -a uppercase G libvirt and my username. And we need sudo privileges for this. So I guess we are done right now. We can create a directory as mkdir, name it vagrant, for example, cd to this directory, create one more mkdir, let's name it rel9, change to this directory, and create a vagrant file. So I'll type nano vagrant file and paste the contents of vagrant file I've shown before to this newly created vagrant file. So it'll create two virtual machines using generic /rel9 vagrant box. It'll add IP addresses to these virtual machines and add the IP addresses to hosts file. But it doesn't matter right now. The main thing that we need to start this virtual machine with libvirt virtualizer. So I'll hit exit, Control X, Y, save the file, and now let's try running this vagrant file. So I'll type vagrant up. It should use libvirt virtualizer, and it's using it, and it's a great news. So it starts creating virtual machines. It'll need to download the box from this link. Now it's adding the box. It'll take some time to download this box, about 2 minutes or so. And after it's done, we'll have two virtual machines running on another virtual machine with rel9 system, and nested virtualization turned on this virtual machine. Now it finished downloading the image and is creating virtual boxes, virtual machines, vagrant boxes with name VM1 and VM2. It's uploading base box image as volume into libvirt storage. And now it started creating the virtual machines with different parameters, IP addresses, SSH settings, setting host name, and running provisioner and shell commands. And it's done. Great. So now we can try connecting to one of the virtual machines. For example, if we type vagrant SSH VM1, we'll be connected to Red Hat 9-VM1 virtual machine as a vagrant user, and it's great. We can start using this technology for quickly creating and destroying testing environments. I'll exit from vagrant SSH, my host rel9 VM, and that'll finish this lesson on installing vagrant on rel9 virtual machine. I'd like to thank you for viewing, and I hope that was informative. In this video, we'll take a look at installation of SUSE Linux and how to install a new version of OpenSUSE lib Linux. So to get OpenSUSE lib, go to download OpenSUSE lib website For this, type opensuse.org, and here you can find 2 versions. Tumbleweed, we can read about this version. As you can see, it's for having the newest packages that include but are not limited to the Linux kernel, Samba, Git, desktops, Office applications, and many other packages. And please note that it's the newest versions. And if we go back, we can find the lib version here as well. We can read about it by clicking more information. Here we can get the most usable Linux distribution and stabilized operating system with OpenSUSE's regular release. So for this lab, I'll be downloading the lib version, so I'll click Install lib, and I'll click Download. Now, after clicking Download, we'll get several options. The option for Intel or AMD 64-bit desktop, the option for UEFI, ARM 64 servers, IBM, these systems, and PowerPC servers. I'll select Intel or AMD 64-bit desktops, offline image. So I'm fine with this version. I'll click Download. Select Save As, and I'll download it to the default location on my PC. It's Downloads location. Click Save. That'll take some time to download because it takes 4.3 gigs of RAM, of space. So the options are offline image and network image. If you want to perform the installation via network, you can download this version, network image. It's very small, 200 plus megabytes, and experiment with this one. Now, as for minimum system requirements, you need any AMD or Intel processor, 64-bit processor, 1 gig of RAM, and at least 1.5 gigs of RAM when using online repos, and 4 gigs of RAM or more is strongly recommended by SUSE. So the best is to have 4 gigs of RAM. You also need 10 gigs of available disk space for minimal installation and 16 gigs of space for a graphical desktop, and that is recommended by SUSE. And it also supports most modern sound and graphic cards, so if you want to follow along, I guess it won't be a problem. Now, as for my virtual environment, I'll be using Hyper-V hypervisor, so I switched to this hypervisor, as you can see, with one node, which is Nuke, and here I'll be creating a virtual machine for the lab. And by the way, let me shut down these 2 virtual machines which are in running state. If you want to follow along, you can install Hyper-V Manager on your Windows 10 or Windows 11 Professional or Enterprise version. It's included in this version, so to do this you need to type in the search window Optional and find Manage Optional Features, search for Hyper-V in the search window. Here in the upper left corner, as you can see, I've typed Hyper, and you'll find this Turn Windows Features on or off. Click it and you'll find this Hyper-V folder. You can select it and click OK to install. After installation, your computer will need to be rebooted. As you can see, I've already installed this feature, so I won't be doing it. You can also go to your browser and search for VirtualBox. Go to Oracle VM VirtualBox site and download VirtualBox software for Windows host, macOS host, or Linux distributions. That's completely free and easy to use. When you install VirtualBox, you'll click New and create a new virtual machine with appropriate configuration. So my download is ready. As you can see, I've got this green arrow here, and we can find this OpenSUSE lib 15.6 DVD ISO image. So let me switch to Hyper-V Manager, right-click my node, select New, Virtual Machine, name it OpenSUSE 15 _ VM1. That will be the name of my virtual machine, but the name of the host could be different. I'll be storing it on C drive VM folder. I'll click Next, select Generation 1 here. Let's provide it 4096 megabytes of RAM. That'll be 4 gigs of RAM. Click Next. We'll connect it to external switch. Click Next. I'll create a virtual hard disk for this virtual machine. Click Next. And I'll install it from media and select imagefile.iso. That's the file I've just downloaded. It's OpenSUSE lib 15.6 as you can see. Click Next and click Finish. That'll create a virtual machine. And here it is. The virtual machine has been successfully created. Now to use an external switch, you'll need to create it first. So to create a switch, you right-click on your host, go to Virtual Switch Manager, and click Create Virtual Switch. You give it a name. For example, you could name it Internal or Net. Then you want to select Internal, Private Network, or External Network. And when you are done, click OK. As I've got my external virtual switch here, I'll click Cancel and go back to the virtual machine I've just created. So let me double click it and start this virtual machine. It will start the installation process, so I'll need to select Boot from Hard Disk Installation, Upgrade, or More options. Let's take a look what we've got in More. We can rescue system, boot Linux system, check installation media, and perform memory test. I'll hit Escape and get back to the main menu and select Installation. Hit Enter, and that'll start the installation process of OpenSUSE Linux. As you can see, it's loading basic drivers, and while it's doing so, let me check the media here. So if we click Media, go to DVD drive, we can find that our OpenSUSE.iso file is inserted into DVD drive, and if you want to eject it, you click Eject, or you can insert another drive. Now the initial installation process has completed, and we've got language, keyboard, and license agreement selection window. So we can select language here. I'll leave as a English US as default, and English US keyboard layout as well. We can read through the license agreement, and when we are done, we can click Next. Now we've got this YAST2 online repositories window pop up. Enabling the online repositories during installations gives you access to all software that does not fit on the installation media anymore. Additionally, those repositories might contain updated software packages. So I'll select Yes for sure to activate online repositories now. And we get the list of online repositories. We can add more online repositories here, but I'll go ahead with the defaults and I won't be selecting any new repositories, and I'll click Next. As you can see, it has added all the repositories selected, and now we can select system role. So we can select desktop environment here, KDE Plasma or GNOME, or desktop with XFCE, generic desktop, and server. For this particular system, I'll select the first available option, that's desktop with KDE, and click Next. Next is the partitioning options, and we get initial layout proposed with the default guided setup settings. And as you can see, changes to partitioning will be the following. Create GPT on dev SDA, create partition / /dev/sda1, that will be as BIOS boot partition, create /dev/sda2. The main space goes here for the root, then the next partition 2 gigs for swap, and 10 sub-volume actions. We can see the details and click it. So sub-volume 1 is the main space on SDA2, then we'll create /var partition /usr local /tmp and so on /home. I'm okay with the defaults and I'll click next. Now we can select clock and time zone here. So let me click this time zone and find, yes, first we need to select region. Let's select Europe. Now we can select the time zone needed. Click next when done and get ready to create a new user. I'll create my user. We can provide the full name here and username. I'll provide my username and password. Let's try some very simple password, just 123, and see if it takes this password. I'll click next, and it informs us that the password is too simple. It is way too short. Really use this password? Yes, I'll be using this password because that's for demonstration purposes, but my suggestion to you to create some complicated long password containing digits, special characters, uppercase, and so on. I'll click yes here, and we get installation overview for booting, software installation, default system target. As you can see, it's a graphical mode, system and hardware settings, security, network configuration. As you can see, we've configured we haven't configured networking, but the system auto-configured networking with DHCP on ETH0 interface and host name set by DHCP. We can change all these settings later on. For now, we accept all the settings and go on with installation. So I'll click install, confirm installation, click install again, and that'll start the installation. It'll take some time, and when it's done, I'll get back to you and we can continue with learning OpenSUSE Linux distribution. In this demonstration, we'll install several Linux distributions with the help of Microsoft Linux subsystem. So I've opened Microsoft Store on Windows 11 client and I'll search for Ubuntu, and I can select the distribution and version I'd like to install. For example, as you can see, I've got two versions installed already, Ubuntu and Ubuntu 22.04. Let's install Ubuntu 18.04. So I'll click this Get button and it'll start acquiring this distribution. Now, we can install Debian as well. So I'll click Get on this and let's search for Fedora Linux for demonstration purposes. I'll type Fedora and here it is. I'll click on Fedora WSL link and get it as well. As you can see, Debian is still being installed and Ubuntu 18.04 installed already. We can click open, but I'll wait a minute until all the distributions are installed. Debian is done as well, and Fedora has been installed. So now if we open PowerShell, or I'd say terminal, Windows 11 terminal, and if we type, let's say, Ubuntu, that will launch the Ubuntu Windows Linux subsystem, and in this particular case, it will launch the version which is named Ubuntu. As you can see, it is launched now, and we can start working in Ubuntu because I've configured it before. But if we exit, let's make it larger, clear the screen, And let's say we want to start Fedora Linux. It'll start installing this particular distribution, and I'll need to configure it as I'm running it for the first time. So I'll need to provide Unix username, let's say my regular username, and password, retype password, and installation is successful. We can start using Fedora Linux. Let's exit it and we'll launch Debian Linux. So I'll type Debian and that'll start installing this distribution for the first time again. You need to configure it just once. Then you just type Debian and it starts the distribution. So again, I'll type my regular username and provide password. Retype password. Password's not matching. Let's try again. Now the password is updated successfully and we can start using this particular distribution, and we can check it with cat etc / and we'll use asterisk here and type release and one more asterisk, hit enter, and as you can see it's Debian distribution version 12, so it's quite convenient and handy to use this Windows Linux subsystem in case you're using Windows as your host or client machine. The story of Linux is a fascinating journey that intervenes the development of Unix, the growth of unique hacker culture, and the birth of a revolutionary open source operating system. To truly appreciate Linux, you must delve into its roots and understand the contents in which it emerged. Our journey begins in the mid 1960s with the Multics project. Although this ambitious time-sharing system was ultimately abandoned, it laid the groundwork for what was to come. In 1969, Ken Thompson, drawing inspiration from Multics, created Unix. This groundbreaking operating system was soon complemented by Dennis Ritchie's invention in the C programming language. The marriage of Unix and C proved transformative, but by rewriting Unix in C, Thompson and Ritchie achieved something unprecedented: a portable operating system, and this probably allowed Unix to run on various hardware platforms, a feature that would prove crucial in its widespread adoption. As Unix gained traction, its development took an interesting turn. AT&T, constrained by a federal court order, couldn't directly market Unix. Instead, they sold the source code to various companies and provided free copies of Unix to universities. This strategy inadvertently fostered a collaborative environment that would later influence the open source movement. One notable outcome of this period was the Berkeley Software Distribution, or BSD, developed by the University of California, Berkeley. Meanwhile, companies like Sun Microsystems began offering Unix on more affordable hardware, further expanding its reach. Now, parallel to Unix's development, a unique subculture was forming: the hacker culture. It's crucial to understand that in this context, hacker refers to curious, knowledge-seeking individuals and not malicious cybercriminals. At the forefront of this movement was Richard Stallman, who championed the free sharing of knowledge. His efforts culminated in a formation of the Free Software Foundation, or FSF, in 1985, and the launch of GNU project in 1984. These initiatives were pivotal in promoting collaborative software development and the idea of free open source software. Now, some words about hacker culture principles. The hacker culture operated on a set of principles that would later shape the development of Linux. This included viewing users as co-developers, valuing peer recognition over monetary gain, and emphasizing coordinated cooperative development. The culture also prioritized the utility of software over its cost and encouraged constructive feedback rather than personal attacks. And in 1991, the stage was set to a revolution. Linus Torvalds, a Finnish student, began developing Linux as an experiment to improve Minix, an educational version of Unix. Crucially, Torvalds released Linux under the GNU public license, opening the door for global collaboration. This decision proved to be a catalyst. Developers worldwide, steeped in the hacker culture and armed with experience from projects like GNU, rallied around Linux. The open source nature of the project allowed for rapid, collaborative development that would have been impossible in a closed, proprietary model. As Linux matured, it began to diversify. Multiple distributions emerged, each tailored to specific needs or philosophies by all sharing the same core. Popular distributions like Red Hat, Debian, and Ubuntu became household names in the tech world. The year 1998 marked a significant milestone with the coining of the term open source software. This concept, deeply rooted in the hacker culture and exemplified by Linux, began to gain traction in the broader tech industry. Large companies, recognizing the potential of this collaborative model, started to support Linux development. As we moved into the 21st century, the focus of Linux development began to shift. While it continued to be a powerful option for desktop and server environments, increasing attention was paid to embedded systems, mobile devices, and cloud computing. This adaptability has been key to Linux's enduring relevance. It's important to understand that Linux is not just an operating system. It's a philosophy of software development and distribution. Linux stands out in the software landscape due to its unique licensing model. Unlike proprietary operating systems, Linux is freely developed and continuously improved by a large community of software developers worldwide. This collaborative approach is at the heart of what we call open source software, or OSS. Let's delve a bit deeper into the concept of open source software. At its core, OSS is characterized by three key features. It's freely developed and continuously improved. The source code is available for anyone to read, modify, and redistribute. And it's distributed free of charge. But what exactly is source code? Think of it as the ingredients which programmers use to create software. In the case of OSS, these ingredients shared openly, allowing anyone to see how the software is made, suggest improvements, or even create their own version. This open approach leads to some significant implications. For one, it fosters rapid software development through widespread collaboration. Imagine thousands of chefs around the world working together to perfect a recipe. That's essentially what happens with OSS. Now, the open source model has far-reaching implications for software development and the tech industry as a whole. Let's examine some of this. First and foremost, OSS enables rapid software development through collaboration, with developers from around the world contributing their expertise, bugs are often identified and fixed quickly. This global effort also means that software features can evolve rapidly based on users' needs. Another interesting application is how OSS changes the perceived value of software. In the OSS world, value is based on usefulness rather than price. This shift is perspective challenges traditional business models in the software industry. However, this raises an important question. How can a product that is distributed freely generate revenue? This challenge has led to innovative business models in the open source world, which we'll explore further in our course. Now, to fully understand Linux licensing, it's crucial to be aware of the different types of software licenses that exist. Let's break them down. First type is open source. As we've discussed, this includes software where both the source code and the software itself are freely available. Then closed source. In contrast to open source, closed source software doesn't make its source code available. This is often commercial software that you have to pay for. Then we've got freeware. This is a type of closed source software that's distributed for free, but without access to the source code. And shareware. This model allows free use initially, but requires payment after a trial period or to unlock full features. Understanding these different license types help us appreciate the unique position of Linux in the software ecosystem. When it comes to open source licenses, there are two main categories to be aware of. Copyleft licenses like the GNU General Public License and permissive licenses such as BSD, MIT, and Apache license. Linux itself adheres to the GNU General Public License, or GPL. This license stipulates that the source code of any software published under it must be freely available. Moreover, if someone modifies that source code, they must also distribute their modified version freely. This ensures that Linux remains open and free, fostering continued collaboration and improvement. On the other hand, the spectrum we have closed source license. These come in various forms. First, commercial software. This is typically sold with the manufacturer's label and includes restrictions on distribution. And again, freeware and software. Freeware, while distributed for free, the source code remains unavailable and there may be restrictions on redistribution. And shareware, this model offers free initial use but requires payment for continued use or access to full feature. It's important to know that even though freeware and shareware are distributed freely, they are not considered open source because their source code is not available for modification and redistribution. In this presentation, we are going to explore the various distributions available. Let's begin by understanding what a Linux distribution is and why they are important. Linux distributions, often called distros. These are complete operating systems built around the Linux kernel. They package the kernel with various open source software to create a fully functional system. This approach saves time and effort compared to building a system from scratch. Moving on to the components, let's break down what typically makes up a Linux distribution. The Linux kernel. This is the core of operating system, managing hardware resources and providing essential services. Then common function libraries. These provide reusable code for application. Open source software packages. These include utilities, applications, and tools that make the system useful for various tasks. Then Package Manager. These tools help install, update, and remove software efficiently. And of course, desktop environment for distributions aimed at desktop users. These provide the graphical user interface. Speaking of desktop environments, let's explore some popular options. GNOME and KDE are the two main competing environments. GNOME resembles macOS, while KDE is more similar to Windows. However, these aren't the only choices. Cinnamon, derived from GNOME, offers a user-friendly experience, while XFCE is perfect for systems with limited resources. It's worth noting that most distributions allow you to install multiple desktop environments, giving you the flexibility to choose based on your preferences and system capabilities. Now let's discuss an essential component of Linux distributions, which is package managers. These tools are crucial for managing software on your system. They keep track of installed packages, handle dependencies, and make it easy to update or remove software. Some common package managers include RPM, it's a Red Hat package manager, DPM, Debian package manager, Pacman used in Arch Linux, Zypper found in OpenSUSE, and Portage used by Gentoo Linux. Additionally, there are sandbox-based package managers like Snap, Flatpak, and AppImage. These install software components as a single unit, enhancing security and reliability. An interesting aspect of Linux distribution is how they handle the kernel. While all distributions use the same core Linux kernel, many modify it to include specific fixes and optimizations, and these are called distribution kernels. For example, a kernel version might look like this: 5.15.0-70.5.1.el9, and so on. Breaking this down, 5.15.0 is the base Linux kernel version. 70.5.1 is a distribution release. L9_0 indicates it's for Red Hat Enterprise Linux 9. And ARC64 specifies it's for 64 ARM architecture. This name convention helps identify the specific kernel version and its intended use. Linux, known for its versatility and robustness, and it has found its way into various aspects of modern computing. In this lesson, we'll explore some of the most common uses of Linux across different domains. While Windows and macOS dominate the personal computer market, Linux has carved a significant niche in specialized workstations. Let's look at some of key areas where Linux workstations excel. The first area is cybersecurity. Many cybersecurity professionals prefer Linux for its powerful tools and customizability. Distributions like Kali Linux come preloaded with a suite of security and penetration testing tools. The next area is software development. Linux provides a rich set of open source development tools and frameworks, making it a favorite among developers. Many major computer vendors now offer developer-focused laptops with Linux pre-installed. Of course, performance on older hardware. Linux often runs faster than Windows or macOS on the same hardware, making it an excellent choice for extending the life of older computers. This is particularly useful in environments with limited budgets for upgrades such as schools. And open source alternatives. Linux uses a wide range of open source software alternatives. For instance, LibreOffice can replace Microsoft Office, and Krita can serve as alternative to Adobe Photoshop. Now, Linux truly shines in server environments, offering a wide array of services. Let's explore some of the most common server roles for Linux. The first and foremost, web services. Apache and Nginx are two of the most popular web server software packages available for Linux. These powerful and flexible tools can handle everything from small personal websites to large-scale enterprise applications. Then DNS services. The Berkeley Internet Name Daemon or Bind is a widely used DNS server software that comes with many Linux distributions. It plays a crucial role in translating domain names into IP addresses, making it easier for users to navigate the internet. DHCP services. Linux can easily function as a DHCP server by adding and configuring the DHCP daemon, which is DHCP-D. This service automatically assigns IP addresses to devices on a network, simplifying network administration. Then time services. Linux systems can provide time information to other systems using NTP via the NTP daemon or NTP-D or cron NTP daemon or cron-D. Accurate time synchronization is critical for many network operations and security measures. Then we've got mail services. Popular mail transfer agents or MTAs for Linux include SendMail, Postfix, and Exim. These services enable businesses and organizations to manage their own email systems efficiently. File and print services. Linux excels at sharing file and print resources on corporate networks using services like NFS, CAPS, and Samba. This allows for seamless file sharing and printing across different operating systems. Of course, we cannot forget about database services. Both open source, for example, PostgreSQL, MySQL, MariaDB, and proprietary, for example, Oracle database. These database management systems are available for Linux. These powerful tools can handle massive amounts of data and complex queries. Then we've got authentication services. Linux can be configured to work with various authentication services, including Kerberos-based systems like Microsoft Active Directory or Apache Directory. This ensures secure and centralized user authentication across an organization. And last but not least, certificate services. Linux serves as certificate authorities or CAs using software like OpenSSL or OpenXPKI. This serves you in a stable and robust manner, and these services are crucial for implementing secure communications and digital signatures. Now, Linux dominates the supercomputer world, primarily due to its scalability and customizability. Key concepts in Linux supercomputing include Beowulf clustering. This is a common method of Linux clustering where multiple computers work together to solve complex problems. It's named after the Old English epic poem, symbolizing the power of many working as one. Then parallel supercomputing. Tasks are broken down into smaller units and executed simultaneously on multiple machines. This approach allows for solving extreme complex problems that would be impractical on a single computer. And Message Passing Interface, or MPI. These are frameworks like OpenMPI, allowing for efficient communication between nodes in a supercomputer cluster. This is crucial for coordinating the work of hundreds of thousands of individual computers. Linux's dominance in supercomputing is evidenced by its presence in the majority of the world's top supercomputers. Its open source nature allows for fine-tuning and optimization at every level, from the kernel to application software. Now, of course, network devices. Linux is widely used in various network devices, providing essential services for network infrastructure. And here we've got routing services. Linux can be configured as a router to interconnect different networks, and its flexibility allows for complex routing configurations and protocols implementation. Then, firewall and proxy services. Linux has built-in firewall capabilities such as AP tables, NF tables, and it can run proxy servers like Squid. These services are crucial for network security and efficient resource utilization. And advanced security services. Many security appliances run on Linux, providing services like intrusion detection, VPN functionality, and centralized logging. Examples include Next Generation Firewall or NGFW and Unified Threat Management or UTM system. The use of Linux in network devices allow for great customization and often results in more cost-effective solutions compared to proprietary hardware. And finally, mobile and IoT devices. Linux has made significant inroads in the mobile and IoT space. First off, Android. The world's most popular mobile operating system is based on the Linux kernel. This demonstrates the scalability of Linux from supercomputers down to handheld devices. Then, alternative mobile operating systems. Linux-based alternatives to Android include Postmarkets OS, Ubuntu Touch, Mobian, and Manjaro. This offers users more control over their devices and often prioritize privacy. IoT devices. Many IoT devices, from smart home gadgets to industrial sensors, run on custom Linux distributions. The lightweight nature of certain Linux distributions make them ideal for devices with limited resources. And last but not least, Raspberry Pi. This popular single-board computer runs various Linux distributions and is widely used in education, prototyping, and hobbyist projects. It's a great example of how Linux enables innovation in small, low-power devices. Let's explore the fundamental concepts of cloud computing and Linux's pivotal role in this technology. As we delve into this topic, we'll uncover the various types of cloud configurations, delivery models, and the process of deploying web applications in cloud environments. To begin with, let's get back to the early days of the internet. In the 1990s, the World Wide Web, or 3W, emerged as a collection of interconnected web services hosting static websites. Fast forward to today, and we find ourselves in the era of the cloud. But what exactly is the cloud? Simply put, the cloud is a worldwide network of servers that host dynamic web applications. Unlike the static websites of the past, these web apps process and communicate both data and media to users in complex ways. Examples include search engines, office suites, video streaming services, and even the back-end software that powers our smartphones and smart assistants. Interestingly, the transition from 3W to the cloud was largely fascinated by open source technologies, particularly Linux and the Apache web server. This open source foundation has continued to shape the cloud landscape, with most web apps in the cloud today running on Linux systems using open source web app frameworks. As we delve deeper into cloud computing, it's crucial to understand the different types of cloud available. There are three main categories. Public cloud. These are cloud servers available on the internet that can be rented by individuals or organizations. Examples include Amazon Web Services, Google Cloud Platform, and Microsoft Azure. Then there is private cloud. In contrast to public clouds, private clouds consist of cloud servers used exclusively by a single organization. These can range from a single server to entire data centers, depending on the organization's need. And hybrid cloud. As the name suggests, hybrid clouds combine elements of both public and private clouds. For instance, an organization might use its private cloud to regular operations but redirect traffic to a public cloud during peak usage to handle the overflow. Now that we've covered cloud types, let's explore the different ways organizations can utilize cloud resources. These are known as cloud delivery models. And the first model is infrastructure as a service, or IaaS. In this model, the cloud provider offers virtual machines that you can manage like any other operating system. You are responsible for installing, managing the web apps that users will access. The next one is Platform as a Service, or PaaS. PaaS allows you to run web app containers in the cloud. These containers don't contain a full operating system, but instead rely on container runtime software to access the kernel of the underlying operating system. And finally, software as a service, SaaS. With SaaS, the cloud provider manages all aspects of the infrastructure. You simply provide the web app and the provider executes. Now, it's worth noting that Linux plays a crucial role in all these models. Due to its open source nature and cost effectiveness, Linux is often the operating system of choice for cloud providers, whether they are offering AAS, PaaS, or SaaS solutions. Finally, let's discuss how new versions of web apps are deployed in cloud environments. This process is known as a continuous deployment, or CD, workflow and involves several steps. Step number 1. Developers push new code to a repository server. Its name is continuous integration, the name of this step. So developers push new code to a repository servers, and this is named continuous integration. Step number 2. Orchestration software obtains the new version and compiles it. Step number 3. The compiled app is sent to a build automation server. And finally, the new version is deployed to cloud servers. So it's often used as an abbreviation CI, CD-CI. So continuous deployment, continuous integration. This process is managed by DevOps professionals who bridge the gap between development and operations. Interestingly, the servers involved in this process, namely code repository, orchestration, and build automation, often run on Linux as well, further emphasizing Linux's importance in cloud computing. In conclusion, Linux's role in cloud computing is far-reaching and fundamental. From powering cloud servers to facilitating efficient workflows, Linux has become an integral part of the cloud ecosystem.